Hey guys, we received multiple grievances about the sound quality of many of our previous videos from multiple viewers over a long period of time. We paid serious attention and as a solution, we are republishing all the episodes from Python in VLSI series all together in this marathon episode by digitally remastering the audio. In this marathon, you will learn why learning Python 3 is very useful in VLSI. Next, you will learn how to install Python 3 in both Windows and Linux operating systems and use it along with Geany IDE, which you will also learn to install. Next, you will be introduced to the basics such as for loop, while loop, if-else blocks, various operators, various data types such as int, float, and strings in Python 3. Next, you will learn all about importance of regex in VLSI through Python 3 with examples. Going further, we will dive into the EDA automation using OS and sys module through various examples. Next, we will cover various data structures in Python 3 using thorough examples. Next, we will cover the function and module available in Python 3. Finally, we will deep dive into the object-oriented programming using Python 3 through various code examples. This is a must-have marathon for all the VLSI aspirants. So stay tuned, stay focused.
Hey guys, welcome back to the first episode of Python in VLSI. In today's episode, we are going to discuss the below points. First, we will talk about why VLSI adopted the Python. So, we will talk about the reasons that are existing in today's VLSI industry that triggered the engineers to include Python. Next, we will talk about where Python is used in VLSI. We know Python is used in VLSI. However, we will go in detail the areas where the Python is used. Next, we will start deep diving by invoking the interactive interpreter. Next, we will give you the Hello World script in Python in two different ways. Next, we will talk about the comments that helps the VLSI engineers to segregate different part of the code and write the description of that particular part to the comments. And hence, we will talk about single line comment as well as multi-line comments. Next, we will go for the list of reserved keywords so that at very beginning, you know all of these keywords are reserved in Python and you cannot use them anyhow in your own variable declaration. Hence, we will conclude our episode. So that's the menu for today. Without any further delay, let's begin. Why VLSI adopted Python? That means why VLSI engineers prefer to use Python. Python is a powerful programming that combines remarkable power with very clear syntax. By birth, Python is an object-oriented language. Like you know the difference, right? C is a procedure-oriented language, whereas C++ is a object-oriented. Similarly, the Perl is procedure-oriented by birth. However, you can do the object-oriented programming and we have episodes on that in the Perl playlist. In contrast, Python from birth is a object-oriented programming language and we can use its power for scripting in VLSI. Python is an interpreted, interactive, object-oriented programming language. So it's a scripting language. We can call it a programming language. However, it is not a compiled one. It's a interpreted one and hence it has an interactive shell. The reason of using the interpreted scripts in VLSI is that we don't spend time for the compilation and other things. We just write the script with the syntax and semantics and everything is okay. Then we go for using that script. There is no point that you compile and generate a binary and then use it. No, there is nothing like that. So it's a very easy way. It incorporates modules, exceptions, dynamic typing, very high-level dynamic data types and classes. So this is the inner resource of the Python that we have just pointed out. It has interfaces to many system calls and libraries, and it is extensible to C or C++. So that is another part where generally the CAD people who are doing the automations in VLSI industry, basically a CAD engineer job role, those folks sometimes does have to use the proper software methods to assemble a large amount of scripts for a particular target goal by the design engineers, and that particular time you can have the benefits of Python. It is also usable as an extension language for applications that need a programmable interface through APIs. You know that Tcl is used to create APIs. Those APIs are used in the tool shell. Similarly, Python is used nowadays for many of the VLSI tools and flows, and it has a large library so that the APIs can be developed, and hence versatility and the flexibility of Python is there. Finally, Python is portable. It runs on many Unix variants including Linux, macOS, and Windows. That means you write a script in Python, maybe on Windows, which is your home PC, and you can copy it onto your pen drive and take it in your office computer, where from using the Linux, and you port that into the Linux, and you can use the code as is. So there will be no changes. So that is the portability factor among different operating systems. Python is very stable, so this is another important factor. If a scripting language or programming language is not stable, it is not going to help a production level engineering need. So the programming or the scripting language has to be very stable, and Python has it. New stable releases have been coming out every 16 to 18 months. Generally, based on the development phase, it is a regular interval which we get the Python release. When I learned Python 2.7. Now this series, when I am broadcasting here, latest stable, I think it is 3.8. So we will learn here Python 3. There is a lot of syntax change among Python 2.7 versus Python 3. I am not going in the benchmarking. However, in this series, we will focus on Python 3 coding. There are probably millions of Python users worldwide. So this is another thing. Python nowadays used vastly among vast application landscape. So that is not only limited to the VLSI. It can be anything. It could be an extension to a web browser. It could be something that needs to run on a web, something like that. So there is a lot of opportunities for the Pythons. If you have a script written in Python, you may include something from the external already developed repository like GitHub. From there you can get something and you can include it readily. So that is the beauty of the Python. Enhancement requests are handled through Python enhancement proposals, and this is another good thing. So if you have a language where if you request something, that means something that is needed by you as a VLSI engineer, and you are still not getting into any of the modules of the Python. So either you can write it, even when you are writing a module for your need, you are lagging something and that is not existing as an inherent property in Python. So you can request that to this particular enhancement request channel and get the desired results maybe in the proper release cycle, that is 6 to 18 months. So within that you will get it. So that is all the reasons that the VLSI adopted Python. We are done here in this slide. Let's move on to the next slide, where Python is used in VLSI. In this slide, we will talk about the Python applications in VLSI. Previously, we talked about the Python's basic characteristics because of which we choose Python in VLSI. And in this slide, we will talk about the areas of VLSI where the Python is. Obviously, this is not an exhaustive list. There can be many applications even beyond the things we are discussing in this slide. Please be open in your mind. Automating all steps such as compilation, elaboration, and simulation. Recently, we have published an episode on Makefile that is used as the inherent automation for these steps. However, there can be scenarios where later needs are filled up by Python, and hence the everything, that is the automation of compilation, elaboration, and simulation, those are taken care by Python. There are many steps as well as PDK or DK dependencies which we can call through Python. We have an entire episode on PDK or DK, what is called. It's in the FAQ playlist. In case you don't know, please go ahead and watch it. Source code paths, environment variables, and tool path and licenses involved in compilation, elaboration till simulation. So there are a lot of complex things happening here. So a lot of things have to be reset in your terminal to do the desired software run for compilation, elaboration, and simulations. All those prerequisites can be well handled by the Python. It can be difficult to source them and redo it multiple times manually during the HDL design and primary test stage. For these reasons, as well as some other reasons are there why the Python is used in the front-end VLSI. So front-end guys love Python. They use it in a very extensive way. Next point is automating the code or test bench generation. It might be happening that you have a particular design series in your company and you want to generate the test bench. So Python routine has been written so that you can write that in a Python code how to generate the test bench, and there will be manual tweaks to that as per your design change. Those things can be well handled by the Python. Text parsing from log files or input or output or any file. This is a very important thing. When we run a tool, we generate a log file, and we have to carefully parse the log file for any warning or error or any other messages. It could be an info message also. That is very much relevant to a VLSI designer. All those things can be parsed and processed by the Python in very sharp manner. And here we talk about the input and output files. Many times the QA engineers do have to use the Python for doing the QA and QC, that is the quality check and quality analysis for the input and output files of any VLSI IDE tool. For that, Python is also used. Append or modify some lines of many files with a single command. Generally, there are a lot of files here and there in different locations, and within that, for a particular set of design, you have to include one or more line in all of the files, which is corresponding to the design under consideration. So that automation, that modification can be done through a Python script. Python can be used for developing parameterized layout cells, that is py cells, from PDK or DK. This is another thing. You can learn about the PDK and the DK from the FAQ playlist. We have an entire episode on that. Now, the py cells are particular cells which are kind of unit cells in the PDK DK library. These are written in Python and they are scalable as they are parameterized. That means if we change the parameter, we change the different ratios of that particular cell, whether that could be height or whether that could be the number of inputs or whatever is there configurable through the Python module that has been used to define the py cells. These can be configured across various technology nodes. So the py cells may be written in a general format, and when we change our technology node, we can tweak some of the parameters and make the py cells ready for another technology node. So that is the beauty of these cells, and here the Python is also used. So you must have a knowledge of Python to tweak these things. So not only front end as well as in the PDK DK, that is maybe in the back end or maybe in the IP generation case, that part of the VLSI also use the Python. So wide range of audience is there in VLSI who use the Python. We are done discussing this slide. Let's move on to the next slide. Invoking interactive interpreter. Generally, any of the scripting language has an interpreter that interprets line by line code of the Python. So here I will simply show you. However, in our entire course, we will use Python scripts rather than the interpreter, because interpreter, everything is volatile. In script, you can change in the script and then again you can source it and then you get the changed result. For interpreter, you have to write every line, and that is a very hectic for a VLSI engineer. So just for your knowledge, we will show you the interpreter here. And in our entire course we will use the scripts. This is my Linux prompt of my laptop, and here we type Python 3, and when we hit enter, these all lines are displayed. Let me clear it and show you again. So when we type Python 3 in our command line in the terminal of my laptop, this shows. So Python 3.810, and this is the time on Linux, and we have GCC this on Linux. These are the versions. Here it is giving some information and making the prompt ready. So here you can type any of the Python command and run it. And here while generating this, I tried to type exit. It doesn't take exit. Instead, it takes exit to exit the prompt. So this prompt will be terminated in your Linux terminal or Unix terminal by this exit command of Python. Or you can type Ctrl D. That is the thing. This is the way you can enter or exit in Python. In case you want to try out any single command, you can use it. However, as a VLSI engineer, you are trying at 5 o'clock in the evening and maybe 7 o'clock you are leaving the office. But in hurry, if you close the terminal, right, all the code is gone. So better you write a script and run. That we will show in subsequent slide how we are writing the scripts. And entire series we will use Python scripts, not the interpreter. But the interpreter works behind and that actually process the Python code. The knowledge of the Python interpreter is a must for you, and that's why this slide is kept here. We are done discussing this. Let's move on to the next slide. Hello World in Python. So Hello World generally is the first program of any programming language that you come across, whether it is C, whether it is Perl, whether it is Tcl, or now we are in Python. So here is the simple code of the Hello World. First, you have to write #bang, then the path of the Python 3 binary. We will talk about Python 3 in this series, hence we will write Python 3 all along. So #bang, this is the path of the Python. You can get this using the command which in your Linux terminal, which Python 3. So that will result out this, and then you can copy this back in your text file. So here you are using a notepad or gvim, and next we write print, then within first bracket we write within the double quotes hello world. So this is a simple command, and when we are in our terminal, we save it in hello.py name. This is the name of the file, and we write /, that means in the executable. Obviously we have to change the permission as a +x chmod +x to this hello.py. So hello.py, when it is run, it gives the hello world output in the terminal. This is the one way of writing the Python. There is another alternative way of writing, and here it is. We write the first line as #bang user bin environment. So to get this path, you have to type which env and it will get, and then we give a space here in between, and then we write Python 3, and then we write again the print hello world command. However, if we compare these two, I will prefer, and I will also ask you to prefer this one, because this is a straight call to the Python 3 interpreter rather than using first binary and then calling the second binary. This is the preferred way. Anyhow, there is no restriction. You can even use it if you want. And similarly here we have how we call it. Then we write Python 3 binary followed by hello.py. So here you can see the comparison here. Here is an extra effort that you are writing here Python 3, again you are using the Python 3 binary, then hello.py, and then you get the hello world output. So this is a much more short and sweet way of using the Python script. So in our entire series, we will prefer this method of using Python 3. Here we are done discussing the hello world programming Python. This is a very simple program. You can go ahead and try it. I have an episode on Geany. It's in the FOSS playlist. Please watch that, because Geany is a very good IDE, that is the integrated development environment. There you can write the code in the upper half, and in the lower half there will be terminal, and you can execute it. And then again you can change the code in the upper half and run the code in the lower half. So this is the very useful thing in Geany. Geany can be used for any programming language. So here we are done discussing. So let's move on to the next slide. Comments, how to. So here we'll talk about the comments. Now the comments is a very important thing in VLSI, because when you are writing a particular subroutine or you are a code block, what that code block does and where that is used and whatever versions of PDK that it implies to, all these information have to be logged onto the code, so that whoever the developer of the code, rather than the developer, if any other engineer is looking into the code, he must or she must understand that particular message and interpret the next code block that is corresponding to that particular comment in a right way. So single and inline comments are done with the hash. Single line comment is like that. Here it is the single line comment, and if we have a Python code and after that we write a hash and then we do write something here, that will become the inline comment. So both are taken care by the hash a bare hash, that means we don't have the X here, or it's I think the first quote. Okay, so bare hash symbol will do a single or inline comment, and in case of multi-line comment, it starts with I think 3 here. It's not a single, it's 3 double quotes, and then we have the text followed by the closing 3 double quotes. So for a multi-line comment, you can start the multi-line comments with 3. Remember, number is 3, and here it is number is 3. It's not 2 or 1, so it is 3. In between whatever lines are there, they will be treated as the multi-line comments. Multi-line comments can be written between triple double quotes and often used as a function or and module comment. So which I just spoke about. As a VLSI engineer, you are developing a Python code for your company, and that code has to be interpreted or read by other engineers, and for those you have to pass on to some message, so that guys, this is a block that does this and this and takes this and this as the inputs and gives that and that as the output. All that messages can be put in a multi-line comment inside the Python script that you are writing for your company. So here we are done for the comments part. Let's move on to the next slide. The reserved keywords. So this is a very important. However, you may ask that why you keep these things we are not using, but you must be well knowledgeable what you cannot use. You should be well aware that what you can use, but you should be double aware what you cannot use. And here we will give you those examples. So you can see all these are keywords: false, none, true, and, as, assert, async, await, break, class, continue, def, del. So all these things are reserved keyword in Python, and you cannot use them as a variable or any function name or any module name or anything like that. And here it is elif, else, except, finally, for, from, global, if, proc, import, in, is, lambda, non-local, not. All these are reserved keywords. And we complete the list here: or, pass, raise, return, try, while, with, yield. So all these are reserved in Python, and their purpose are there. You can get their purpose and operating instructions from the Python manual that is available in the Python site or Python documentation. Rather than it is called a documentation, not a manual. So you can use the documentation to understand all these keywords and their usage and restrictions. But for your custom code, you cannot name the code or name any module or any script's name as these words. All these words you cannot use for your custom naming. Rather than you can use them in your code as their usage is. There is no restriction, but you cannot use them as a custom naming of your script, of your module or function, anything that you are writing by yourself. So here we are done discussing for the reserved keywords. Hey guys, welcome back to the computer screen. Today we are installing one very useful and lightweight integrated development environment. As you can see here, we are on the URL geany.org. This is our IDE, integrated development environment. That means you can code here, and at the same time you can run the code in the same window. So you don't have to switch in between a text editor and the command terminal to do the coding and running the code. The beauty of Geany is that it is free of cost. It is a free and open source software, and it is very much lightweight. That means it do not eats up your resources while running. Here you can see it is written Geany, the lightweight IDE. And you can see it is compatible to multiple OSs like Linux, Windows, and Mac OS. So in any of the OS, you can download it. So here in the top row, you can see that it is Geany, the base, then about, then download. If you click it, you will go to the download page. Alternatively, you can click here and go to the download page. So here you can see the source code is also here, the Windows binary is there, Mac OS is there, and in Linux, other than the Ubuntu or Debian, you can go ahead and use the source code to build it. For Ubuntu today, I will show you how you can install it from the command line. If you go here, you can see the manual, and here there is a wiki. So if I go to the manual, download the manual here in HTML format as well as in the text format. If you go to the wiki, you will get a lot of articles here. How to do things are here, and you can find out a lot of
tips and tricks here about using the Geany. Now let me go back and go to the main page. So this is the general interface of Geany, and color can be switched. It can have multiple themes. So that's why these are there. And here, as you can see, it is very much fast and small, and it has a community support. That means you can have all the bugs and related info from there. And here you can see that multiple plugins are there, like here PCS plugin. And here if you go, you can find that different plugins. So here you can see different plugins are available. Let me go back again to the home page. You can see here it is supporting multiple type of programming language. That means once you install Geany, in the same window you can play with multiple codes. And if you want to go to this, let me go ahead and open in a tab. So there are a lot of available themes you can download, and you can switch to your desired look and feel for the Geany theme. Today I'll just showing you this thing. I will today only install the basic thing so that you can go ahead and start using the Geany. So without any further delay, let me go to the terminal. So here I will type sudo apt-get you must spell this correct. Geany is Geany. So I have written the command here, sudo apt-get install Geany, and I'll hit enter. I am connected to the internet right now, and it is communicating with the repositories to fetch the required files. So here you can see that it has installed. So here I was logged in with the sudo password, so it did not ask, and it go ahead and install the package right away. Let me clear the screen. I'll invoke Geany. But now we have come to the interface. Here you can see file. From here you can save or save as the file. The most common operation, and you can find and replace operations. You can do it from here. Replace is here. You can change the view from here. You can multiple document related stuffs here. In case of language like C or programming language or C++, you can do the build here. This interface is very useful. First left here you will see the files, which files we are saving and writing. Here is the editor window. Here you will see the editing. If you go down, right, there are a lot of other things are here, like status. Here things will be messages, and here is the beauty. Once you are working in any text editor which gives you a syntax highlighting, the trouble with that is that you have to continuously switch between your text editor and the terminal. Here in Geany you don't have to do that. If you go down below here the terminal is available to you. So this is basically a shell. If I type echo $shell, you can see is the actual Linux shell, and it is not an emulated shell. It is actual Linux shell, similar to the terminal here. This is the same thing. Hey folks, we are on the Linux part. Let me type on the command to install Python 3. So it is asking for my root password. So here you can see that it is checking and it says Python is set to manually install. So here you can see that Python 3, since it is already installed in my system, it said 0 newly installed and 0 to remove and 31 not upgraded.
we do have the Python binary here in our Linux system. Otherwise, explicitly you can give this particular command. Obviously, I provide this in the description to install Python 3 in your Linux. I'm talking about Ubuntu Linux. For other things, you have to go and find by yourself. And for installation of Geany, what we do, we give the sudo. We type this command. And here is the command, we type enter. So again, we do have the Geany installed here in our system. Hence, this message is coming that 0 newly installed, 0 to remove, and 31 not upgraded. So we already have the Geany. Otherwise, you have to give this command to install Geany. I provide this command in the description so that you can install in the Linux. Now, this part is clear. Let me close this terminal and open Geany. Here I type Geany. You can see Geany is here. Let me open it. Here is our Geany, and let me open the Python file from the last episode, the if-else episode. Let me open it. Not here. We will go to desktop and then we will go to code. So if-else.py. Let me open it. Here in the code you can see that it is already having the path of the Python, and this you can do by typing the which command. And here let me show you. Here is the terminal. Here if you go right, here you go, and here before running the code, what you have to do, chmod +x, and then you give the file name. So the file is now executable. So let me see whether we can directly run from Geany. We say execute. So here you can see our terminal is externally open, and here you can see the salary is medium is printed. Either you can use this method of directly going and here you can see the program exited with code 0 and press return to continue. So it will close that terminal. So when I type enter, it closes the terminal. So you can either use this method, or you can here in the terminal you can do the / the file name and then you enter. So here you can see the output is coming as salary as medium. However, in Windows, this particular terminal is not there, and here you can use that method which I have just shown. Go to build and then execute. Since this is a compiled language, we don't have to go for compilation or any other thing. We go to build and create, click execute, and this way your output will be coming. So this method is same for both the Linux and the Windows. So here we are done showing you the installation and the demo Geany and Python together, and here we are done. Hey guys, we are on Windows, and let me first download the binary of Python. So here we type Python download. It will directly open the official Python link here for the download. And here you can see the download Python 3.11.3. So it's okay, even we are developing the program with 3.8, even the subversions are increased, it's okay to use the 3.11. So there is no issue. However, the major release is Python 3, so we will install it. First we have to download it. Let me click download, and here you can see the Python has been downloaded. Next we will download Geany. So here Geany download. So here directly it opens up the geany.org, then download. So we directly go to the download page, or rather than we directly go to its home page. So here you can see a link, download Geany 1.38. Click it, and we are on Windows, right? Our Windows is 64-bit, so we will download this setup.exe file. So we click it and it starts downloading here. You can see it will finish download soon. So it has been downloaded. So let me close the browser. So let me navigate to the downloads folder. Here first we will install the Python. Let me double click it. And here it says install now. So we will click on install now. And here it starts installing. So it says setup was successful, and click here, close. And here next we install the Geany. We double click the Geany setup file, and here you can see the welcome screen comes, and here we click next. I agree, and here we are doing the full installation. Next, and we click install. So here you can see the Geany setup has been completed and we click on finish. And here you can see in the desktop the Geany icon has come. So what we will do, we'll double click it. And here it opens up. So here you can see the Geany interface. This is very same as the Linux one, except one thing. Let me open my pen here. Except one thing, here you cannot see any terminal here, which was present in Linux. However, we can still use it without the terminal here in Windows and Linux I have already shown. Let me go and open the file. Here it says open an existing file, and here if we click on if-else.py. So in documents we have a folder called Python, and there I have kept the example that we have shown and explained in last episode. And here let me open the if-else.py. So here I have removed the line where it says about the Python interpreter hashbang user, because that hashbang line is only for Linux, so it is not used in Windows version. So here I have opened the file, you can see, which I have already explained in last episode. Let me go to the build, and then we directly go to execute. And when I click it, what happens? Let me go for the pen here. Here you can see Windows command line prompt has been opened and it says salary is medium. So that was the output of the if-else program. And here you can see the program exited with code 0. This is already similar to the prompt in Linux, what we got, and press any key to continue. So this is very similar to the Linux one that I have already shown. And here this is the simplest way of running the Python code directly from this Geany. So let me close it and let me close this terminal. And here you can see this is the very simple interface. So here if you want to write another file, it will come as a tab, and here you can type your code, and once you are done you go to build and then execute. So here, since the extension is py, it is automatically taking the syntax highlighting feature. The Geany knows it's a Python, and when we go to build then execute, it executes the Python code. So this is very simple to use. So that's why I suggested to use the Geany. Another thing is that here, let me open the pen map. So here you can see there, if you are doing a large project on Python, many files can be enlisted here. So this is your project window, okay, when multiple files are there which are interrelated, maybe one calling another. So those files will be here, and this is the beauty of the Geany IDE. So we are done here. Let me close it. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about the if-else-if-else structure in Python with an example. Next, we will talk about the basic for loop using an example and make you familiarize with the basic for operation in Python, how it is different from any other language like Perl or C. Next, we will talk about for loop with range function, or we can say range operator, and how this is very much similar to the for loop in C language. Next, we will talk about the for loop with the break statement, which is very similar to the C language. And next, we will talk about for loop with continue statement. And in each of the case, we will have an example to make you understand how the loop works. Next, we will show you the construction of the while loop using an example. So that's the menu for today. And before beginning, I would like to say one thing here. Throughout our episode, we will be using examples to make you understand each of the bullets that we have here. And Python has a very basic stark difference from any other programming language, that it maintains a indentation. That means you are writing a for here and the next line will start from here. So here, there will be either you can use any of the white spaces like space, tab or double space, anything, whatever you are using, you should follow the entire convention throughout the code. And you will see these things in the code organization here, the code organization here in entire episode. Now, as we proceed, you will understand that if starts here, its inside statement goes here, next else goes again here, and else's statement, whatever inside the else, go here. So generally here I use a tab operator, which is very easy to use, and the spacings are maintained. Say if I want to hit a tab 2 times, it will shift 2 tab spaces. And say if we have anything nested like this, So this is a nested, maybe it's a nested if. So first tab goes here and the second tab will make the space further. So this is a 1 tab distance and this is 2 tab distance. So in the code I have used tab. You can use space or double space or any other white space, but whatever you use, you must keep that convention throughout your code. So this is one thing, otherwise Python will throw out the error. This is what I have to say even before I begin the first slide, because our every slide here has an example. Without any further delay, let's begin. If-Elif-Else. So here, one thing you must note is that it is not else if, it is elif. In many of the languages, it could be else if, but in Python, it is elif. That is E-L-I-F, elif. So if-Elif-Else. So this is the name of the if condition or if-else condition. So here goes our code. We will have the similar example that we had earlier, maybe in any other series here, maybe in Perl or maybe in Tickle, whatever. The same structure, same example is replicated here so that you can do the cross comparison with other programming language. So we have kept the same inner material for the programming if, elif, else, which is very similar to the Perl, Tickle, whatever series we have. Here we have also used the same kind of example and you can cross compare with those languages. So what is the difference between them? If you put the code side by side for if, elif, else with the Tickle and the Perl we have in our channel, so there you will be able to compare. So let's start. First line goes of the script is #bang user bin Python 3. We are learning Python 3 here and hence we will give the path and how you can get this path. So if you in the Linux terminal, right, if you type the which then Python 3 here, you will get this path as a result. This path you will be getting in the Linux terminal. Here, if we type which and then Python 3. So this is how you get your Python 3. In case you do not have the Python 3, please let me know in comment. I will make an episode for Python 3. And if you are in office and here you have to use Python 3, for that case you have to ask your Unix administrator to install the Python 3, because in office environment you are not allowed to install anything inside your system. That is the word of caution for you. And we start our example. First line, we define a variable salary equal to 25,000. Next, we have if, then we have braces, pair of braces, or we can say first bracket, and within that we have the true condition, followed by the colon separator. So here you can see this ends the if statement, the colon. We do not have the opening and closing brackets, that is the second bracket here in if in Python. We do not have that. Instead, we have a colon. And here we put the true condition, salary less than 20,000. What we will say? Print and salary is low. So we put it in the quotes or double quotes and we keep it here. So we do not even have a semicolon here. We do not have. That's why the Python is a very much flexible language, so that it's very easy to code. Only thing you can see here, I have kept a tab here. I have given a tab, right? I have given a tab here so that it shifts, so that whatever written here after the tab comes under if. So if I have multiple statements, tab has to be there and all the codes has to go in the same indentation. So inside if we give one tab and under that indentation whatever code is written comes under the if. Next, we have elif. So you can see it has the same indentation as if. Here you can see, and there we write the first true condition. This is a else if and we write with the keyword elif, that is ELIF. Please remember this thing because this could be good enough for your interview question, and as well as when you are coding you might get an error if you write else if rather than this is elif. So here we have the first condition, salary greater than equal to 20,000, and see we don't use a and operator here. We do not use it. We simply write and, and as an ending. We can write or not, all these words as the conditional operators inside if, elif, else block. And then we have the again the true condition, that is the salary less than 30,000. And we finish our code with the colon. and then with a single tab we write our next statement, that is print salary is medium. So salary falls within 20,000 to 30,000, that will mark as a medium salary. If it is less than 20,000, it will counted as low salary. So you can see here we have a tab, and with this indentation whatever code was there, it comes under if, and we have again another tab, whatever code comes under this indentation will be inside the elif. Next we have another elif, and you can see that it has the same indentation here as the if-elif, right? And then we have the again true condition, if salary greater than equal to 30,000 followed by a colon, and you can see here we do not have a semicolon or something to end the statement. This is very important in Python. This is very striking difference with the Perl, and I think in case you have done the Perl series you will be able to identify it. Next, again with the tab, we write a tab here, and then we write our statement here, print salary is high. So the salary, if it is greater than 30,000, we count that as a high salary. And then we have the else condition. This else is for anything that doesn't fall under if, this elif. If all these conditions are not satisfied, our control goes to this else. And here you can see again we have a colon. And here we write the value, it is not a salary. So anything goes beyond this, and we do not have any proper example for this, but we write a condition. If doesn't fall within these three conditions, it is not a salary. So when we execute, what happens? This output comes in the terminal. Why? Because 25,000 is greater than equal to 20,000 and less than 30,000. So this particular value goes into this particular code block, and this particular elif statement absorbs the value, and all the condition is satisfied as true, and as a result this is printed here. Now you write the code in a simple notepad and save as something maybe if-else.py, and you make it executable with chmod +x. So you have to execute it. Before execution I have to make it executable. So I have already done an entire lesson in the Linux series about the chmod, but here you have to use the simple thing, that is +x, and then we use a dot, and then we write slash, and then we keep the file, whatever file name, okay, whatever the file name .py. This Python file we execute in our terminal. So you can write it in whatever name you like, abc.py or something like that, and then you make it executable using the chmod +x, and in the terminal, Linux terminal, if you execute it with the ./file.py, this particular output comes. In case you are having trouble of running this code or you want an example, please let me know, we will make an episode. So we are done with this particular slide. Let's move on to the next slide. For loop. In this particular example, we will make you understand the basic for loop, how it works, and how the for loop is written organically in Python, and how it is different from either Perl or C, whatever language you have learned, or Tickle maybe. So let us start with the example and make you understand. Here goes our first line of the code, #bang user bin python 3. This is, you know already, that we get using the which command in the terminal, as I have mentioned in the earlier slide. Next we have the list. So list is like an array. In upcoming episodes we will have detailed episode on the data types and the data structures in Python. So there we will talk about the different forms and shapes of the list, but for now you can think it is like an array with multiple candidates. Here the list starts with pizza, then macaroni, then noodles. Okay, so it's a kind of list where food names are there. Next we have a variable. This is a counter variable. There is a counter of the for loop. For w, in, we write in, and then we give the name of the list. So this is the basic format of the for, and then we terminate the line with the colon. So after anything comes with the indentation will be counted under this particular for loop. So here you can see the basic difference from initialization counter, and then we have a colon, and then we have a condition here, then we have a incremental counter, which was earlier in C or maybe in some other language, maybe in Perl. So that is different. Here we do not have it. Here it acts like, I think, for each of Perl, which is very similar in case you have done the for each. So here in Python the for works in that fashion, and w in list. So whatever we have a list here, so in case we want to have a counter like or three counter statements like C, we have to recreate this, and this we'll do in the next example. So wait for that. Here, the next line we print W and then we keep a comma and then length of the W. So that means we print the length. That means how many characters are there. This is a inbuilt function of Python and we operate it on W. So each element of food is called by this particular counter, and whenever that counter is reached, we print it as W and the length of the W. So this is printed. Now, when we save the code, we do the chmod plus X and then execute with a // in the Linux terminal. We have this one, this output. So first comes pizza. You can see pizza is the first element. And if you count 1, 2, 3, 4, 5. So 5 is the length of the thing here. And then we have macaroni, the length is 8, and then we have noodles where the length is 7. So we operate on the list using the for, and this is very similar to the for each operation in Perl. Now your question is that how we write a for loop, that is we are much familiar when we learned C. Yes, we do have a method, and in the next slide we will do that. So here we are done. Let's move on to the next slide. For loop with the range operator. Remember, the range is an inbuilt function or an operator in Python. So we will use that to make or convert our by default for loop into a C-like operation. So here goes our code. First line is hashbang user in Python 3, that you already know how to get it. Next we have for I in range 0 to 6. So we have a C-like counter. I is initialized with 0 and I will move up to 6, and the range will increment as an integer, right? So 0, then 1, then 2, then it will proceed like that. It will create a list of say 0, 1, 2, 3, 4, 5, and so this list will be created by this particular range operator. And this is very short and sweet, so you don't have to write it explicitly. Range will create this. So whatever, you can start with say 2 and then go to 6, then 2 to 6. So this list will be created. If you write 2 here and then this 2 to 6, this list will be created. This is a very easy way of creating the list of 0 to 6 with the integer increment of 1. So this is how we convert our defined for loop in Python into a C-like or very close to C-like structure. It's not exactly C-like structure, but close to the C-like structure. Now here we have a tab, that is an indentation, and we write print. In this indentation, whatever is written goes under this particular for loop. So what we write here, we write I equal to, and then we put the value of the I. So whatever incremented, and when we save this file as something say abc.py or maybe for loop with range.py, and then we do the chmod plus X and we execute it in the terminal, this value comes. So I equal to 0, 1, 2, 3, 4, 5. Okay, so there was a mistake by me where I said that 0 to 6 will be there, but here it will create 6 elements, 1, 2, 3, 4, 5, 6. Okay, yeah. So 0 to 5 will be created, not up to 6. This is the range operator. Guys, sorry for my mistake, and you should also get corrected here. So this will be coming as the output. So this is how we convert the predefined for loop in Python in a much closer operation to the C structure. So you can see it gives 6 elements, 0, 1, 2, then 3, 4, 5. This particular list is created by this range operator, and you can play with this range operator and let me know how you do that and what you are getting, or in case you are having some troubles, please let me know in the comment. Here we are done. Let's move on to the next slide. For loop with break. Now the break statement, you might be aware from the C language, it is very same. That means it breaks out the loop, breaks out any loop. It could be for loop, it could be while loop. If we use a break statement, it breaks the loop and goes out. So here we will use an example, and since I have explained so much for the lines and indentation and all, I will make it short and sweet because this is a lengthier example. So here we have the for loop with break. The first line we have our Python binary path, hashbang, then we write the description of our program, that is prime number identifier. It will automatically do. It doesn't scan from your input. It just do whatever written inside the script. So here we write for n in range of 2 to 10. What we do again a nested for loop, and you can see we have an indentation here and here for x in range 2 to n. So it starts with 2, it goes up to n, and then we again give another tab here. So this if is under this pod, and this condition is true, that is the modulo division is 0. Then we print again with another tab. Here we write the next line, n equals to x star in n by x. Okay, so we'll come later in the operators episode about all these operators. Next we write break. So break, you can see under the same indentation, that means it is within the if block, and here we write break. So if we reach this condition, we print this and we break, so we go again back to the original. Otherwise it will continue inside the nested for. Once this goes up to this, right, it breaks the nested for and goes to the mother for, okay, or the parent for, whatever. Next we have the else, which is in the same indentation, and that means it's within this particular for loop. And here we write just a comment, loop fell through without finding a fact. It's a comment and we don't print anything here. We print here, print n is a prime number. So if it doesn't go this if block and instead the control goes to else, in this case this is false, and in that case it will be a prime number. So first line we had an inline comment, and in previous episode I have told you how to write an inline comment or a single line comment with the particular hash. But hash here is a different meaning and hash here is a different meaning. So hash here it's calling the Python 3 to execute the rest of the code, and here hash means it's a comment. So hash and hash bang, this is hash and this is hash bang. The two has two different meaning and you must be very aware of writing them. So here once we execute this in our terminal, obviously before that we have to save the file with some name.py and make it executable with the chmod +x, and then we write it. What it will we will get. So here you can see it produces, the range produces the number from 2 to 9. Okay, it doesn't go to 10. From and 3, it writes that 3 is a prime, 4 is equal to 2 into 2, 5 is a prime number and it reaches there multiple times, and 6 is equal to 2 into 3, 7 is a prime number. All these things are happening. So this is a typical example how you can use the break. However, this is not the only way you can use with any condition. Say the purpose of the example is that you can use the break with a condition, and even if we put such condition in the parent loop, if you need, you do it. It's not necessary that you write again a child for or a nested for, and inside that you have to use break. No, you can use it right away in the parent or the initial for loop. So that is the thing. So here we are done with the example. Let's move on to the next slide. For loop with continue. Now you know that whenever we reach the some condition and we want to still continue our loop and go to the initial counter of the loop, we use the continue. It is very similar to the C. Now let's start our example here. First line goes as the Python binary. Next we have the comment of the description, the odd even number identifier. Next we have for number in range 2 to 10. So we have num as a variable and range operator to create a list from 2 to 9. And here we write if num modulo division 2 equal to 0, then found an even number and we print the number. And we write continue. That means we go back to the counter here and we continue. And if this particular if block is false, then it is not executed. At that time, the control goes to the next line, that is to the print command found an odd number. That means whenever we find the even number, our control goes back to here in the counter and number is moved one step forward in the list and picked up with the next list element. So continue takes that control. And if this entire code block is false, that means it's not an even number. In that case, this print command, which is you can see under the indentation of the for, so it's under this particular for, and here this print statement will execute found an odd number. Here is another example. So here is the example of continue, and when we execute here in the terminal, obviously after saving the file in some name.py and make it executable, and then we execute it, we get the output as found as even number 2, odd number 3, even number 4, odd number 5, even 6, odd 7, even 8, and odd 9. This is an example of using the continue statement inside the for loop. However, the same way, if you put a condition if and you use the continue inside that particular indentation, that means inside the if block, you can still it using in the while loop. That is up to you. So here we are done with the for loop with continue, and let's move on to the next slide. While loop. Let's start our example. So that we jump onto the definition how the while loop is written in Python. Here the first line of our code is Python binary, that is #bang user being Python. And then we write one variable as a equal to 0, and then we write a numbers, that is a blank list. In later episodes we will cover all the data types and data structures, so don't worry about that. Just for now, see this, it's a blank, it's two triangular brackets kept face to face here. It's only that. Okay, it's nothing other than that. Then we write while a less than 6, and you can see we terminate or the while statement, not the loop. Loop will continue later on. The statement with a colon here and not a pair of braces. And we give the first tab and write the print statement here. Print at the top, a is %d %a. We have a C like printing here, %d, and we have a %a. Next, we write an command that is numbers.append then a. We will come to all of these list operations in the list episode, which is upcoming. We have not covered it yet. We will cover it. Then we write a equal to a plus 1. So we increment a by 1. And then we print numbers incremented to this. So we print numbers, that means this list is printed. So before going any further, you can see numbers.append. So you can see this is a kind of object oriented operation. I will explain it later, because numbers is an object and we have an object related function here which we are using, and this function is inbuilt in the class, right? So we have it and we are using it. The class of the list. This is the beauty of Python as a object-oriented language by birth. Next, we have the print command, right? At bottom is %d %a. Next, we write the numbers. And then here you can see up to this indentation, right? Here, because of the typing and the character spacing, this has come to the next line. Otherwise, it is here only. This is here only. So please don't get confused. So up to this indentation, that means with a single tab here and all the lines, and here single tab under the while loop. And as we write again from this same indentation, we are out of the while loop. And here we write for num in numbers. We iterate over the numbers. We print them using print number. So basically here we start with a blank list and we fill it up, and we have a blank variable, and then we increment it, and then we fill up the list, and then we print the list here. As we save the file in some name.py and then make it chmod +x, that is executable, and execute it in the terminal, we get all these outputs. Finally, we get the numbers here. You can see the numbers is 0, 1, 2, 3, 4, 5, 6. So here you can see we have filled up this list using the for loop. So we have given an example how a for loop can be used, given an example how a while loop can be used in Python. And again, I am saying that continue and break you can use still inside the while based on your need. The continue and break is not only associated with for, it can be used in while. So here we are done with our example. Hey guys, welcome back. In this episode, we have a very short and crisp description of the operators and the precedence. And before proceeding, I'd like to mention that there will be 3 slides in this presentation, and because of the shortage of the area, the entire list of the operators and precedence has been split into 3 different slides. However, if you join them back to back in order that I am going to present, the entire table will be constructed. And as we go in this direction, in the table, it means lowering the precedence, and if we go in this direction in the table, that means we are getting a higher precedence. So please keep remember the 3 different tables shown in the upcoming 3 slides are not discontinuous, they are continuous and will follow the precedence order as marked by these arrows. And if you join them together and make a bigger table, even then this order of the precedence will follow. So without any further delay, let's start. Here in our left column, there will be operator. In the right column, we will be having its meaning. Now we have different kind of brackets. So this is a first bracket, second bracket, the third bracket. So these has different meanings, and these has the first precedence over any other thing. Now binding or parenthesized expression, list display, dictionary display, text display. So all these operations are done using these brackets. So these will have a higher precedence. You will become familiar with the Python code in upcoming slides. Before going to that direction, we just discussing this because you will not stumble upon the precedence in any of the upcoming slides once you have covered this particular episode. So the next lower precedence is x then index, x then index colon index, x then arguments, and x dot attribute. So what are these? These are subscription, slicing. Slicing we have already seen in other scripting language like Perl, and here we also see the slicing in strings. This is the call, this is the function call, and this is the attribute reference. This you will see, sorry, not this one, let me clear it. This one you will see as the Python's by birth. The Python language by birth is object oriented, and this you will see much more often in the programming Python. This is you are familiar. This is a subscription. That is the you have a array or list, and you have the index, and this is slicing, index to index. This is a function call with arguments, and this may be a function call from a object. That means a object's function is an attribute. So these things you will become familiar. So this will take the first precedence, this will take the next lower precedence, and there is a await expression, and that particular await expression will have the next lower precedence. Then start, that means double start. It is, we know that the exponentiation operator or to the power operator. Next we have all these three bitwise operator, that is plus x, that is increment, minus x is the decrement, and bitwise not. So these will have the next lower precedence. If you want to evaluate why this particular episode is important to you, the reason is that when you are having an interview and you don't have the Python interpreter with you, that time you are asked to resolve any Python equation. That time you have to keep all this thing in mind. What will come first, and what will come as the second precedence, and what will come as the third precedence, and all. So that's why I have kept this single episode separate from any other episode or any other section, because this is itself very important for the interview process. Next we have star, @ double slash, and %. So you know these are multiplication, matrix multiplication. So this is simple multiplication, this is simple multiplication, this is matrix multiplication, this is division, this is floor division, and this is modulo division, that is remainder. All these will have the next lower precedence. So going in this direction we decrease in precedence, and if we go in this direction we increase the precedence of the operator. Now let us continue the remaining part of the entire list in the upcoming slide. So the next lower precedence we have the plus and minus, that is the addition and subtraction operator. Then we have shifts. So this is the left shift operation, this is the right shift operation, and you know this happens for the bitwise shifts. Then we have bitwise AND, then we have bitwise XOR, and then we have bitwise OR. So bitwise AND, XOR, and OR. Here all these operators are bitwise operator. Next we do have the in, not in, is not. So these are used for comparisons, including membership tests and identity tests. This is less than, this is less than equal to, this is greater than, this is greater than equal to, not equal to, and equal to. It is equal to, that means we cannot use a single because single is an assignment operator and double is checking the condition. These are explicitly used in the if condition or elif condition, and these are also used. These are specific, these are generic. You have the right hand side, these are generic, you have already seen in any other programming languages like C, Perl, etc. And these are specific to Python, that is in, not in, is not. So these are specific to Python, and they can also be used in a testing condition like if or elif. Again, let me emphasize, as we go in this direction, we decrease the precedence, and as we go in this direction, we increase the precedence. So let us continue and finish the list of operators and their precedence in the next slide. So here first one is the not x, that is the boolean not, and it is not the same as we have seen in the earlier one. This is a not and this is and, this is a boolean and this is or, this is boolean or. So these are also used in the if or elif checking condition, please remember. And then comes the if-else conditional expression. So these are operators. Even this is also a operator, so this will be given higher precedence. That means if we have a if-else, so whatever in the condition checking using these ones will be given the preference first, and then itself the if or else block will be given precedence. And this is an assignment operator. This comes at the last precedence or the lowest precedence, and here you can see that there is a colon than equal to rather than. This is a, I think, lexical format, that is a grammatical format of Python to express an assignment operator. Whenever you open the Python manual, you will see this symbol. However, it is a simple equal to symbol. So this is only a simple equal to sign, that is the assignment operator. So you assign any variable with this particular operator. So this comes with the least precedence. Again, let me mention that as we go down in this direction, the precedence goes lower, and as we go in this direction, the precedence goes higher. If we concat, that means if we join the three tables that I have shown in this particular episode, in last two slides including this slide, we make an entire table of the operators, and in that table, the entire big table, even if we go from up to down, the precedence goes lower. From low to high, from bottom towards up, if we go, we get a higher precedence, and in this direction, lower direction, we lose the precedence, and here if we go, we gain the precedence. So please remember this precedence order. These are very important while you use the if-else condition or any other checking condition, the entire Python coding, as well as you must remember this precedence and memorize them, because whenever you are using this in your Python theoretical preparation, you will need them in your Python interview. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about various variables that exist within Python, and these are called as literals in Python. Next, we will talk about integer literals classification. So we will talk about the different types of number system that can be represented within the Python. Next, we will talk about the specifiers for integer literals, that is integer variables in Python. Next, we will talk about a set of examples for the integers and float using a Python code and its output. Next, we will go further and give some further examples for the integer and float using another example. Finally, we will use an Python code example to understand how the C-style formatting can be done for the format specifiers that can be used in Python for printing the output. That's the menu for today. Without any further delay, let's begin. Variables, also known as literals. So here we classify the literals in Python in 4 branches. The first one is integer. The next one is string. The next one is floating numbers, and next one is imaginary. So these all 4 type of literals exist within Python. As you know, we call the floating number in programming language, in mathematics book, we call it a real number. So both are same. This is just for your information before proceeding any further. So you know the basic classification of all the literals, that is variables in Python. Now let us move forward to the next slide. Here we talk about the classification of integer literals. That means our integer variables, how they can be represented in various number systems. So first one is the decimal number system. Next one, that is binary. Third one is octal, and fourth one is hexadecimal. In Python, we can write all these 4 type of number system using integers, and we have proper representation to write and understand the different type of number system for integer within Python. We will exemplify it, don't worry, and you will be easily correlating in case you have done the coding in Verilog, because in Verilog we definitely use the binary as well as the octal as well as the hexadecimal apart from the decimal. So in case you have done that or already have the knowledge of that, so you will be able to correlate. Another thing is that in case you have not done, we have an entire Verilog playlist. Here we have explained this. So please go ahead to the playlist page and find the Verilog playlist. So we are done here with the classification of integer among the various possible number systems within Python. Now let's move on to the next slide. Integer literals, specifiers. So first, we have non-zero digit, and how we write them? We write like this 1 to 9, and there could be many things. And digit, that means we are talking about any digit that starts with 0 and goes up to 9. Next, we have the decimal integer. How we write them? We have a non-zero digit here. That means this representation will come here, and then there will be a underscore. It may be there, may not be there, and there is a digit. So this is the representation. This is very simple for the basic integer. Next comes the binary. Here starts the interesting phase, right? The binary we know either 0 or 1. Next we have binary integer. How we write them? That is 0, then we write small or capital B, and then we have an underscore, then we write the binary digit. So this is very similar to the Verilog. Like how if I write 4 B, then the binary numbers 1 0 1 1. So this becomes a binary representation, and here you can see that after this B there will be an underscore. So here there will be an underscore. So this is the representation of the binary. In the similar fashion, we can go ahead and write for the octal, which is the next. You know that octal starts from 0 to 7, the basic numbers in there. And then we can write an octal integer starting from here. There can be specifier, right? How much the width is there. Then O, then underscore, then octdigit. And here is the hexadecimal, right? And we have the digit. Then we have this, it could be the digit, right? That means 0 to 9. Then A to F and then A to F. So this defines the hexadecimal number system. And in Python, how we can write this and then this and then this, and here goes the hexadecimal number. So one striking difference here, when I have wrote for the binary, right? I wrote 4B, right? So the 4 will not be there because here you can correlate, right? All the first initial digits are 0. So even how much long, this what I written, that was okay with the Verilog. But here when you are writing, right, you will see that 0 0 0 should be there. That means here instead of this will be 0 B, right? And then it will continue underscore 1 0 1 1. And now this is true for all of the three, that is binary, octal and integer. And if you place it right, you will see a non-zero digit here. So this is the difference between these three and the decimal integer. Here it will be a non-zero digit, whereas here it will be a 0 1. So here it will be 0, not 4. So this is a striking difference with the Verilog. Now, we must note here that Python version 3.6 onwards. Why we are talking 3.6? Because right now we are learning Python 3 and it has some sub-versions, starting from 3.1 up to 3.10. Right now, I think 3.10 point something is ongoing. And for their underscores are now allowed for the grouping purpose in literal. So this is one thing. For grouping purpose, we can use underscore in Python. Obviously, you have to use a Python interpreter 3.6 and above. Right now, whatever we are emulating in this particular series, we are using Python 3.8 or we are using the current Python 3.10 as I have installed in last to last episode. That is the episode previous to the last episode. This is few things that you must know as a learner in Python. We are done here with this particular slide. Let's move on to the next slide. Integer and floating numbers. We first give you one set of examples. Here start our example. First we have our Python interpreter, that is hashbang, user being Python 3, and remember we are writing Python 3 and not Python. Although when we are talking it as a Python, but when we are writing we are using Python 3 because Python 3 the coding is different from Python 2. Here we write a variable width equal to 20, and here we check the multiplication of integers. How? The height is equal to 5 into 9. Next, we have the area. Area is what? Width into height. So this and this multiplied. So the multiplication of all of these will come. Right? Next, we print the area. So this area we can print, and we have a type checker here. So using the type function of area, we can print the what type of data that we are storing within area. Division leads to the float. This was multiplication, right? If we do the division, right, we will face the floating number. So here we have 50 minus 5 into 6 all divided by 4. And we print here the variable, and also we do the type checking of the calculation. Now here we have not defined any of these variables as integer or float, but due to the ongoing mathematics, whatever we are doing, that will make it a integer or a float based on the type of mathematics that we are doing. Now, before going any further to the example, let's have the output so that you can relate. So first one, so forget the last two, only we are talking here the first two, because we have exemplified here only the first two, because there are only 4 print command. This is from the first print command, that is print area, that gives this output. Next, we have the type checking. So here it says the class integer. Now why we are talking class here? Because from birth Python is a object oriented language, and the integer type is defined as a class in the Python. So it is printing as class integer, but seeing the int, you will be able to understand that this variable contains integer values. Next, as we proceed with the division here, the next one gives the 5.0, right? Whatever we are dividing here. And when we check the type of it, it comes as the class float. Here we have the floating number representation, and the variable is a float. So this way we can check the value of a variable and the type of a variable. That means the type of the value that is storing inside it. And one thing for remember, it doesn't has to go with the definition, but it depends on the what type of mathematics we are operating here, and that will lead to the type of the variable. Next, we have again another code. We start with hashbang python 3. And then we are using the to the power operator, right? You know, say we start with number equal to 20 and then power equal to 3. Then we use the final is equal to number, then double star. These operators we have already discussed in the last episode. In case you have not watched it, go to the playlist and see the last episode. So this is the to the power operator, and as we print this, this comes as this. This is the value. And as we check the type, it shows the type is integer. Here you can see the type is integer. Next, we use a function power instead of the basic operator that is here. In that case, we have the final as pow. This is function, then number, and then to the power. So this is the function pow that you have to first give the number, and you have to give its power to get the output to the power. Then we print it, and as we print it, we get this value. Next, we do the type checking here, and with this type checking, the printout comes as the integer. Now you can see that you can use a variable very flexibly. That means you don't have to declare it as an int or float, and you can go ahead with your mathematical operation as you want. And as a result, what happens? Python automatically declares the type internally, and to check the type, you have to use the type command within the print state. So this is very different from the C language. And here we are done with this particular example. Let's move on to the next slide. First, we start here with our Python interpreter. Here we have written the environment, but I will suggest you to use directly the user being Python 3. But in case somewhere I have to demonstrate you, that's why I have kept this, but it is suggested that use directly the Python binary. Next, we use the classic division returns a float. First, we write the result is equal to 17/3. So it's a classic division. And here we print the classic division, then result. Next, we do the float division, which discard the fractional part. And as I show the output, you will be able to correlate what we are doing and what we are getting as an output. Now, this is the float division. So this is, I have explained already in the operators episode, in last episode. and then we print it fractional, that is result 2. So here you can just see the difference. Here it is 17/3 and this is 17/3. If any automatical fractional part, because this is auto managed by the Python, is coming, that will be removed. Next, the remainder of the division. This is the modulo division, that is 17, then percent, then 3. So we do the modulo division here, and as a result we get the remainder. And here we print our remainder. Now as we run the code, we get the output as this. And here you can see this one gives the classic division, that means 5.666. So even if you are doing it in a handheld calculator, right, this value will come. But in case we want to discard this part, we use the floor division, right, this one. And here you can see only 5 is coming and the rest of the value is discarded. And next we have the modulo division to get the remainder. So this is how you do the different division related mathematics in Python, and how you deal with the automatic assignment, whether it is a floating point number or an integer, with the Python coding. Now we have this classic division and the fractional part which is discarded, that is called the floor division in Python. This is because the Python automatically manages the output, that means the type of the output, whether it should be int or real. So in that case you need a specific output, you have to use a specific floor division here. So here we are done. Let's move on to the next slide. C-style format specifiers. Now before going any further, you remember that we used %s, %d, %f, %e, all these things in C language just to print the proper representation of integer, float, and etc, etc. Earlier we are just printing the variable and we are not giving any specifiers, but in Python we can still use the C style format specifiers. And how we go with this example. The first line is our Python interpreter, that is hashbang user bin Python 3. In your system this could be a slightly different. You have to go and type which Python 3 in case you are in Linux. In case you are in Windows, you will run directly, as I have shown you in the episode of installation and using the Python interpreter and the Geany GUI, that is Geany UI. So the next line is we have the name of our channel, Tech Simplified TV, and next we have, then sub is the subscriber is 5000, and then this tutorial is Python for VLSI, and we have views is equal to 2.5. Next we type the print. Then let's talk about %s, and then we have a modulo symbol here, that is the percentage symbol, and name. And we have %d subscriber and %f lakh viewers, and here we have percentage and then we have a bracket. So please watch this carefully. In case more than one, that case we can take the percentage common out of the first bracket, right, and all the variables will go here within the first bracket or the pair of braces. Now as we proceed, we give the another print command. You are watching %s, that is this tutorial. As we run the code, what we get the output. Here is our output. Let's talk about Tech Simplified TV. We have 5000 subscribers and we have 2.5 lakh views. So in case you have to give the exact number of views, you can specify it. So here you can see views we have written as float and the output is coming as float, right? As we write %f, and here we are writing is %d. Here for 5000 it is coming as 5000, and for this it is coming as this, and we are giving the variable values here and here, and here this is a string, so %s is giving this output. And finally when you are using this %s, this gives the value this Python for VLSI, this which was originally stored in this particular variable, which is we have used here. In this way you can use all the C format specifier, and in case you are using a single variable you have to use this fashion, and you are using multiple variables in the print statement, you have to use this fashion to write the variables. And this is very similar to the printf which we have used in the C programming language. And here you can see we have got the C style format specifier and the outputs. So this is for the printing output of your Python code in the terminal. So here we are done with the usage example of the C style format specifier in Python. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will visit the variables which are also known as littles. They are divisions in our chart which we have already discussed in last episode. We'll talk about what we have covered and what we will cover in today's episode from that chart. Next, we will provide a short introduction to the strings in Python. Next, we will make you understand the string syntax by a simple example. Next, we will go in detail why we should learn converting string to number and back, because numbers we have already covered in last episode. String we will be covering this episode. With respect to the Python in VLSI, what is the importance of converting string to number and back in VLSI we will talk about. Next, we will go for detailed example for the conversion of string to integer and back. Next, we will cover string to float and back to example. Next, we will talk about conversion of string to octal and back. Next, we will cover the string to hexadecimal and back. And whatever significance we discuss here in this point will be exemplified through this next 4 slides. Without any further delay, let's begin. Variables. This is the table that we have already discussed in last episode. Now, in last episode, we have covered the integer, the float, and we are not discussing at all the imaginary, so you don't have to bother about imaginary. In this episode, we will cover string. We will cover all the literals that are necessary for you. So let's move on to the next slide. We are done here. Strings in Python. Let me introduce you to the strings concept in Python. A string is usually a stream of text you want to display in the screen or write into a file. So this is a generic definition of a string, what you call a string in programming language, obviously, and specifically in Python. Next, Python identifies strings with double quotes or single quotes around the text. Backslash can be used to escape quotes and print as regular characters. This means inside a string you want to print the double quote or single quote. You have to use a backslash to do that. So far, it is very similar in case you have already learned the Perl. To print a string, we use the print function in Python. Obviously, in Python 3.0 above, you have to use a pair of brackets. The first bracket pair you have to use in print function. Earlier Python code did not need it, but from Python 3.0, you need it. Print function accepts format specifier %, followed by the variable you have in already, because in last episode we have exemplified the format specifier. In case you have not watched, please go to the playlist and from there watch the last episode. For multiple variables, you need to put them inside parentheses separated by commas. So this is very important to this, and both of these are exemplified in last episode. So you have a clear example already in case you have covered the episode. We are done here. Let's move on to the next slide. Your first string example. So here starts our Python code with the first line is the Python interpreter. The path of the Python interpreter inside Linux. In case you are using a Windows, this should not be there and only the rest of the code should be there where you are running the code through Geany, as I have shown you already in the installation episode. Next, s equal to within first quote, first line, top, then we have a \n. You know this, right? From the C language. This is a new line character, and then we have the second line. Next, we print s to this print s command, and here you can see there is a pair of first bracket. Next, we write the same line with r, and again we have the print command. So here is the output. So you can see that the first print, the first line and the second line are into separate lines. But when we put R, what it becomes? It becomes a single line. That means if we put a R here, it will not use this as a new line character. Now, what is R? R is the syntax for the raw string. So in case you want to have the entire thing here, whatever thing you are writing as is to be printed, you just insert a small r there as a raw string. I write R-A-W, the raw string. So this R is here. these are. So the raw string, in case we have to print and without any modification, it should go ahead and print. So in that case, we have to use a R here. This is a beauty of Python. You have a lot of tools here to write and modify the string. This is your first one you see in your first string example. So here we are done. Let us move on to the next slide. Why learn converting string to number and back? So in the classification slide, we have seen that there is string, there is number, that means integer and float. And in last episode, we also talked about there are number system like octal and hexadecimal. Now, why we want to convert string into number and back? We get the string as is, right? This is your question. And why should we convert at all? So here goes your motivation to learn the conversion. These type of conversions are very important in front end because you have to deal with test vectors. This is the very important thing. In front end, there will be a lot of test vectors, whether you are designing RTL or you are working as a verification engineer. In case you are using the Python automation, the Python code has to go through lot of test vectors. So here I mention either generation or validation. Generation means you are generating the RTL, or validation means you are working as a verification engineer, or it could be a simple RTL validation. Next, in Python, when we parse anything, we parse everything as string. This is the important concept you should pin to your mind. So the conversion is necessary. That means whenever you are parsing something, you are parsing it as a string. In Python automation, you are reading a file through Python and you are getting a hexadecimal number or a octal number or a simple int or a float. You are getting it as a string, not as the expected data type. So you are parsing it as a string. This is the most important thing you should remember before you handle the string, before you handle the parsing, before you handle the Python automation. Now, here comes the next interesting point. The test vector values for a bus may be in octal or hex number. So you are having a bus which is sending bits or receiving bits. So the communication can be in octal or hex number system and you are reading it as string. Now there is no chance or that you can use it as is. You have to convert it in the respective number system to include it in the mathematics or the validation. Next, you may have to modify according to your need. That means whatever need you have to modify it or not modify it as per your need. Conversation for integers and real numbers, it is very straightforward. We use the built-in int and the float type constructors. So for integer, we use int. For real number, that is floating point number, we use float type constructors. These are the functions that you will be using to convert a number which is parsed as a string but has to be converted into int or float. Next, we have a short example. Int 542 gives 542 as an integer and then this float. So inside this, within first quote, right, this is and also this is. Inside whatever we have, it is a string and this gives a float 542.0. A simple example how this works. For octal and hexadecimal, a leading 0 indicates with O as octal and 0 with X indicate as a hex number. So this is we have already talked in last episode, right? And now you are learning the significance, why you are learning the octal and hex at all when you are learning Python. We have examples in detail in upcoming slides, so we will not go in detail for the octal and hexadecimal here. Here we are done explaining you the significance of learning the conversion of string into the number, whether it is int, float, octal or hexadecimal number, whatever type of number it is. This is the importance. We are done here. Let's move on to the next slide. Here we will learn the conversion of string to integer and back to an example. First, here is our Python interpreter. This will be needed in case you are using Linux. In Windows, you don't need it. Here goes our comment that converts string to integer. You should put such comments so that when you code something at later point, maybe 6 months later, if you open that code, you will be able to identify easily what you have done with that particular code. Now we have a variable which is a string and we name it as string_num. And then we have a integer_num which will be an integer type and we convert this particular string number into integer using int and then string_number. Next, we have a print statement string to integer. Then we write the original string is string number. then we print the converted integer is integer number. So this is, we are converting first string to integer. So this is the code. Now here we can do the type checking using the type function, and here we write the type of the converted integer is this. Next, we convert the integer back into string. So we may need it, we may not need it, but you should learn it. Next, we convert the string, that means a converted string, with the str function. Earlier it was int, right? Now it is str. Here is our integer number. The integer number is this one which got converted. Next, we print the header integer to string. Next, we write the converted integer, that is integer number. And then we write in which it is converted. So the converted string. Now we are converting integer into string. Next, we have the type of the converted string, checking we've done with the type function. And finally, when we run the code in our terminal, we get this out. First, here string is 42, converted integer is 42, and here you can see the type of the converted integer is int, right? The type. So this type function gives this result. Why we are doing this? Because on screen these two look same. You don't know the difference, but the type checker does it. Now in the second one, we have the converted integer as 42, and now we are converting back into string, so 42, and now we are checking the type here, right? And this goes here like the str. So the first conversion turned into int and the second conversion turned into str. So we have properly converted one type into another, that means string to integer and back we have done here to this example. These codes are available in the description to download from the GitHub. You can download from there and practice and modify them as per your need. Here we will convert string to float and back to an example. First, we have the Python interpreter. Then we have our comment, that is converting string to a float. This could be a practice for you to keep a comment so that you understand what you are doing in the code. At some time later point, maybe 6 months when has elapsed, that time if you open the code, you will understand what you have done 6 months earlier. So here we have a string float. So this is a string and we contain a float, that is 3.1. And then we have a float variable. And how we do that? We convert this string here to the function float. And we type here string to float. We are printing now for checking. Original string is string float and the converted one is a float. Okay. Now again on screen these two will look same. How to check the type? Here we will check the type with the type function. Next, convert the float back into string. First, converted string float. We have str function similar to the float function here. We have str function here to convert the floating number into string. Now we type float to string and then we print the converted float, the floating number, and the converted string. Why we write converted float? Because this was not originally float, so this was converted in the earlier step, right? So we kept this printing same, this and this same. And now converted string float. Okay. And here we do the type checking, because on screen these two outputs will look same. We do the type checking with the type function. Now when we run the code here, we get this output, and so here this is string, right? And this is your float number which is converted. Now we do the type checking here and it is float. Similarly, we have the converted float, that is the floating number, and we have the string. Now on screen these two look same, so we do the type checking here and it is. So this way you can convert a float into string and do the reverse. You can download the code from the description and from the GitHub link that already provided in the video description. So we are done here. Let's move on to the next slide. String to octal and back. In this example, we will convert string into octal and do the reverse. First is our Python interpreter. Next, we have our comment, that is converting string to octal. First, we have string number 42. And then we have our octal number, and we are using octal conversion. But remember one thing, we cannot directly convert from string to octals. We need a two-step process. First, we convert string to int, that means integer, that means it's a number, not a string. And then we convert that integer into octal. So this is a two-step process. You have to keep it on mind. So you cannot directly give the oct and then the string. So this is a two-step process. This is very different from the previous slide. For octal and hex, you have to do a two-step process. Next, we write string to octal for the printing, and then we have our printing of the string number, and then we have the printing of the octal number. And on screen you will be able to see the difference. So we are not doing the type checking here. Convert octal and back to the string. In the next set of lines, we will convert the octal which we have achieved here back to string. So here we are writing the converted string. Now this is also a two-step process. So we have an octal number, and here we are keeping the base, right, for the integer, right, since it is dealing with all the numbers, right? So we keep a base 8. 8 means octal, and here we give the octal number, and first it is converted into int and then it is converted into str. So you keep this pinned in your mind that either the forward conversion or the backward conversion, both is a two-step process. Here is the difference. Here you don't have to give any base or something, but when you are converting it back, that means you are converting into string, and from an octal number you have to give the base, because otherwise you will not know whether this is a octal, this is a hex or something like that, to the int function. So int function will identify with the base this is a octal type of number and it will convert into int. Next we give a print header. Next we print the octal number. Next we print the converted string, and as we run this code in terminal we get this below. So first here was our string, and here you can see it has converted to octal, right? Visually it is very different. So here is 0 and then octals O and then the octal number system 5 2. These are octal, these are not decimal. Now we are converting octal back to string. First goes our octal number and then goes back to our string. We go back to its original stage. Remember, this was a two-step process and this is also a two-step process, which is a striking difference from previous slide. We are done here. Let's move on to the next slide. String to hexadecimal and back. We start our code with the Python interpreter. Next we have the comment, that is converting string to hexadecimal. First we have a string number 42 and then we do the conversion, and here you can see it is also a two-step conversion. First we convert the string into integer and then we convert integer into hex. So this cannot be done omitting the integer, so this has to be done. This is how it is designed in Python. You cannot skip this step, intermediate step, otherwise it will be very problematic. Next we have string to hexadecimal, the header printed. Next we print the original string and then we print the hexadecimal number, and visually this will be different, so we are not doing the type checking here. Next we convert the hexadecimal back into string. First we have the converted string, and you can see we are using the same method, int, and then we have the hexadecimal number, and since it is hexadecimal, the base is 16, we are using its base in the int conversion function, right? And to identify this as a hexadecimal and not as a octal or a decimal, so it goes to int, and then this int in is converted into string by the two-step process. Next we have a header, hexadecimal to string. Then we have the converted hexadecimal number here, and then we have the converted string. Once we run the code, this output comes. Now let me correlate. First here goes the string, and here you can see the hexadecimal. So you can see the 0x of the hexadecimal and 2a, it is the hexadecimal number system. So it has been converted successfully to hexadecimal format. And the reverse, here we take it as a input 0x2a, right? And the converted string is 42 to back to its original form. So here one thing you should also notice, that forward conversion or the backward conversion, that means when you parse as a string and convert it into hex, or you convert it into again to string, both are two-step process. It is not a single step process. This two-step process is applicable to octal and hexadecimal numbers, as we have seen in last two slides. So here we are done with the conversion. You will get the code in the description. Download it from the GitHub. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will discuss the very important topic, why string operations is important in VLSI. Now, string operation means whatever string operations we are going to do in rest of our slides and upcoming episodes of string. So why they are important? Why you should learn string so well that you can use it as per the need of the VLSI. Now, what are the needs? When you know, you have the proper motivation to learn the strings. Next, we will go in the technical stream after discussing the need, and the very first technical point is accessing element and slicing of string. Next, we will talk about the change case and checking of start and end of a string. Next, we will talk about counting, replacing and converting to a list. So here we will consider the string as a list and we will do these operations, the counting, replacing and converting. Next, we will do the concatenation or joining of the strings. That means you have two separate strings or you have more than two strings which you want to join together to make a new string. So that we will learn how to do it in this particular slide. Next, we will go for splitting of strings, the single delimiter. We can split a string based on a particular delimiter. Now, we will try out the splitting mechanism using a particular single delimiter. Next, we will go in more detail and we will use the multiple delimiter method for splitting of strings. In the final slide, we will discuss escape sequence in strings. So these are very important because this also you might have seen in programming language like C or Perl. So what are the escape sequences? We will learn and go through them. So here are the list of topics that we are going to cover today in this episode. And before beginning any slide, I would like to mention that you will get the codes in the video description which you can download from the GitHub link provided against each of the slide. So there will be a name, right, as per the usage and program, whatever we are writing here, and you will get them from GitHub. You will have to pick the link and download the code from GitHub. Without any further delay, let's begin. This is the most important slide before we dive into the strings in VLSI. Why string operations is important in VLSI? First, input-output validation. String parsing helps validate input data and EDA tool output file as a part of the VLSI QC/QA. Next, locating faults. It assists in locating the source of errors or faults by parsing error messages from log files. So the first point is about the QC and QA, that is quality check and quality analysis. So this is true for any other scripting language which can do parsing and string processing. The next point is data extraction. String parsing allows the extraction of relevant information from large data or text file for analysis. This means, say you have a long, large .lib file from which you want to extract some particular cell information. So you can have a script or Python module, and according to that module, you have to give the proper directions or instructions to extract the particular cell information from the .lib file. Next, compliance testing. It helps verify the compliance with industry standards by parsing the design output files or reports. Here we give an example, right? Some special part of a .lib file. Say the .lib files are generally created through the standard cell characterization process, but it may happen in your design house some extra data that is getting generated by your design teams for each and every cell, and that data is internal data to your company and that is not publicly available as a part of the .lib which you have received from the standard cell package or library or PDK or DK, whatever you say. Now that part, the extra part that you are generating, right, for the .lib, you have to do the compliance checking. That means whether it is up to the mark for the .lib as per the latest standards. So that can be done using the string parsing. That means the .lib, whatever part you are generating and writing, maybe you are entering or appending to an existing .lib file, or you are creating a separate .lib file, whatever is applicable. In that case, you can check whether whatever data has been entered is in correct format or not, or as per the compliance of the .lib or not. So this is another purpose of the string operations, that whatever we do with the strings, we do checking, we do parsing, we do comparing, everything that is needed at this point. So far we have discussed 4 points and we have more points for which we have to learn very carefully the string operations in VLSI. Next, automated string. String operations are crucial generating input test vectors. Whenever we are generating some test vectors for our design, we generally do not do it by our own hand. That means we do not type every 1 and 0 by our hand. So that will be done by some scripts, and that script, whether you are generating the data or checking the sanctity of the data, that has to be done by the string operations of the scripting language. Here we are talking about Python, because in front end most of the vector generations are done by the Python, because Python is very much popular in the front end VLSI. Next, enhances efficiency. On-the-fly string parsing improves the efficiency and effectiveness of the VLSI automation scripts. The string manipulation capability, that is whatever we are reading, we are checking, and maybe we are dumping it or writing it as a file. So this efficiency helps in the automation process. That means the string handling capability of any scripting language makes it robust for automation. The more it can deal with the strings, more it is applicable for the automation, because here whatever we are running in the terminal or what we are getting as an output, everything comes in form of text, and text is nothing but the collection of strings. So this is the basic difference between a grammatical perspective of a text and the programming perspective of a text. So there are two different perspectives. In grammatical perspective, we will check whether the text is correct or not, and for the VLSI perspective, we will check whether every data is as per our compliance and standards of the industry, file formats, or maybe a IEEE file format or an Accelera file format, whatever we are dealing with. We must be aware of the standards, and we will be able to check that standard through the string manipulation and string operation capability of any scripting language. The final point is ensures quality. Finally, all of the above together contributes to the overall quality and reliability of the VLSI design. That means when we have all these things together implemented in our script, that means the script or scripts or the bunch of scripts that the automation team is using, when they have all of these features enabled through the scripting language, that helps the design to become less error prone and many faults, that means the faults that can be detected by the computer and the programming language, are done. So the rest of the things, that means whatever remaining for the human verification, is in very small amount. That means you are having a less human effort for the design validation, whatever type of validation it may be. So that's the importance of the string operations in VLSI. We are focusing on Python, and most of these points are applicable to Python when the Python is used in the front-end automation. So here we are done with the slide. Let's move on to the next slide. Accessing element and slicing operation in string. So here is our first line of the code, and this is our Python interpreter for the Python 3. Next line goes our string, where we assign the value hello hello my world. Next line is a comment. We are accessing the characters. So first character, this means this, will be string 0. Again, the last character, that means this, will be accessed by string -1. Now here you can see we are taking the continuous string and thinking it as a list or array. So we are accessing each and every element. The concept is very similar to whatever you have learned in the C language. Next, we print the first character. Next, we print the last character. And next, we will move on to the slicing. Substring 1. Now, slicing means we have this, right? But we need a portion of the string, and this is a non-destructive slicing. Let me emphasize on this point. This is a non-destructive. That means we say our need is from here to here. That means from index 6 to index 11. Slice out that part and save it into another variable. But however, do not destroy the original one. So this is a non-destructive. The slicing in general, when you are slicing a fruit, it is destructing, right? When you are cutting a fruit, it is actually cut into pieces. But for string operations, it is a non-destructive one. That means the mother string here is not destroyed at all. That means it remains intact, and the substrings or the child strings which we are generating through the slicing process contains our desired target. The next example is that substring 2 is string that is :8. That means we are not mentioning anything here as we mentioned 6 here. So this means slice from the beginning up to the index 8. That means when we do not mention anything here at the first point, we get the string from the very first index point up to the index point we are talking about. Next, we are having the substring 3 is string, then 9, then colon, and then we do not have anything here at the last point. So what this means? This means slice from index 9 to the end. Again, I am emphasizing that all of these slicings are non-destructive. That means the original string is intact and you are extracting the part of the string as a new child string called substring, and the substring is not a variable. This is a concept. But however, to relate the concept to the variable, we have named all the variables as substring. Next, we print out the first one, second one and third one. And as we run this code in our terminal, we get the output here. So here you can see the first letter is H, which we got from this, and from this we got the last character as D, and D is nothing but this D, right? So the first thing is done here, the first part, and the slicing part, if you see right from 6 to 11, it gives hello only. It's your task, you find out the index and you see whether what we got is correct or not. However, since we are using the standard Python codes, so whatever you are getting is expected. That means we are getting in from index 6 to index 11, and this is a non-destructive slicing, and the first substring is hello. The next one is from the beginning to the index 8, and here we get hello he. That means from this up to this we are getting, and slice from the 9 to the end. That means whatever 9th is there to up to the end we will get, and here we can see LO my world. So this is LO my world is this much is going for this one. So this one is coming from this particular substring. First of all, to understand this, you have to run the code and do the modification in these numbers to understand in a more robust manner. In that case, so what will happen that once you change these index values and try out yourself, you can download the code from the video description from the GitHub link and try it at your end immediately after you finish watching of this particular video. So in that case, what will happen? That you will learn how to extract a part of a string. So this can be very important when you are parsing any file and you get a particular type of error message, and you know that from index X to index Y there will be some determining string that you need that is existing there. So you can extract that string and do the checking on that particular string. So for that you can use the substring and the slicing. We have other methods too, will come later in this series, not in this episode. So here we are done with this particular slide. Let's move on to the next slide. Change case and checking the start and end. Start and end means the start and end of a string. So here starts our code. First line is the interpreter. Next line is our string, that is hello hello my world. Next, we have a comment in our code for later understanding. We are changing the case here in the below codes. First one is the lower case. So here we have lower case. It will be this string and we will have operation lower. So by birth, the Python is an object-oriented language, and this is a function defined inside the class of the string, right? That you can make it lower, and we are using that particular function here as dot lower. So it will change the entire string in the RAM, not in this particular variable, and output will get in this particular variable. To get the uppercase letters, we will use the dot upper one. Here we will use the string dot upper. Remember, here we are using the variable name as string, and hence we are writing string dot lower or string dot upper. In case this is different, in case this is XYZ, then it will be XYZ dot lower and this will be XYZ dot upper. We are done for the changing case. Now let me move on to the next line. Here we are printing the two variables for our display. And next, we are doing some other operation. That is what? Checking strings starts with a specific prefix. That means we are entering this part, the checking of the start and end. First one starts with hello string, then we write here starts with hello. So this is an inbuilt function that it will check that whether the string starts with hello or not. So we will get a logical output here or Boolean output here. Next, we will print whether it starts with hello and give the variable name to check the out. Checking the string ends with a specific suffix, ends with world. So here we have world and we are naming the variable as per that. String dot ends with world. It will again give a boolean output, that means whether it is true or false. And here we print out that particular variable. So there will be lot of lines of code when you write a code, but however, what is the gist? That means what is the summary of the understanding? That will be very short, and that we are getting here in the output. So when we change to lowercase using this particular operation, we get the output as the lower. And when we are doing the uppercase, right, this one, and we are printing using this, and we get this particular output. You can see all of the characters are here in lowercase and all of the characters are here in the uppercase. So here we are done. And in the next one, we are checking hello, right? And I said it will be a boolean output. So if we check the starts with hello, it gives the true. Yes, it is true. True is a boolean output and false is also a boolean output, because only two outputs will be in a boolean condition, whether it is true or whether it is false. And next, what we have here is the ends with also true, because we have given the word. Once you get the code from the description and download it from the GitHub, you can try out changing these particular things into different words and check whether whatever output you are getting. So that is how you will learn the Python code. So here we are done. Let's move on to the next slide. Counting, replacing and converting to list. So here we will do all these string operations. Let us start the example. First line is our interpreter. This you get as you type which Python 3 in your Linux terminal. And in case you are using the Windows, you will not be using this line. You will be using the rest of the code, because they are the Geany, whatever IDE we are using here. When you go to the run instruction, it will automatically find out the Python and it will run. We have demonstrated this in the installation episode of this series. In case you have not watched, please go to the playlist of Python for VLSI, and from there you find out the episode. And to find out the playlist, you have to go to the channel homepage and navigate to the playlist tab. Next we have the string hello hello my world, and then counting occurrences. So here we are using the inbuilt function, that is the count. This is string, again I am saying the variable name is string. Then we have the string dot count and we type hello. We can see visually there are two occurrences, but as per our programming we have to count it, and for that we will use this particular string dot count operation. Next we print it, and here you say the occurrences of hello is count hello, and replacing the characters. Now let me move on to the next part of this code, where we are replacing. Then we say string dot replace hello with hi. So these two hellos will be replaced with hi. Next, the replace string we will print, and remember this is again a non-destructive because we are storing it into another variable. So the original variable will remain intact and we are getting the new changed string into another variable here. Next, splitting the string into a list. So here what will happen, right? Word list is string dot split, and here we write split and we don't give anything here. As a result, it will split all the things, and let us see what comes as the output. As we run the code in the terminal, we get the output here. So this split operation will help us to get the list here. The first element is hello, second element is hello, then my, then word. So that means it is splitting with respect to the wide characters. That means the spaces here 1, 2, 3. Now let us go back to the replacing character. We replaced hello with hi. So in that case we are getting this second line, that means hi hi my word, instead of hello hello my word. And here we check the occurrences. So here we can get the occurrences. How many times hello is there? It is 2 times, because we can see first and the second occurrence. So these are some basic operations on strings using the inbuilt Python functions, that is obviously as a object oriented language. These are already defined in the class of the string. Okay, so from there we are using. We must know all these tools, because when you are actually doing the scripting of the VLSI, right, that time you don't have time to go around and search whatever you have to find and from where. So that's why you are learning this ahead and getting yourself prepared for the proper scripting. Anytime you can come back to this video and you can use the chapters to navigate to the respective slide. Remember, chapters you can find from the description, or it is also available if you move your slider to the video playhead moves like that, and here you will see small chapters will be there, and if you click on the beginning of a chapter it will move. So chapters are also here in the video timeline, and as per the playhead moves, from there you can also come to any particular slide. Otherwise you go to the description and click on the timestamp before this name. So you want to come to this slide, there will be timestamp and then the name of this particular slide. Here you just click on the timestamp, playhead will move directly to the video position where this slide is getting webcasted. So here we are done. Let's move on to the next slide. Here we will do the concatenation or joining of strings. Earlier we have done the splitting, right? Now we will do the joining. So first line is our Python interpreter. This is not needed in Windows. First string is str quake. The next one is str2 is brown fox. And then we have str3 jumped over, and str4 is a lazy dog. And here we are doing the final concatenation. Concatenation means joining. We can use a simple plus sign here on the right hand side of the equation, where the left is a new variable and all these variables we are describing here, we add them 1, 2, 3, 4. In the sequence we are adding them. In the sequence the string will join. So if we change the sequence to str2 here and str1 goes here, then obviously the output string will be different. Print finals. Length, then final. Okay, so these two. Next 1, 2 and 3. So first we will print the final one, then we will check the length here, and then again we will print the length. So as we run the code in our terminal, we get this output. So here you can see the final string is a quick brown fox jumped over a lazy dog, and we have the length that is 40. So the output string length is 40, and this is the output string. So this way you can simply join different particular strings and into a larger string, and you can also check its length. Here we are done with this example. You can go download this code from GitHub, link in the description of this video, and try out changing over the sequences and the content and whatever you want to do, whatever way you want to play with it. So please go ahead and download the code and try out at your end. Here in this particular slide, we will describe the splitting of the strings using a single delimiter. Earlier we have done the splitting, but there was no delimiter, and by default the white space was taken as the delimiter. Now here we will do the single delimiter splitting. As bang user bin Python 3 text red, green, blue, yellow, white. So we have comma separated values of different colors, right, inside one particular string, and here we are naming the string as text. So we are not naming it as string earlier what we are doing. Next, we import the regular expression module, that is by the command import re. We will talk about the Python modules after a couple of episodes later in a specific episode for the Python modules. But the use is very simple. We can import entire module of the regular expression in our code by using this. Next, here we type the broken, that means whatever broken is variable. Later we'll type of variable is broken. We do the re.split. So this is a function defined in this particular module, and we use the delimiter as comma, and we give text as our input string on which we will do the split operation. And here we print our broken, and as we run the code we get this output. You can see this now is a list of the splitted strings. So that means when we split with respect to comma, we have different colors: red, green, blue, yellow and white. They are coming as the first, second, third, fourth and fifth element of a list. So this way you can do the splitting of a string using a single delimiter. Now here we are done. Please go ahead and download the code and try it at your end and try out with different combination as your mind thinks, and let me know if you are facing any troubles. So in the video comment. We are done here. Let's move on to the next slide. Splitting of strings with multiple delimiter. Let's begin our code. First line of the code is the Python interpreter, and next we have again our text. Here we have first one as the semicolon, second one as the comma, third one as the colon, and then again fourth one as comma. So we have multiple delimiters among the different colors, that is red, green, blue, yellow and white. Now we want to split every color like the previous example. How we do it? So here we again import our regular expression module, import re. And here the grouping is done by the brackets, that means the third brackets here. we say our variable broken will contain the broken parts, and here we write the re.split. So the split command is same as the previous slide, and it is a method or function defined inside the re module. So this will take the delimiters as comma, then semicolon, then the colon as delimiters. So all these delimiters will be used for the splitting operation of this string, that is text. And here we have our output as broken. Now as we run this code in our terminal, we get the below output. So you can see the output is same as the previous one. Here we are getting red, green, blue, yellow and white as the 5 elements of a list, and here we have used the multiple delimiter method of splitting. So we can see in this particular slide we have used multiple delimiter splitting to get the desired output. So we can see that in this particular slide we have get our desired output with the grouped splitting options for all of the group delimiters. So we are done here. Let's move on to the next slide. Escape sequence in string. So this is a very quick go through for this slide and the next slide. We will go through the escape sequences. Many of you know about these escape sequences in case you have learned the C language. In case not, you will get good informations here. So the escape sequence here is used for the special characters that are used for special purpose. That means if we are using a backslash, right, it will act as a special character. But to get the backslash as backslash, we will use the double backslash method, and output we are getting as a backslash inside the string. And in case you want to have the entire string, right, remember earlier we have said that we can get a raw string by the R in the last episode. So here you can see that we can do printing of a single quote by using a preceding backslash. So we'll get a single quote. For double quote, we have to use the backslash double quote. For B, that is a ASCII backspace. That means this is a backspace character, special character. This is a new line character. Okay, so all these you can get by backslash B and backslash N. Otherwise, the B and N will be treated as the normal alphabets. Earlier, this was different. Earlier, you have to get the normal one, you have to use the backslash. But for these two, to get the special treatment, you have to use the backslash. We continue here. So backslash T is for the horizontal tab. That means in keyboard when we are typing in a notepad, we hit the tab key, right? We get a jump of couple of white spaces. So this thing you can get with the backslash T in the print operation. Backslash V is the vertical tab, and backslash R is the carriage return, and backslash OTT is the character with octal value TT, and XHH character with the X value of HH. So these are the escape sequences that you can use inside your string while you are giving the print operation, right? The escape sequences are used only in the print operation. Remember this, nowhere else. We are done discussing about the escape sequences in string in a very quick fashion. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about a general introduction of what is regular expression, which is abbreviated as RE or regx. Next, we will talk about the basic regular expressions. Very next to it, we will talk about the extended or advanced regular expressions. And remember the name, the BRE and the ERE are the abbreviation for these two type of regular expressions. Now from birth, these two are different. So we will make you understand and educate you about these two, so that in case you see a regular expression, that means a code where the syntaxes of the regular expressions are used, you can identify whether it is a PRE or whether it is a ERE. Next, we will talk about in our Python which of these two are used. That means in Python whether we are using the BRE or the ERE. So that will make your mind clear which one to learn. Next, we will talk about the regular expression matching, and we will talk about the different syntaxes for range matching. Range means whether it could be a character range, it could be a numeric range, or it could be a alphanumeric range, or something in between. So we will talk about the range matching. Next, we will talk about the regular expression matching syntaxes for micro matching. That means we want to match each and every character or each and every numeric literals, all these things. So that means whether we want to match an alphabet or we want to match a number, and we are matching exactly as as they are written. So in that case, we will be using the micro matching. So using these two, we will start our syntactical journey for the regular expression. And before that, anything we have is a very conceptual part. You can use chapters in case you know anything of this and you want to directly jump to any one of this. So that's the menu for today. And without any further delay, let's begin. The regex or RE, these are the abbreviation of the regular expressions. Let us see an introduction so that you have a basic familiarity with the regular expressions. Regular expressions, that is REs or regex, are a specialized programming language originated from POSIX. The POSIX is a basic operating system feature that exists in both case of the Windows and the Linux and the Unix and the Mac OS. So you can learn about it. If you want to go in depth, you have to search in the search engine and get the details. So you can understand that regular expression came from the very operating system features. POSIX is called Portable Operating System Interface. Is a set of standards. So it is a standard. POSIX specifies common interfaces, APIs, and shell utilities. That means the POSIX allows some code or some instruction that could be made compatible with multiple operating systems which support POSIX. It ensures compatibility and portability among various operating systems. That is just we have talked about. Adhering to POSIX standards reduces the effort required for porting software or code. And this is why, apart from some few features or some few specific module, if you are using the basic Python code, you can use the code in Windows, you can use it in Linux or in the Mac OS or in the Mac OS. So it is portable, and that facility or that compatibility comes from the POSIX compatibility. The POSIX here is the full form. Already we have talked about. Basic regular expressions and extended regular expressions are the two types of syntax supported by POSIX. POSIX means at the operating system kernel level, these BRE and ERE are both supported. Now, these are something which came with the POSIX, and later on they were adopted by different programming languages like Perl, Python, Ruby, Java, etc. So, the BRE and ERE came with POSIX, which came from the operating system itself, and it was created because of the software code portability from one operating system to another. You can see that any software that you are using today in desktop, I'm talking about desktop or laptop, in that case, you find generally if there is a software, right, that is available for Windows, that is available for Linux, that is available for Mac OS these days, and that compatibility feature came from the POSIX standards. And we have the same thing for the regular expression. That means regular expression is not something that is exclusive for Python or Perl or something like that. It's a general feature that came from the very basic thing in an operating system. So I want to clear your mind before we jump into or dive into the regular expressions in Python. You might think that something is fascinating about the Python and the regular expressions are exclusive to Python. No, it's not like that. It is there with every advanced programming language nowadays, and Python has adopted that from the POSIX, and we can use our syntactical skills to write regular expressions for string matching, text matching. So we are done here. Let's move on to the next slide. Basic regular expressions. Here we talk about the basic regular expression that originated from the POSIX. BRE is a type of regular expression syntax used in various Unix utilities. Why we say Unix utilities, you will come to know, because these are things that when you learned Linux, you came across the sed and awk, right? In those binaries, some of them supports the regular expressions, and I think BRE is there. We have an entire series on the bash programming where the sed and awk programmings are discussed. Please go ahead to the playlist and watch those episodes in case you are curious. It provides a basic set of pattern matching capabilities. So this is very beginning or primitive set of regular expressions which can be used for text matching. What do you understand by text matching? Now this is a very good question, right? So I want to match this word, right, the basic, with some programming instruction. When it reads the entire string, I have to check whether this particular word is there or not. So that is called the text matching and string matching, whatever you say, and that is the purpose of the regular expression. BRE uses a subset of regular expression syntax compared to extended regular expressions. That means BRE was first generated, then the ERE. That means ERE has a greater coverage and BRE has a lesser coverage, and hence the BRE is a subset. Now the first common BRE matching characters include star, question mark, set of brackets, this one, the caret and the dollar. Okay. It does not support features like alteration, grouping with parenthesis, and quantifiers like this one, the second bracket. So by now we know what are there and which it do not support. BRE treats meta characters literally, that means as they are, unless they are escaped with a backslash. That means what is a meta character, right? Backslash n, that is for the new line character, all these things. So BRE treats meta characters literally, that means they think that is a text as is until or unless that meta character, that means a backslash n, is preceded by another backslash. Until or unless like that you are writing, it will treat as a normal string. It is the default regular expression syntax. Utilities like grep and sed unless we have specified to use the extended one. So this is I was talking about at the beginning, right? When I highlighted the Unix utilities. Those utilities are grep and these are sed. So these utilities use BRE, that is the basic regular expression, until or unless you use a special flag to incorporate the ERE. BRE is generally more portable across different Unix-like systems. So BRE is a very portable thing across Unix-like system. That means why we are saying Unix-like system. So today there are a lot of variants of the Linux. We have Red Hat, we have SUSE, we have Debian, we have Fedora, we have Ubuntu, and there are lots of many more Linux distributions. So these are we term as Unix-like system. That means today we have several number of branches and sub branches, and all of them supports the BRE. And you are writing any code, any regular expression syntax for the system utilities like grep or sed, that will be portable across these operating systems. Now here we have done discussion about the BRE. Let us move on to the next slide. Here we will talk about the extended or advanced regular expressions called ERE. ERE is an enhanced version of the regular expression syntax compared to the basic regular expression, that is BRE. This is an enhanced version and this is a superset of the BRE. That means whatever features you have in BRE, you have them in ERE, plus there are some more features. It offers a broader set of pattern matching capabilities. So that means we have more handyman tools for our work. ERE includes all the features of BRE and extended them with additional meta characters and constructs. So this is very technical thing and it's easy to understand. Let's move on to the next point. Common ERE meta characters include plus, pipe, set of brackets, that means first bracket, second bracket, and backslash. So these are meta characters from ERE. ERE supports alternation, grouping with parenthesis. Obviously, this grouping has to be done with parenthesis. Quantifiers for specifying repetition and more. So you can see the features in ERE are much more than the BRE, which we have talked about in the last slide. We have much more advanced features which are giving us more powerful handyman tools. Engineer our code. Meta characters in ERE do not need to be escaped with a backslash unless they are conflict with the literal characters. So here we can use a backslash n as a backslash n and they need not to be escaped unless you want to specify it as a string. That means this point we are exactly opposite to the BRE. ERE is widely used in shell utilities like awk, egrep, grep with e flag. So I was talking about until or unless we give a special flag. Here you can see we have a -e flag for the grep binary to use the ERE. That means if you are not using the -e, you are using the BRE syntaxes. Also in Perl, Python, Tcl, etc. the modern scripting language. That means ERE is adopted easily on all of these modern scripting languages. Using ERE can provide more flexibility and power in pattern matching compared to BRE. So that means we have a superset of tools and those we can use for our regular expression syntaxes, writing and matching. Here we are done discussing about extended or advanced regular expressions. Let us move on to the next slide. Now here come the crucial question. Python. After discussing BRE and ERE, you are wondering, okay, now Python by default uses which one? Either it is BRE or it is ERE. How should we know? Python's RE module supports both BRE and ERE. So that means we have support for both of them. By default, Python uses the ERE syntax for regular expression. That means you have to learn the ERE for Python programming, not the BRE. Here your concept is clear. So you have a complex regular expression you have seen somewhere using with grep or without the flag dash e, right? And you want to port that into Python. That time you should be very careful because there it was using the BRE and here the Python is using ERE. So there will be a syntactical mismatch. You have to do the correct mapping or the correct change to implement the regular expression in Python. To use BRE syntax in Python, you can specify re.ascii or re.local flags when compiling the pattern. So that means these are two flags that can be used to access the BRE because by default Python is using ERE. The re.ascii or re.local flags indicate or force that the pattern should be interpreted as a basic regular expression, that is BRE. In Python, the focus is primarily on the regular expression syntax supported by the RE module. We have a module, RE module. So that module, we are focusing primarily on the expressions supported by it. The RE module provides expanded features by default, conform to ERE. That means these syntaxes are highly matching with the ERE. So you must be focusing on learning ERE. Regex are used to define rules for matching strings such as sentences, email addresses, or log file error or warning messages. So this is very important because in VLSI, sometimes you have to read a log file and capture the error or warning message to find out the faults. It could be in front end, it could be in back end. Wherever you are parsing the log, your main scope of interest is on the error or warnings. That means the circuit is not behaving properly. Sometimes it could be due to a warning. Warning, it's not an error or it's not a fatal, right? I have not talked about fatal here. It could be error, warning or fatal. In case you have a fatal, that also has to be taken care because something which is terminating the run of the simulation or something like that. So that has to be well taken care. And if it is a warning and it's not an error, that warning message might have some impact on the next error. That's why the error and warning both are important to be observed while you are doing the pattern matching and parsing a log file. Next, they allow you to check a string matches a pattern or if there is a match anywhere within the string. So it could be a partial matching or the whole matching. REs can also be used to modify strings or split them in different ways. So these are different set of operations with the strings for the automation and the parsing and the QC and the QA, whatever you are doing using our Python code. Regex patterns are compiled by bytecodes and executed by a C-based engine. This is some technical information which happens behind. You don't have to learn it. You have to just have a proper overview of this point. That's all. Not all string processing tasks can be efficiently handled by regular expression. So this is another thing. If you think the regular expression is something that will give you all the solution, no. In some cases, you have to do something else to get your desired results. So this is a realistic overview of the regular expression. That means if you think that you have some magic tool with you and that magic is going to help you in every step, no, there could be some other ways of shooting the problem and those might not be the regular expression. That might be something else. These things can be handled case by case basis and not in a generic manner. Hence, we cannot have a generic slide or generic information or generic set of bullets on them. So once you start working, this will be gathered within you from the working experience. We are done discussing about the Python basic engine for regular expression. Let us move on to the next slide. Regex matching, the range matching. From this slide, we will start diving into the Python's regular expression syntaxes. And first, we will talk about range matching. That means it could be a alphabet range or numeric range or alphanumeric range or something in between. Let us see what are there for us. Matching various sets of range characters is a key capability of the regular expression. right? Now first we have \d. This is a regular expression, right? We remove the quotes and use the \d in our regular expression. What it matches? You first know the rules before you can use them. So in this slide we are teaching you the rules for range matching. Now \d matches any decimal digit equivalent to the class 0 to 9. That means we have a range of numerics from 0 to 9. It could be different combinations of 0 to 9. Okay. \D matches any non-digit characters equivalent to the caret then 0 to 9. Caret means not the 0 to 9. That means anything which is except any numeric combinations of 0 to 9. This will be matching. That means we have a positive match here and we have a negative match here for the decimal digits 0 to 9. \S matches any white space character equivalent to \T, N, B, all these things. Any white space character. And \S matches any non-white space character equivalent to the not of all of this. Now, again we can see that this one is the not of this, as this was the not of this. That means we have a completely opposite set of matching. That means in the range matching. \W matches any alphanumeric characters equivalent to this, that is A to small z, that means small a to small z, capital A to capital Z, and 0 to 9. So if any combinations of this, \W will match that. Next, if we use \W, it will match non-alphanumeric characters, and which is represented by this group where we have a negation, that means a not or the caret character followed up by small a to z, capital A to Z, and 0 to 9. Dot matches anything except a new line character, and there is a alternate mode re.all where it will match even a new line. So dot is often used when you want to match any character. So this is all the set of regular expression tools to match a range of characters or alphanumeric characters or any combinations of them. So let's move on to the next slide. Regular expression matching, micro matching. Here we will not match a range, rather we will do the micro matching, and here we will match exactly some of the characters or some of the numerals. Regular expressions allow specifying repeated micro positions of the pattern. So these are micro positions. The meta character star matches the previous character 0 or more times. That means we have A and then we have a star. That means we have 0 times A or more than 0 times A. For example, cat matches CT. Here you can see the star in between the cat, and this will match CT, the cat, and the CAAT. That means this A could be 0 times, 1 times, or many times. The meta character plus matches the previous character 1 or more times. Here you can see in star it was 0 or more times. That means there could be a no match situation. But here we want at least 1 or more than 1 matching. Plus will serve that purpose. For example, this one, that cat with a plus sign here, matches cat CAT but not CT. The question mark, that means this one, matches something as optional, matching either once or 0 times. That means this many times is not possible, but either it is once or 0. That means either this case or this case will be served by the question mark. For example, home brew matches home brew or home dash brew. That means the dash followed up by question mark. The dash is absent here or present here. So that means whether it is absent or present, that is dealt with the question mark. The quantifier, this, that means within the curly brackets, right, we have m, n, and these are syntaxes. These are not alphabets of m and n. So these have special meanings. Specify the minimum repetition of m number of repetition and maximum number of n number of repetition. That means this is a minimum and this is a maximum number of repetition. That means it could be 1. That means we have the cat, and it could be 3. That here could be 3. Right? That means we have this one. So we can use that for specific matching. That means you are restricting your match. For example, A, then forward slash, then 1/3 matches A/B, A/B, and A/B. That means we can match 1 time, which is this one. In between 1 and 3, there is 2. This is 2. And the last one, we restricted to stop here, 3. So it can match this. Omitting either m or n assumes reasonable default value. Omitting m sets the lower limit to 0, while omitting n allows the upper bound to infinity. That means if we do not give m, it means 0 to n, and if we do not give n, it means that we are starting from n, it can go up to the infinite. So these are the micro matching factors which you can use in regular expressions. We are done discussing this. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about the regular expression module, that is RE module, and its compile method to deal with the regular expressions. In the first slide, we will go in the detail of this RE compile method. Next, using this RE compile method, we will do the basic pattern matching, definitely through code example. Next, we will do the group extraction for a pattern. We will extract groups. So we have multiple groups inside a single string, and we will extract all of these groups. You will understand once you see the example. That's why this entire episode is flooded with examples of Python code, which at your end you can simulate with Geany, and you can download the codes directly from the links given in the video description and from the GitHub website. Next, we will do the search and replace operation using the RE compile module. Next, we will do the splitting of a string with respect to a pattern using the RE compile module. Now, this is very different from the basic splitting which we have done in the string episode. Next, we will detect multiple occurrences of a particular pattern using the RE compile method. So this will be very useful because when you are parsing a log file of any EDA tool output in VLSI world, there you have to check for a pattern whether and how much time it is coming. That pattern you can detect how many occurrences have been there in the log file. That's the menu for today. Without any further delay, let's begin. Let's talk about the Python RE compile method. Regular expressions are compiled into pattern objects which have methods for various operations such as searching for pattern matches or performing string substitutions. Generally, we do the matching and substitution, and sometimes we extract in groups. So these are the common things that we do in the regular expression world. Whether we are dealing with Perl, whether we are dealing with Bash, or whether we are dealing with Tcl, or maybe we are doing with Python. In all of the cases, what we do most of the times is a pattern matching, do the substitution, group extraction on all of these things. And obviously there is another important, the splitting of string with respect to a pattern. Next, RE compile takes a regular expression pattern string as its argument and returns a compiled pattern object that can be used for various pattern matching operation. Now, this particular part, the compiled pattern object, let me highlight again the compiled pattern object. This is very much different from the Perl or Sed or Tcl. This part is compiled first. In the background, it will do some C++ compilation for the regular expression. As we have talked about the regular expression in last episode, that it is a feature of the POSIX. By connecting to POSIX, the compilation will be completed, and that compiled regular expression will be ready to use not only single time, multiple times in the Python code. Compiled pattern object can be reused for pattern matching, especially when performing multiple matching operations. That is just what I have said. The compiled pattern object provides various methods for pattern matching such as match, search, find all, find ITR, and more. So these are few things that you will come across in upcoming examples. It also allows for advanced operation like substitution and splitting based on the pattern. So these are two very important, the substitution and the splitting based operation, because in VLSI, when you are, say, you are having a Verilog code, you are having a Python code which is reading the Verilog code and modify it according to your need. So at that time, you may require to substitute something, or you may require to split and take the arguments, the splitted arguments, into your variable or array like structure and then reuse them. So that thing can be done easily using these methods. And the final output Verilog code will be something that is target. I have just talked about an example in VLSI how these things happen, because most of the cases there will be a sample parent circuit and there will be places where you need to replace things to get your case specific Verilog code. So once you are in front end, you will come across all these things. By compiling the pattern, you can set additional flags to modify the behavior of the regular expression matching, such as case insensitivity or multi-line matching. So these are some advanced things, that is the multi-line matching and case insensitivity. That means whether the text can be in uppercase, lowercase or mixed case. So these are advanced things. So you will have additional flags. Additional flags we have not covered in this episode. We will cover later. The compiled pattern object supports both BRE and advanced regular expression syntax, that is ERE. So BRE and ERE are the property of the POSIX, and by compiling the code, that is the regular expression code, it is connected to the POSIX, thus enabling complex pattern matching capabilities. That means it connects to the POSIX through the compilation and enables both BRE and ERE. Obviously there will be flag to control either of them. Generally we use ERE, that is the advanced one, because that is a superset of BRE in usage perspective and features perspective. Using RE compile helps to improve the code readability and maintainability by separating the compilation of the regular expression pattern from the actual pattern matching operation. So we split the two things. One we compile, then we match. So this one will stack in case you are writing something wrong and you will not move to this step. Here you have to correct at the compilation and then you have to do the matching. So once you are compiled in without any error, you can proceed for the matching. So that means your entire process is split into two halves. One half is correct, then you will go smooth on the other half. So we are done discussing on this slide. Let's move on to the next slide. Basic pattern matching. First, we have our hashbang user bin Python 3, that is the interpreter. Next, we import the RE module. Remember, we are importing the regular expression module and this is a must. So in case you forget to write this line, the code will be defunct. Next, we have a variable and we compile the regular expression using RE compile, and in the argument we give R means raw, right? And we give A, B plus C. Plus, what does plus means? You can recollect from the last episode, okay? And we compile the pattern here. Next, we have done the compilation here. Now, we have to use this pattern to match, right? Then we are using the pattern and we are using the method match. And we are giving the argument A triple B C, right? That's the matching. So, we will now check the result. If result is true, then print match found. That means this will be either 1 or 0 as the matching result. 1 is true, then it will go to the if and go to this particular segment of code. Else, that means when it is 0, it will go here, right? This one, the no match found. This is a very simple code and we write our regular expression here. This one is our regular expression and this is our target string. So we can have this string somewhere else in other variable and we can pass that variable here also. Okay. Once we run this particular code, we find that the output in the terminal is match found. That means this plus means B, that is multiple times B is matched, and hence the result has come as 1. And by this 1, we proceed to this line and we see the match found, and hence the output is match found. You can download the code from GitHub. The link is in the description. Go ahead, run it, do some modification, try out your different regular expression that you want to do with this particular code to see whether your given regular expression pattern, that means this thing, and the target are 1:1 matching or not matching. We are done with this particular slide. So let's move on to the next slide. Extracting groups from a pattern. So in this particular slide, we will identify different groups of texts with obviously different set of regular expressions and we will try to match them from a given string. First line goes as the interpreter. Next, the most important line, we import the RE module. Next, creating groups using first bracket. Next, we compile our pattern and store it in a variable, and our compilation is pick this one. So here we have \d, that is 3 times \d, that is 3 times, and backslash d 4 times. Backslash d, you remember, right? It could be a range from 0 to 9. I have already explained in the last episode. In case you are not able to recognize, please go ahead and watch that episode. So what it will do, it will scan for 3 groups of numerics, first, second and third. The first two will be of 3 digits length and the fourth one will be 4 digit length. Now we apply this pattern here and using the match function, and this is our target string, that is 123-456-7840. Remember, we have already put a dash here and dash here so that we can segregate. Now remember, we have first level of parenthesis here and the second level of parenthesis here. Only 2 matches are there. So there are 2 groups. One is this, another one is this. However, we have used 3 different set of regular expression matching. So this return value will be either true or false, that is 1 or 0. Next, if the result is 1, what will happen? Area code result, then group 1. So this first one, it is termed as group 1, first group, and this is the second group. So this will be second group. So we have result.group1 and result.group2. In case it is coming as a positive, we will have all these 2. To access the groups, we have to use the method called group, and we have to give the index 1 for the first group and index 2 for the second group. The first group we have stored in the variable area code and second one as phone number. Next, we have print command, and there we are printing the area code, that means this one. The next print command, we are printing the phone number, and we are printing the phone number here. Else, if we do not match, that means we have a 0 result here, sorry, not here, 0 result here, we will reach that no match found. So if true, it will go here, and if false, it will go here. Once we run the code, we get the output that area code is 123 and the phone number is 456-7890. So you can see we have the first group matching here and the second group matching here using the regular expression this and this. So this is the way you can do the group matching. Now in this case, we have all numerics. It could be alphanumeric or only alphabets. As per your requirement, you can change. You can download this code from the GitHub. The link is in the description. Go ahead, modify this and these as per the learnings from the last episode. Change it as you want and then run the code and get the output and see whether you are getting an expected output or non-expected output. Here we are done with this particular slide. So let's move on to the next slide. Search and replace. The search and replace we do every day in our text processor. We find some particular word and we replace it with maybe one word or a phrase. So that thing you have to do within your programming language. That means here we are doing it in the Python. What we have to do? Let us see our example code. Code starts with the interpreter. Next we have the import RE. And this is the most important thing. If you do not write it, the code will not be running. That means the entire rest of the code here shown here will be defunct. And one more thing, in case you are using the Windows, as I have shown earlier in the installation and the usage episode, this line you need not to use within Windows. That means this line can be omitted easily when you are writing the code in Windows. Next, we have the compilation coming up. We write pattern, then RE compile, and here we write our regular expression \b, then apple, and then \b. What is \b? In case you do not remember, go ahead back to the last episode. There I have explained in detail. Next, we have our text. This is our text, and we have apple here and we have oranges here, right? This substitution, what we are going to do is a non-destructive substitution. That means this particular variable and its content will be unaltered. Whatever is modified will be coming as the output and we can store it in another variable. So this is our new variable which will contain the non-destructive substitution. That means this will be unaltered and whatever changes as per our substitution will come in this particular variable. And what code we have to write? We have to write pattern. That means this is our compiled pattern. Then sub. Sub is the method which use the search and replace. That means this is the thing that has to be replaced. And this is what we are searching for. Remember, this particular method will contain only the substitution part in the target text. That that is here given, and here we have to give the search pattern, right? Now remember, the search and replace is not in a single one, so it has been past part 1. Here we are doing the compilation of the search, and second part here we are doing the substitution. So this word we have to find and substitute with this particular word in the target this text. So text is this one. So you remember carefully, because in our text processor we have side by side words, but here first we compile and then we substitute using the import re method. There are other methods of the substitution that I have already discussed. So that is the basic string replacement, but using the regular expression, when you have to replace the thing using the regular expression, you have to follow this method. Next, we print our updated text, and once we run the entire code, we get the output as this. I have a banana but I prefer oranges. Earlier it was I have an apple but I prefer oranges, and we have find apple and substitute it with banana. Hence, this text has become here the new one. But one thing you carefully notice, this is unaltered. That means this variable, the content of this variable is unaltered. Whatever we got in this particular variable. So these are two different variables and these two have different contents. Okay, so we are printing only updated one. So this is a non-destructive search and replace. Okay, so here we are done. Before moving, where this can be used? This can be used, say you have a parent spice deck or you have a parent Verilog file, which is their simulation. You have to modify multiple parts of that file. So this is your parent file, and see here you have to modify, here you have to modify, here you have to modify. Not the same thing. This is different, and this is different. Different things you have to modify at different parts. For that, you can compile multiple patterns, so pattern 1, pattern 2, pattern 3, pattern 1, pattern 2, and pattern 3, and you can parse the text and modify at this particular lines. Okay, and there you can replace the things and get a derivative, either a Verilog file or a spice deck. So these are common because nowadays in the front end you will have mixed signal simulation where both the spice deck and the Verilogs are simulated together. So this is fine, and let's move on to the next slide. Splitting a string with respect to a pattern. Now earlier we have done some splitting, but that is a basic splitting. Here we are doing the splitting as per a regular expression pattern. So this is different from any earlier splitting we have discussed as a basic string splitting. And here we can do the pattern compilation using the recompile module. So let us start the code. First line, obviously the interpreter, this one. Next we have the most important line, import re. Next we have the delimiter, non-alphanumeric characters. This is our comment, and here is the code, right? The pattern is recompile is common, and here we are giving the \w plus. So non-alphanumeric characters. In case you are not able to remember, please go ahead to the previous episode in this series, and there I have detailed explanation of this w. Next, our text under consideration is this one. Next, we have a non-destructive split. Again, here we are doing a splitting which is non-destructive. That means this particular variable and its content will remain intact. Whatever we get as an output will store into a different variable. So here we have words which is different from text, and there we are using the compiled pattern and we are using the split method, and there we are giving the sample text. And once we done this, next we will print the words. So this will be a list or array, whatever you understand. So this will be a list, and once we run this entire code, what will be coming as the output? So there will be different things like this is a sample sentence, and there is a space character also. So here we have done the compilation of the delimiter, and here is our target text, and here we have done the non-destructive splitting, and as a result we are getting this list or array, whatever you say, and the elements of that particular list or array are this, which are comma separated, and you can see it. Go ahead, do the changes here and here. You can download the code from the GitHub link provided in the description, and from there you can change this particular code with other different things as well as the target string, and do the trial and error to see how you are getting efficient on the pattern matching. We are done with this particular slide, so let's move on to the next slide. Multiple occurrences of a pattern. So this is very important when you are parsing a log file of a EDA tool output. Say whether this generally work when we read a log file, we look for either error, warning, or there could be messages. So EWL and M. These things we generally search for in a log file, and obviously this, and there could be another thing, F, that is the fatal. That means with this the tool has stopped running and not proceeded anymore. So these are the common things that we search in a log file. But for that occurrences, to find that occurrences, we have to do a multiple occurrences search. So a simple code will be shown here, not the log file one, that you can develop at your end when you are pro with the Python coding. So here goes our first line, that is the interpreter obviously. Next one is the most important line, the import RE. And here we are doing the find the numeric patterns. So we have the pattern and then we have the RE compile method and we are using \d plus. So in case you are not able to recall, please go ahead and see the previous episode. There we have talked about these things. Next, we have our target text and here all these things are there, which we will do the searching. Next, we have our match part and matches, and here we have the pattern which is compiled from here. So this compiled one comes here and we invoke the method find all, and here we give the text. Text means this one. So this one we have compiled the regular expression and then we are applying it on this particular text to this particular command. And finally, we print the matches. Once we run the code, we get the output as 1, 2, 3 and 4, 5, 6. So this is the numerics, right? So we have two set of numerics with multiple occurrences here and here. We have find out all of them, right? This. So go ahead, download the code from GitHub, link in the description, do the changes here and here as per your creativity and try out the code and see how you are getting used to the regular expression in Python. So here we are done. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about the OS module and various example of this module as a Python code which is used for tool automation in VLSI. Next, we will talk about various types of dealings with the operating system. The basic operations we will cover here through Python code example. Next, we will talk about the methods to convert a relative path into an absolute path and extract file name. This can be very essential when you are dealing in a shared network drive area while you are working in a VLSI company. Next, we will talk about the common path and prefix extraction from a group of paths. Generally, this group of paths can be received from a environment variable while doing the automation for your VLSI tools through Python. Next, checking of a file or path whether it exists or not. That means the given path, whether it is an absolute path, whether it is a relative path, we will use a Python code that will ensure that whether that particular file or path does exist or not. Next, we will talk about globbing. Now, globbing is nothing but the kind of find a particular file type, say txt, inside a particular directory or inside a particular path. So globbing is that thing. We will use Python code to do the globbing. Next, we will do the file name matching so that you can match a required file name in a given path. Next, in the last slide, we will talk what is the equivalent of parse chomp in Python. Parse chomp actually trims out the trailing whitespace characters of a particular string. Actually, this is very useful when we are dealing with any file name to remove the trailing whitespace character, whether it is \n, \r, whatever. So removing that, we will talk about the methods in Python, the methods available in Python to do the parse chomp kind of equivalent work. So in a nutshell, we will do today's episode two different Python codes serving our purpose in the way of VLSI EDA automation. So that's the menu for today. Without any further delay, let's begin. OS module, tool for automation. In this slide, we will talk about the introduction of OS module to you, and this module and its various components can be used for the VLSI EDA automation. The OS module, the command we will use, the import OS, provides a portable way to use operating system dependent functionality. That means whatever operating system related commands are there, you can execute them through Python. OS specific extension available in OS module but may impact portability across different OS. That means once you develop the code maybe for Linux, it may not be portable to the Windows. That means whatever code you are writing for Linux, that cannot be ported into Windows, and vice versa. So that means even if you are doing a code for Mac OS, you cannot port it into the Linux. That means whatever OS you are in and where you are coding, your codes will be very much specific to that particular OS. And it's not a global code, it's a local code with respect to the operating system you are working on. This thing you have to remember, because previous all codes whatever we have discussed in series is almost portable across different OS, but this OS module and its components whatever we are using will be particularly to a specific operating system. And here in VLSI the background OS is either Linux or Unix, so we will code according to that in our today's episode. We can use the os.path for path related operations and manipulations. We can use file input to read lines from command line files. We can use temp file for creating temporary files and directories. So this is a very important factor, because when we are doing the EDA automation, right, we have to keep something in our mind that for a while we need to work on some temporary files, and that temporary files and directories we can create through our OS module. And once our work is done, we can delete those temp file or directories. OS module functions accept both bytes and string objects for path or file names. Next, OS module functions in the module raise OS error for invalid or inaccessible file names, paths or unsupported arguments. That means when you are using a file path or file name, if there is something invalid, that means it doesn't exist or something like that, we will get a respective error, and our OS module is well equipped with that. So that's the short and sweet introduction to the OS module, what it can do and what it cannot do and what are the options. In today's episode we will talk about some of these options through Python code, and we are using Python 3. So we are done here in this particular slide. Let's move on to the next slide. Dealing with operating system. Here goes the first line of our hashbang user bin Python 3. This is our Python interpreter, and remember we are working only and only in Linux as we are talking about the EDA automation in VLSI. So we will restrict our code, at least in this episode, for Linux operating system or Unix operating system. Next, we use the most important command, that is import OS. We are importing the OS module from the Python library. Next, we write the variable pwd is equal to os.getCwd. You remember that in Linux we have a command pwd, and hence we have named our variable as pwd, and we are calling the method getCwd from the OS module. That means get current working directory, and the result will be stored in this particular variable. In the next line, we do the print operation of this pwd. Next, we are using the os.system command, and whatever we write in this bracket will be treated as a Linux or Unix command, and accordingly that we will get an output. So in case you do not have a pre-listed method or function like getCwd, you can go ahead, use the os.system and then use your known Linux command here to get a desirable output. We use the rate variable here, and next we will print it. So here we print our read variable to get whatever we get as a ls command in our present working directory. So first we do the print of the present working directory. Next we do a ls in our present working directory. Next is the most important function that can list whatever things are there in the entire module. So this is not only for this particular OS module. This command can be used with any of the modules that you can import. First, here rate is equal to dir then OS. So dir command will list all the modules that are available in this particular OS module. Here we are talking about OS module and hence we are giving OS. In case we are using some other module here, we can use it here. And next we print rate. And once we run this code, we get the below output. So first one, when we do the print pwd, we get this. So this is our first output. And this was inside the my documents, and then we have a Python tutorial and then Python test. This folder we are writing the code, so it gives the directory, the full path to this particular directory or folder. Next, as we do the os.system then ls and we print here, we get all these files. That means all these files. So here you can see all of the Python files are there. So these Python files are nothing but the codes that we are going through this particular tutorial, and whenever I am writing any code, I am trying it out and then I am putting it into the PPT so that I can present the code to you, and the directory contains all the codes that has been written by me whatsoever, and those names will be printed as by the ls command. Next, we give the dir-os command, and here you can see that all the methods here are printed which are available in OS. However, this was a very long list and I have just truncated it so that you can get a quick view. But however, it was very long list. However, I have truncated it so that you can get a quick view of the things that are available in the OS module. But don't worry, the most important things in the OS module we will cover through examples in this episode and the next episode. So here we are done with this particular slide. Let's move on to the next slide. Here we will do a relative to absolute path conversion and the file name extraction through Python code. First, here is the first line of the code, that is #bang user win Python 3, as we are using the Python 3 interpreter and the Python 3 coding. Next, we write import OS. Next, we write a relative path, and here we have created a file with some text in the file.txt, which is one directory above, just above our present working directory, and hence we are giving within single quotes the file.txt, and above that we are writing .. means we go one directory above and there is a file.txt. With our knowledge we are creating this file. However, when you are working in actual VLSI IDE automation, you will get this particular file maybe as a sum tool output, or maybe from a log file, or maybe sum tool output file. Next, we will convert this apps into absolute path. This relative path we will convert now into the absolute path. For that, we write the command absolute path is the variable, and here we write os.path then abs path. So we have OS module, inside that we have path. I have just described in the introductory slide, right? We will use the OS path, and here we will use the abs path method or function to convert this relative path. This value goes here, and this abs path method will convert it into the absolute path, and then we print the absolute path as the print command. So we give the print relative path and the relative path, and then we print the absolute path and then absolute path, so that we can compare the relative and the absolute path side by side. Next, to get the base file name of the file, so we have a file name and we will get the base name. We write the command here starting with a variable. The file underscore name is os.path. Again you can see os.path is again used, and the method is here the base name, and then we give the relative path. Relative path means this content will go here, and we have the file name is file.txt. So we want to get that particular name, and then we print the file name, that is from relative is file name, and here again we use the same variable, as we do not want to use another variable. We done it like that, and we get the OS path name then base name, and we give the absolute path. Absolute path is from here, we get it. And in this case, it must show also the same, that is the file.txt. There is another print command here as the absolute path, and from there the extracted file name. So once we execute this particular code, we get the below output. First, you can see the relative path here, the file.txt. This is the relative path as we have written here. Next, we get the absolute path using this apps path, and using this particular variable, it comes here as absolute path, and you can see that the whole path is stretched in long format. Next, we have the relative extraction. That means the file name extraction from the relative path is file.txt, and we do the same for the absolute path. That means from this path and this path we have extracted the file name, and since this is same, we are getting the same output in both the cases. So we are done with this particular code. You can download the code from the GitHub link. The link is provided in the description. You can go ahead, you can do some modifications, and you can try out at your end. We are done here with this particular slide. Let's move on to the next slide. Common path and prefix extraction. So here we will do the finding out of common path. That means we have several paths and we will find the path that is common in all of them. And here we can extract the prefix. So here goes our code. The first line is our Python interpreter, that is has bang user bin Python. Next, we use the import OS command. This is the most important. Don't forget to write it. Next, we have paths. There is a list, right? And here we manually give the paths, right? Here the first one is there, second one is there, and third one is there. And we close the list here. So these are the files, and you can see here we have something common here in all of them, and we want to extract that, right? For that, what we have to do? Here, let's get the common path and prefix along the given paths. We give a variable name common underscore path, and we can write the OS path and then the common path method or function to extract the common path. That means this one up to the documents, right? Here we give the list of the paths. Next, we write another variable common prefix. Prefix means it may be a path or it may not be a path. However, whatever up to which this is common, whatever string there is common among all these paths, that will be extracted by this method, the common prefix, from the os.path. And here we also give the list of the paths. Now let us print the common path and common prefix. We write print common path, then common path. This is the common path variable. And we use the print common prefix and we give the common prefix. Once we run this particular code, we get the below output. As we all know that common path is up to home, user, then documents, and then the common prefix is up to documents and then F. So you can see there is a slight difference. The common path is up to this and the common prefix is up to this. So we are done here in this particular slide. Let's move on to the next slide. Here in this slide, we will talk about checking whether a file or path does exist or not in the physical disk. In VLSI automation, this might happen that you get a file path maybe from an output log file, maybe from some other tools output, or maybe somewhere else in the entire chain of the automation. But you want to check whether that particular path or file exists before you want to pass it on to the next automation step. It may be a tool or it may be some processing using your Python code. For that checking, what you will use. So let's start our code. The first line is hashbang user bin Python 3, our interpreter. Next, we do the import OS. Next, we write the path is equal to file.txt and we have a // before it. That means it's a relative path. In previous example, we have used this. That means we know that this file exists. But in real case, this you have to be certain by using the next line of codes. If os.path then L exists, then the path, that means if this path exists or the file name exists, we will print the path and the file name. Here we are using the if. We'll shortly talk about this if. Next, in the else part, we have that it does not exist. So if it is untrue, that the checking is untrue, that means this file do not exist in the disk, we will print a different message. So this way we can take a decision whether we will pass on the file name or path to the next step of automation in Python or not. Here, let me talk about the if. The print with F statement in the code is provided as an example of the F string. This requires Python 3.6 at least. That means we are using Python 3, and we said that in the beginning of the series that we are using Python 3.8 or Python 3.10, or you may use any version above. But to use the print with F, you must have at least Python 3.6 in your system. Next, an F string is short for the formatted string literals, allows you to embed expression directly inside the string by using the curly braces. So here the path, right? This is the path, and you can extend it inside the basic print operation. Once we run this code, we get the below out the path, and then we get the path and the file name here as a print exists. That means we know this file was there as per our previous experiences in the previous slide, and we have reached this one, the true condition. So in case we are reaching to the else, in a real case, we will issue some warning or error that the file doesn't exist. So we are done here. You can download the code from the GitHub link provided in the description, and you can do some modification as per your own trial and run the code. We're done here with this particular slide. Let's move on to the next slide. Globbing. Globbing is something that we give a path, and there we check some sort of file extensions are there or not. So for that, start our code here. It's a very short code. First we have our interpreter, and then we write the import glob. So this is not import OS, this is import glob. Glob is another module, and it has a very simple use. Like this, we get a variable rate. Inside that we use glob.glob, and then we give dot slash means present directory. We give star wildcard and .py means how many Python files are there, and then we print the content of the rate. And as we execute the code, we get the below output. So there are several Python codes that are being tried before they are put into our slide. So all those Python file names are found out by this globbing. So you can download this code from GitHub link provided in the description, and you can do trials as per your own and get your desired output. We're done here. Let's move on to the next slide. File name matching. In IDE automation, you have to multiple times check whether a particular type or style of nomenclature is maintained. Generally, this is for that you can use there. Let us start the simple code. First line is our interpreter hashbang user bin Python 3. Next, we have the import matching module. From fnmatch, it's another module rather than OS, it's fnmatch. We import the fnmatch. From fnmatch, we import the fnmatch. That is, fn is file name matching. Next, we have a variable rate, and we have fnmatch, and then we write hello.py and star.py. Okay, and we print rate. Next, we write hello, then fnmatch hello.py, then star.doc. So here we are matching whether these two are matching and where these two are matching, and then we do the print rate. Once we execute the entire code, first one, this one gives true because we have the same extension py here, and here the second one gives false as py doesn't matches with the doc. So this is the fn matching, and you know already about the regular expressions from the last episode. You can use the regular expressions also, but there is a module fn match. You must get aware of it, and this is the use of it. So you can go ahead and download this code from GitHub link provided in the description, and you can do some alterations in this code and try out at your end. So we are done here. Let's move on to the next slide. Now, here in this slide, we will talk about what is Python's equivalent to Perl's chomp. Now, Perl's chomps, whoever done our Perl course in our playlist, you can find it. There, we have talked about the chomp function, and it is very widely used. So, those engineers who are learning Python after Perl can relate this question, and this might be a very good question in the Python interview too. So, what is the answer of this? First, you can use s.rstrip. S is nothing but your string variable, and then rstrip, and then we use the carriage return and the new line characters to remove all the occurrences of any line terminator from the end of the string s without removing the trailing white space. Next, if the string s represents more than one line with several empty lines in the end, the line terminators for all blank lines will be removed. Next, since this is typically only desired when the reading text one line at a time using the s.rstrip, this works well. So you can use simple version the string.r string, and in case you need a wider version, this is there. So now you have the answer to the interview question, what is Python's equivalent to the Perl's chomp? Now generally, why we are talking about this Perl's chomp and its equivalent in this episode? Because generally this is used while we are getting the file and path name, maybe from a log file, maybe from our some other tool output, and like that, where there may be a chance of having some extra carriage return on inline character at the end. There you have to use it. And in Python automation, when you are dealing with the OS module, you may have some interactions like that. In that case, you can use either this or this as the Perl's chomp's equivalent. So you can use this or this as the Perl's chomp's equivalent in Python. So here we are done. Hey guys, welcome back. In today's episode, we are going to discuss the below topics. First, using the OS module, we will check how to get the software executable path. Why this is necessary in VLSI? Because when you are running inside a shared environment where the software is installed somewhere else and your files are somewhere else, you don't know actually from which path the softwares are being called. To get that data, you need to use this method. Next, we will talk about file last access and modification time. This is very important in VLSI because when you work, right, and you save the file in the physical disk, maybe on Friday, once you come on Monday, you need to check which file you have worked last. So the time and date stamp will give you that thing. This is very easily you can check with the Unix terminal, but in case your program needs to work in a fashion, that means your Python program needs to work in that fashion, we will use this solution. We will talk about how this can be done through Python, because the last episode and this episode we are talking entirely about the system automation, that is the IDE automation through Python. That means whatever things you can do with hand in the terminal, you will do all those things through the Python code using the OS module and other accessories that we have either discussed or we are going to discuss today. Next, we will talk about the file size, directory and symbolic link check. We know that when a file is in the hard disk, there could be two types of links. We have talked about this in the Linux series. In case you have not watched the series, the link is provided in the description. Go ahead and watch it. We will talk about all these type of checkings: file, directory, symbolic link, etc. Next, we will talk about the Linux or Unix directory listing. That means we have to list the files or folders in a specific path. How we can do that using the Python. Next, we will do the uname operation that we have already talked about in the Linux series, and the directory operation that we have already shown in the Linux series through Python code, and we will talk in this particular slide. Next, we will talk about the dealing with the environment variables. Now, this environment variable is very, very important in VLSI. Why? Because your tool license daemon and PDK or the DK, that is the physical location of the DK or the PDK, you need to set using the environment variables so that you can directly either access or set using the Python code, and we'll talk about these things in this particular section. Next, we will do some quick file operation, that is a read-write operation and the create operation, and mostly these are modes and we will talk about them. Obviously, we will have a file IO separate episode. However, using the OS module and the other accessories, we can do that things right away in the Python code, and we will touch base on that in this particular slide. Next, we will talk about the capturing of the system error and system module. We will talk about another module apart from the OS module, that is system module, some of its utility, not all of them. And we will talk about the system error. This could be error, warning, all those type of things that could come during a software execution. And if it is executed, how you will capture it and put into a log file, that you must know. However, we are not talking about the log file method here, but we are just talking about the capturing of the system error and reporting it on the screen. This is very important because when you write a Python code for EDA automation, that means you are juggling in between multiple VLSI EDA tools, and the Python code is used to synchronize all of them. That means tool 1's output is passed on to tool 2 and tool 2's output is passed on to tool 3, and like that. So in that time, if any error is happening at any stage, how you will capture that? So for that, this method is there. We will talk about. So we will conclude our EDA automation in this episode, and we have listed out the very important things that very much needed when you are doing a automation among multiple tools, or maybe among different binaries of a single EDA tool to synchronize and run the step-by-step things automatically using Python code. We will talk about that. So without any further delay, let's begin. Get software executable paths. So here we will talk about the method that we can use to get the path of the software. Say using a particular version, say version 1.2 of a EDA software, and there is another version also inside your system which is 1.4. In your case, 1.4 is preferred, but however you are seeing that 1.2 is being used, so you can trace back from which path this 1.2 version software is getting called, and accordingly once you get that thing, you can modify the path, because sometimes different tool version have different modification and enhancement, as the VLSI is a very dynamic world. So in version 1.4 some error or bugs may have been fixed which are still existing in 1.2. You want to move from 1.2 to 1.4, but externally you are not able to detect through the Python code which version is getting used and from which path. So this thing will help you to get this path and replace that with the new one that you want to do. Obviously we will need some environment variables which are discussed later on this episode, but however, to get the path, to fetch the path, you can use this upcoming example. So let's start our example. First line is our Python interpreter, this one. Next is the most important command, that is import OS. We are importing the OS module. Next is the command, get the list of the directories in the executable search path. That means whichever directories are there in the search path, let's list out them. So here we are fetching the list. Here we have a variable inside which we are storing the value which are getting through os.getExecPath. So this method inside the OS module or the function inside the OS module will help us to get the executable paths. Next, let's print all these things. First, we give the print command, right? It's simple print command. And next we give the for loop for path. Path is a variable and exec path, this is a list. So we will iterate and print path. So once we get the output using this particular method, that is the get exec path, we store it in the list and we iterate on the list to get all of these paths. So once we execute this code, get this output. You can see there are several Linux directories from which the softwares are being called, and you can see that all of them are listed out. So it is not a single location from which all the softwares in the Linux system that I was working while preparing in this particular slide or this particular program that has so many paths from where all the softwares are being called. So one software could be installed in this path, another software could be installed in this path. So this is what you can fetch. Now there is a environment variable called path which you can set using the set environment, which we will discuss later on, I think last or the slide before it. So there you can set the variables to include some other paths from where your desired version of the software will get picked up, and then you can do the recheck using this same method that whether that included path is coming in the list or not. So that's a task for you. You can do it, okay, after you finish the entire episode watching, right? And don't forget the link of this code. You can download the code from the GitHub link that is provided in the video description. So you can right away download the code, do the all experiment that you want to do. So we are done here. Let's move on to the next slide. file last access and modification time. So this is very important because hey, if a file is modified maybe 6 months ago, we don't want it. So we can get that data from this type of code, and we need a particular file that has been processed just last week. This is a weekend, and before that you have processed, you need that particular file. So that things you can check. Obviously we are doing a IDE automation. That means the code will do it, and how the code should do it with its intelligence we will talk about in this particular slide. So first goes our code. First line is our interpreter, and we are using Python 3, and next we are importing the OS module. It's the most important thing, and remember this thing, the OS specific codes are not portable. That means whatever we are writing for Linux, we cannot port it into Windows and vice versa. Okay. The next line is import time. There is another module we will deal with the time, so we are importing the time module. Next we have our path, that is the /file.txt. we have it here. We are defining a variable along with a physical file. So this is a physical file in your disk. You can create this file with some text input. Next, get the access time of the file. Okay, the access time is achieved by, we are setting a variable, and what method we are using, os.path.getTime, and then we give the path means this path will go here. So by this we can get the access time, that means when the file was last accessed. And you can see there are two dots, that means os.path then .getAtime. A time means access times. Here you can see this is a time, this is access time, and this method is already defined inside the OS module. We are calling it directly from there. Next, get the modification time of the file. Okay, now here we write another variable, modification time, then we write os.path, then get, then m time. You can see this is a time and this is m time. M is the modification time, and again we give the same path here, right? Very simple. Next, we write the format time in human readable format. Obviously there will be some system kind of time output which we will convert here. Now let's convert this. The formatted access time is time.cTime. Okay, so this is the method we are getting from time, not from OS. Okay, earlier the methods were accessed from OS module. Now this time is accessed, this method is accessed from the time module, time.cTime. Then we give the access time. Then we write the formatted modification time, that means this one. We write time.cTime, then modification time. So this comes as a human readable format, not something which is in the system format, but as a human being we can read it in the hour, minute, second format. Next, we print these two things, okay, using the print command. And in last episode I have talked about printf, which is valid for Python version 3.6 onwards. That means either you are using Python 3.6 or any version like 3.8 or 3.10 or any version upcoming, right? In that case you can use this if along with the print command. Once we execute this code, what do we get? So this is our output. The access time is this one, right? This one, and the modification time is this one. So in this case you can see both are same because this file was created just before writing this particular code, and then we had run this program and immediately both are same. But in your case, when you are working in a VLSI workspace, right, which you access through your VNC, right, VNC viewer, and there you will have this particular file somewhere in some other disk, not in your disk, maybe in some remote area. You are checking when this file was created. You will get these things as different, when the file was created and when it was modified. So this is the way you can check the times. You can download this code directly from the GitHub link provided in the description. Go there, download the code, and you can try it out at your end. You can do some modification or something else, whatever you want to play it with. Okay, and then you can run the code and get the output. Okay, the code is provided through a GitHub link which is provided in the description below. We are done here with this particular slide. Let's move on to the next slide. File size, directory and symbolic link check. So here in this particular code example, we will check what things we can learn to see the file, directory and symbolic link, all the kind of checks that we do generally in the Linux command line. In case you don't have learned the Linux, course of the Linux is totally free as a playlist, and the link is provided in the description. Go ahead and watch it. So let's start our example. First line is our interpreter here. The next line is most important. We are importing the OS module. Next, we are setting the path file.txt, which we have just used in the last slide. Next, we will get the size of the file or the directory. So we don't know whether this is a file or directory when actually we are doing some automation. So here we know explicitly this is a file. Otherwise, it could be a file or directory. In Linux, file and directory have the same meaning. This is strange, but I have discussed this already in the Linux series. So go ahead and watch it. Now, we will use another variable to store the response of the method, that is the os.path.getSize and then the path. And then check if the path is a file. Okay, so is file, os.path, then is file. So first one, we check the size and then whether it is file or not. So we are using another method here, is file, from the os module, os.path.isFile. Next, check if the path is a directory. Is directory is a variable, and in that we are storing the result of the method from the os module, that is os.path.isdir, and we are giving the path. So this path goes here, this path goes here, and this path goes here. We are using the same path everywhere, and we are doing different kind of checking on the same path. Now this path could be a file, it could be a directory, what it is size, and all that, provided we are assuming that whatever we are getting as a IDE automation is unknown to us. Next, check the path is a symbolic link. So we said here the symbolic link. Now we are going through the code. Here is link. Then we are using the method os.path.isLink, and then again we are giving the path. So this will check whether it is a symbolic link or not. Next, print the results. We will print all these four. So 1, 2, 3, 4. All these four variables we will print here. First print command, second print command, third one, fourth one, and the fifth one. So what we are getting as a print: path, size, file, directory, and symbolic link. Okay. Once we execute this code, we get this output. The path is file.txt, that is /file.txt. Size is 0 byte. It is file. Yes, it is true. It is directory. It is false. And is it a symbolic link? False. So we have checked all these things here using this method. Now you can add some if-else loop in your Python coding to take the further decision. That means if it is a directory, do this, else do that. If it is a symbolic link, do this, else do that. So you can do this conditional things further add on. So you can download this entire code from the GitHub link provided in the description, and from there you can enhance this code with couple of further if-else. So in those if-else, you can just give a print command. Nothing more you have to do. But in actual practice, when you are doing an automation, there you can use this for your purpose. The if-else constructs, you can use it for proper purpose for the IDE automation and the next step of the automation. Okay, so here done. Let's move on to the next slide. Here we will talk about the Unix or Linux directory listing. That means we have a path and we want to list all the files and directories there. So let's see how we can do that. First line goes our interpreter. Next we have the comment importing the operating system module, that is import OS. Okay. Next we have the file names, and this will be a list, remember. So here we are using the OS, then list dir method, and in the argument we are providing dot. Dot means the present directory. I have talked about this dot or dot, maybe dot slash, all these things in the Linux tutorial. The link is provided in the description. Go ahead and watch the Linux series in case you are not very much familiar with the Linux commands. Next, we have the print, then file names. So here we will print out this list. So let us see if you do this. And remember, it's not only dot. You can have maybe using this path. So this path you can give user, then bin, and then you can do the listing of whatever binaries are inside this. You can do that. Go ahead, download the code from GitHub link provided in the description. Do all the trials that you want. Next, here once we do the listing, here you can see only Python files, because inside this particular folder I was creating the Python files for this tutorial and running them. So there will be only the Python files, no other files. Okay, download this particular code from the GitHub link and try it at your end. We are done here. Let's move on to the next slide. Uname and directory operation. I have talked about these uname method or maybe binary in the Linux series. Again, I am emphasizing, and all the directory operations there by hand in the terminal. Please go ahead and watch the episodes in case you are totally unaware about these things, and then you can come back to here. Here goes our code. The first line is or interpreter. Next we have the import OS command, the most important thing you should mention. And next we have the variable called uname, and we are using the os.uname method. And then we are doing the print command to print this particular uname. Next we have the current dir, and we have the method os.getCWD. In Linux we have a command pwd to do this. So we are getting the pwd function here using the getCWD function or method. So next we do the printing of this particular variable, that is the current dir. Okay, here it is. Next we have another variable where we are listing the files, os.listdir, and then we are listing the files here. Next we are having the new directory, that is a new dot directory. We are creating this variable because we will create this directory. Next we are using the os.mkdir. So this is very similar because mkdir is a Linux command which is used to create directories, and we are using the os.mkdir, and then we are giving this variable here. That means this directory will be created. Next we print out the name of this new directory, and then we do the change directory. This is just a simple cd command, change directory, that is cd command in Linux, and that we are replicating here with the chdir. As we write os.chdir, that means whatever directory we are currently working in during this Python code, running of the Python code, we are entering to the newly created directory. And then we are coming again back one level up, os.chdir ... That means we are coming back again to the directory which we are initially in. Next we are doing the remove directory, that is rmdir. Then the variable we give, that means this directory will be removed by the rmdir command. Next, so all these are very easy. Download the code and you can add sufficient number of print command in between these steps. Okay, so whatever step we are doing, and run the code. So once we run this particular code in our system, we get this thing. So first uname, when we printed uname, we get the system information like this. Now we write current directory, we get current directory here, and then we have files in the current directory. Files in the current directory are all these Python files because I was preparing all of the Python codes for this tutorial here. Next we have the new directory created. Okay, and here it is new directory created, and directory remove. Okay, directory remove is this one. So you can check all these things at your end. You don't have to just see this tutorial and believe everything is working. Okay, you can download the code from the GitHub link provided in the description, and you can do your own trials with this particular code. So we are done here. Let's move on to the next slide. Dealing with the environment variable. Now this is a very important slide. In VLSI, when we are working, generally there will be a lot of prefixed environment variables. Maybe when you are running the front-end verification, right? There will be a tool from which path it is getting called. There will be some files that you need as input, they will be called from here. So all these are stored in the environment variables. And say you are running the synthesis operation in front end, there you will need the path of the PDK or the DK where the standard cells are kept, which you need to call. So those are again set as environment variables, and that you will call in the synthesis tool. So in case you are running the synthesis tool using the Python, so that time you have to access this particular variable to check whether it is pointing to the right one. Here the PDK or DK path, that you have to verify before you can pass it on to the synthesis tool. So this kind of automation needs the real-time access to the Linux environment variables or the Unix environment variables, and in case you want to change or replace them, that is also possible. So this is very important episode. Watch it carefully, and don't worry, the codes are provided directly on the GitHub. You can access this particular code which we are going to talk from the GitHub, download it and in your home PC, try it out with changes whatever you want. First line goes here as the Python interpreter. Next we have the import OS, which is the most important thing. Next we are having a comment accessing a specific environment variable using the os.getEnv. So getEnv means we are fetching the environment variables. So here we have a variable home, and then we are writing os.getEnv home. So this is an environment variable home. So we are getting the value of it to the method, that is the getEnv from the OS module. So here let's print it. Here we print our variable. Next we have accessing a non-existence environment variable using the os.getEnv. So non-existence is our variable and we are using the get os.getEnv. So here we give a variable value, non-existence variable. It's a dummy one and we give a default name. Okay. And next we have the print command here and we pass on this variable. Modifying an environment variable using the os.environ. So there is another method os.environ. Then we give the environment variable name here and then we set the value. This way we can change the environment variable value from within our Python code. We don't have to manually go to the Linux terminal and change it. Okay, we can right away change it from the Python code. Next we have the custom variable, then os, then getEnv, then custom variable. We are accessing it. Then we are printing this, the custom variable. That means first we do the change here, then we access it and then we print it. That means this custom variable we are printing here. Next, unsetting an environment variable using .environ. That means we want to remove an environment variable. Here, first we do a check whether this is there. If the custom variable is in os.environment. So os.environment, if it contains, that means we are doing checking whether this particular environment variable exists. Then only we do the operation. Del command we are using and then we write os.environment method and then we give the value. That means we are deleting this particular environment variable through Python code. And next we have custom variable after unset. So we write here, we had a custom variable, right, which was storing the value and then we write os.getEnv custom variable. Here we print it. So custom variable is this one, right? This one is accessing here. So this is an environment variable, right? Custom variable. So after we do the delete operation, that means we have emptied the custom variable, environment variable, then we access it and print it. And here we do the printing, right? Printing whether it is existing or after the delete operation. And this is our output. So first we have the home. You can see we can get the access. So this is simple. We are accessing the home and then non-existent variable. Here we are getting it. Okay. And we said, right, the default new was the value. So this one is the variable name and this is value and this is coming here. And the custom variable which we have set, that is a custom environment variable to the os getEnv, right? And the value was custom val is coming here. And we do the del operation here. That is the unsetting del operation here, and after that we are again accessing the custom variable and it contains none. That means it has been emptied. So this is a very tried and tested code. Download it at your end from the GitHub link provided in the description. Try it out with multiple variables so that you can learn to control the environment variables using the Python code. We're done here. Let's move on to the next slide. Quick file operation. So here we will do some file read-write operation, but these are very quick things, not in a detailed manner. We will have separate episodes on file IO where we will do the detailed operation, but here we will do it using the OS module. And this you may need during the automation, quick things that you need inside the automation. First, we have our Python interpreter. We import our module, import OS. Next, files to remove. We have a file name, file to remove.txt. This file already existing in our disk. And then we use the open command, file to remove w, then close, create a file for demonstration. So we are just creating it using the file open command and then we are closing it. Next, we write os.remove, then file to remove. That means whatever file name was here is passed on to this here as an argument and this os.remove will remove it. Next, print file removed and then we give the name here. Okay. Next, we have our old name here and there is a new name. These are two different variables. Now, what we will do? We will open a file with the name, old name, and we will rename the file. So, we rename it using the os.rename method, and first argument we give the old name and the new name as the next argument. That means whatever name we have to change it, we give it later, and this way the old name, this means this will be get replaced with this one. And let's print both of them. Okay. And once we execute this code, files removed is files.remove.txt and file renamed from old file name.txt to new file name.txt. So you can see this is a very simple command, simple file operation. Okay. Where you are using the file operations of the OS module to manipulate them. So that means either you are removing or renaming. Okay. So all these things you are doing using the quick file operation. This code is available for download from the GitHub link provided in the description. Go ahead, download it, do some changes as you want. You want to play with the code, and then you run the code. Okay, until or unless you are playing with the code, you will not able to learn the Python code or the coding style. You do some custom modification, take the challenge, and you set your challenge by yourself and you solve them by yourself. This way you will learn the code. We are done here. Let's move on to the next slide. File manipulation, open in read-write mode. First goes our interpreter. Next, we import our OS module. Next, we open a file in read-write mode. Again, I am saying this is not a complete file operation. This is a very quick operation through the OS module for the purpose of the automation. So learn it in that fashion. The basic of open operation, close operation, read-write operation, all those will be discussed later on. These are not like this. So this is for your automation purpose using the OS module. Even in Linux, we have a command called touch. With that, you can create a file of 0 bytes, right? So those kind of operations that you are doing through the OS module. So let's open a file in a read-write mode. We have the file path, is the file name. So here we have the file descriptor, and then we using the os.open method, and then we are giving this file path, that means the file name, and we are using the os.open and read-write mode. RD is read, WR is write. So this way we are using it. Next, read the content of the file. So read it. Let's be the buffer size 1024 and content. Then we are using the os.read mode, and then we are writing the file descriptor. So file descriptor is basically the file handle here, and we give the buffer. So this much buffer will be given for reading. So you can either increase it in the multiples of 1024 bytes. You can use it. So we are using this particular method os.read. First we give the file handle and we give the buffer size to read the content inside the variable content. Okay. And then modify the content. We write the modified content, and then we write content.upper. That means whatever was in lowercase written in this file, assuming this is a text file, we convert it into uppercase. And this was our modification. Okay. So we write the content and then .upper. We are using the upper method to convert it into the uppercase. Move the file pointer to the beginning of the file. Now we have read the file, so file pointer has reached. So this is a file. When you start reading, our file pointer at the beginning and at the end of the reading, it stays here. So we have to move it back to this particular initial point to write the file. That is, we are using here os.elseek, then file descriptor. File descriptor means this file handle. 0 is the 0th line, and os6 set. So we are using this method os6 set to take the control back to the initial line of the file, because here we have done the reading operation. So the file reading head, the read head has been reached here. We are resetting it to the initial point using this particular command. Next, write the modified content back to the file. Now we will do the write operation. We have reached to the initial point of the file for writing, and we are writing the modified content, that means this one. Then bytes written is os.write, then file descriptor, nothing but the file handle, and the modified content is nothing but this one which we are writing. So this will be, the modified content will be transferred here. So we have done the change case here, and rest of the bytes and length of the file is unchanged. We have done the change case, and that is getting written. So here we close the file, os.close file, and here is the file descriptor, that means the file handle. So this way you can do some quick modification of the file related things using the OS module. Later on we will have the file IO in separate episode, not in this episode. Need of the hour, you can use these methods inside your automation. And one thing, once we executed this code, we did not had any error or something, and output has to be checked manually, because here we cannot check the output to the screen because we have to open the file and read it by our human eyes. So you can download this code from the GitHub link provided in the description. You can write some text here in small caps in this file, create this file first and save it in the disk, and write something in the small caps, and then run this code, and then you check the manually whether this file has been modified or not. This has been checked when I was preparing this code, and that has been well ran and there was no error. We're done here. Let's move on to the next slide. File manipulation, open in create mode. So you can see we will create a file here. So first here, before beginning, I would like to say one thing. In last slide, we opened the existing file and we have done modification on it. Now what we will do, open a file in a create mode using the OS module. Now first goes our interpreter, next our OS module, next we create a new file. We have a file path, my new file.txt, we give the name, and then we have our file handle, that is the file descriptor, and then open method, os.open. Remember earlier we used the last slide, we have used the open, that is the basic file operations of those things. Now we are using the os.open, that is the open method inside os. Then we give the file path here, and the flag is os.create or os.rdwr, that means either of them, that means create o.create or o.rwr. So these flags we provide so that we open a file for writing, or in case the file is already existing, it will open it in the append mode. Write the content to the file. Content is the hello world. Here we have a variable here and it contains hello world. Now we write the bytes written, that is os.write. Then we have the file descriptor, that is the file handle, and we write the content.encode. So we are doing an encode operation on the content and we are writing it. Move the file pointer to the beginning of the file. Now again we are doing the lseek operation that we have done in the last slide. We give the file descriptor, that is file handle here. We give the line number 0 here, and then we seek set. So that means this is our file, and we ensuring our file read head or the file play head, you can say, that is here at the line 0. Okay. Read the content from the file. How we will read it? We set a buffer size, and then we write read content os.read, and then we give the file handle here and we give the buffer size. So increase, in case you want to increase this, do the multiple with integer and put that value, maybe 1024 into 2 into 3 into 4, like that. Next we write the print read content. Then we use the print command, read content.decode. Okay, this is one, the read content is this one, and we use the decode. So for writing we are using the encode, and for reading we are using the decode. So this you can correlate this one and this one, and then we have to close the file. So we have done printing of the file and then we close the file, and here we are writing the os.close method, not the close method but the os.close method, and we give the file handle here. Okay, once we run this code, the content was hello world. Okay, so this is the hello world which has been written into the file. Which file? This particular file. So I tell you to download this code from GitHub link. Try out at your end. You do change whatever you want. You want to write a multiple lines here, you can do that. Okay, and then you run and check the code, what is happening here. Okay, we're done here. Let's move on to the next slide. Capturing system error. So this is very, very important in VLSI. When we are doing the IDE automation, right, we at step 1 we run tool 1 and we take its output into some variable and we pass it on to the tool 2. This could be anywhere. Okay, now if you are doing this using the Python, at first you need to check whether the first tool has given error or not. How you will get that? In this code I'll show you the method to get the system error using the OS module. First line of the code is the interpreter. Next goes our import OS. Third, we write try, that means attempt to raise an error. You remember this thing. This is not very simple thing. It's a very tricky one to capture an error. That's why we are using the try. And then we write the command that we want to check, os.mkdir. So we want to check this one. We want to check whether home, then username, then documents. We want to create it. We know that it exists there and it should give an error. So that's why we have given intentionally this particular path. Now accept os.error as E. What we'll do, we print that an OS error occurred this. We know that this will happen. First, we try out a command, okay, and then we use accept os.error as E, and here we store our error message, and here we print it. So here you can see the error is coming as os.error occurred, error number 17. Okay, it's some number that is automatically Python is giving, and in case you are able to put a log file, this will go into the log file as error number, and file exists. That means here the directory already exists. Now I said earlier that in Linux file and directory have the same meaning, right? So it says the file exists, this particular thing. So we cannot overwrite it. It already, the directory is there. We cannot do the mkdir on the existing one. So that's why I have intentionally put an error, and this way you can capture an error during a Python automation. This particular slide is the most advanced one that I have shared with you in the OS module. Practice it carefully, and this code is available for download from the GitHub link. From there, you download the code, do the trials at your end, and get the expertise by yourself. We're done here. Let's move on to the next slide. System module. So we have another module called system module. So let's exemplify it to you with a short and sweet example. First line is our Python interpreter. Next, we have imported the sys. It is not OS module, it is sys module, that is the system module. So here we have the system.argv. You know that when we run a EDA tool, we give so many arguments to it. So argument values are fetched by this one, this, then argv. So you can print all those things. Okay. In case you want to store it in a variable, you can store it using this method. Next, from sys import argv. Okay, from this we are importing the argv. First we done the printing, next we are importing it. Then script, then first, then second, then third, then argv. Next we print the name of the script is script. First argument, second argument, third one, fourth one. Okay, so the fourth one here we are printing system std error dot write error. This is an error. Okay, so this is just to make your Python automation smooth. So these are tools that I am providing this episode and the last episode, which you can use as different tools for Python automation. So here let us run the code. What will be the output? Name of the script is operation this one .py, and I have given 1, 2, 3 as the argument. Okay. Well, I was executing, I was given 1, I have given 1, 2 and 3, all these things as an argument. So it has printed the arguments. So you can check while you are running the particular code, right? That time whatever arguments are coming to you, you can check the arguments by using this one. Okay, so in C language there is a argc, argv, all those things are there. Here do the same thing, you can use this one. And write an error, you want to explicitly write an error, right? Here you have a condition that you are checking whether your one of the argument should be maybe integer, it is coming as a string. So in that case you want to give a explicit error, you can use the system.std error dot write then error. This is an error. So here you are issuing an error. Earlier slide we have talked about how to capture an error, that means error thrown out by a tool. Now here your program will throw out an error. So there is some error, it will alert the user. Okay, so this is the method of showing the error and checking the argument values and etc. We're done here. Hey guys, welcome back. In today's episode we are going to discuss the below points. First, we will explore the different data structure available in Python. Next, we will start with the first data structure, that is list. Go to its basics like appending, slicing, and making a list void. Next, we will continue the basics with element count, reversing, sorting, and pop operation. Next, we still continue with the basics with the removal of an element, pop of an element, insertion. Next, we will further go deeper in the basics and use list as a stack. Next, we will go further deeper in the basics and use the list as a queue. Next, we will create the list using the loops. That is, we will do the generation of the loops. That is, we will do the generation of the list using the loops. Next, we will explore the delete, that is the del, and the length, that is len command, which can be used for a list to delete elements and finding out the length of a list. So that's the menu for today. Without any further delay, let's begin. Data structure in Python. We all know about the data structure. In case you have learned C or you have learned Perl, you might have came across different type of data structures in them. Also, we have a series integral. There also we have a data structure. So for each and every programming language, which are very advanced nowadays, like Python, Tcl, Perl, etc., we have inbuilt data structures. That means we do not have to create it. That means we do not have to create the basic structure of a data structure, but we can use the data structure which are predefined in the programming language. So in Python, we have our data structure divided into 4 different sections. First one is list, second one is tuple, third one is set, and the fourth one is dictionary. So in today's episode, we will talk about the list, and in the upcoming episodes, one by one, we will cover the rest. So today we will focus on the list. We are done here with the slide. Let's move on to the next slide. List basics, that is appending, slicing, and voiding a list. So here goes our Python code. Since in this series we are explaining or learning things through explicit examples. So here goes our first example. The first line is hashbang user bin python 3. It's the interpreter. Next, we have numbers, and here we have a list. So list you can see is denoted by the third bracket starting and ending, and in between we have comma separated values. So this will make a list. Next, we can print the numbers, and here we are putting the 0th index. That means 0th index element is 1. So this will print the 1. Next, we will print the numbers with the negative index, that is -1. So from the right side this will count, and -1 should print 9. Next, we have the print, then numbers, then -3. So from right hand side we will have -3, and then we have a colon. So this is called slicing method. We will explain it later. We can add elements to our existing list like this. So we have numbers, they is equal to numbers, plus we have a unnamed list, that is this one. So up to this we had element 1 to 9, and then we have elements 10 to 15. So these all are getting appended here in the list. So this list will become bigger here. Next, we print the numbers again to get the outputs. Don't worry, we will show the output very shortly as soon as we finish the code here. Next, we have the length calculation, that is the ln and then numbers. So this will determine the how many members are there inside a list, or how many elements are there inside the list. So len operator will do that. So numbers.append. So since this is the object-oriented language, we are using append method to append 16. That means here we have up to 15, and then we add this 16 at the last of this particular list. So you can see appending is done. Then we again print the entire list. Now we are slicing the list. One thing you have to remember, that the slicing here is a non-destructive slicing. That means when we slice something, it doesn't actually cut out, but it gives a segment of the entire list. So here we start with the second index, and the slicing will end at 5, fifth, right? So 0, 1, 2. So it will start here, and 3, 4, 5. So it will end here. So the slice will contain these numbers. So this is called slice. Okay, so and in the same command we are printing it, so we will get the slice. We can do the destructive slicing by deleting the slice. So we can do what? We have the numbers 2 to 5, and we give an empty list here. This will delete the slice. That means this slice will be deleted. So this is destructive slicing. Former one, this one was non-destructive slicing. This one is a destructive slicing. That means it will destroy the elements from 2 to 5 of index. Next, we print the numbers. Further, we have our slice, so making the entire list void. From beginning to end we are making this, so this will create a void. So you can see we are here voiding. So we had slicing, we had appending, and we had void here. Next, we print numbers, and finally what do? We get the output once we run this particular code. So you can see the first print is the 0th element. It gives 1, which is here. Then we print number 1. As I said, from right hand side we will go backwards. So here we have -3, right? So from right hand side we will have 3 elements, that is 7, 8, 9. So you can see 7, 8, 9 is here, and as we add these the list become bigger. Okay, the next we have the length of the numbers, that is 15 is the len operator gives this. We have append, right? So append add 16 here. You can see 16 is getting added here. So this is the output from our terminal where we have executed this code. So here the slicing 2 to 5 non-destructive size slicing is 3, 4, 5. That means 2, 3, 4. So this one 3, 4, 5. So 3, 4, 5 gives this one, and as we delete this slice, that means we will delete these numbers. That means 3, 4, 5. If we delete it, what it becomes? It shrinks, and you can see this is the destructive slicing. So destructive slicing actually deletes the element and shortens the list. So here we have done the voiding here, right? And hence once we print it, it is coming as a void list. That means all of these numbers have vanished because of this void operation. So these are few basic list operation that you can do with the list, and you know the syntax of the list is how it looks as we have explicitly exemplified here. So we are done here. Let's move on to the next slide. Now we will further discuss more basic things like element count, reversing, sorting, popping. So here goes our code. The first line, as usual, the Python interpreter, that is Python 3 interpreter. Next we have the list with orange, apple, all these fruits are there. Next, so here we are writing apple count, that fruits dot count then apple, so number of entries here. Okay, how many apples are there? So you can see apple is here and apple is here, so it will be 2. Grape count is fruit dot count then grape, so number of entries. How many grapes are there? There is no grape here. Okay, so it should be 0. Next we have pear index, and here we are using fruit dot index and then pear. Okay, so pear, how many pear are there? 1 pear is there, so it will be 1. Next, banana index after 4. So after pressing 4 elements from the beginning, how many entries of banana are there? Okay, so here we write banana then comma 4. So that means after 4 elements are crossed, how many bananas are there? Next, we have the reversing operation. So here the reversing operation, how it is done? So we have the list, simply add the reverse method here. So we write fruit dot reverse and it will reverse the entire list here. So this list will be reversed. So banana will come first and orange will go at the end, and similarly this will come at the second, this will go here, like that. Reversing will happen. Next we have the print fruits. We print this thing. Next we have the append operation and we add grape. So grape, you can see it was not here, so we added grape, added and last element, use the append method here to add it at the last. Next we print the fruits, okay, and then we write the fruits dot sort. So it will do the sorting, that means it will sort among all the names. Then we write the sorted list and then we give the fruits, and then we have print popped element, then fruit dot pop. If we do a pop operation on the list, okay, using the pop method, what element comes out? As we run the code, it comes like that. So you can see at the last we had added the pear, right? So let us go one by one from the beginning. So here you can see apple count, here it is 2 because there are 2 apple, right? Grape count is 0 as there was no grape. Pear index, so it is not count, it's an index, that means the position is 2, so it gives the index. Banana after index, that is the position here, it's index, and here we have 6. So this is not giving how many bananas, rather than it is giving the index. So this is the index and this is the count, so that is the difference, right? So earlier I have just misread it, and so misinterpretation was there, sorry for that. And here you can see the index, right? Index means what is the index of it. And here we can append grape. So as we append grape, the grape comes here, okay, and you can see here the reverse is there. So what happens, the entire this list is reversed here. So banana goes at first, then apple goes here, then kiwi goes here, then banana goes here, and then pear goes here, and apple goes here, and orange goes here. So this is how the reversing is done. Reversed is done, then we have the sort operation, and then we have printed. So sorted is this one. You can see there is a basic difference between this and this. This is how the things are sorted. So you can see A, B, B, G, K, O, P. So it's in alphabetical order. So they are sorted in the alphabetical order. And then popped element, whatever we pop, what comes here? At last there was pear, right? So the last one is popped out. So popping means we opposite to the appending. So here we have append, right? Append operation, the exact opposite of the append operation is pop. So these are two mutually opposite operations. So whatever you do as append, if you pop it, it will come out. So here we are done with the code example and its output and the explanation and the mapping. Let's move on to the next slide. List basics, removal, pop, insertion. So let us start our code to get the taste of removal, pop and insertion. Now here starts our code. First line is hashbang user being Python 3, that is the Python interpreter. Next we have our list where all fruits are there and totally removed by name. So first let the removal operation begin. Okay, fruits, then remove, then pear. So we can remove pear from here. Pear is here, so this will be removed. Next, we print the fruits. As soon as we run the code, we'll have an output and we'll compare. Wait for that. Let us finish the code. Pop out by index. The fruits pop, then we give the index 3. So that means the third index 0, 1, 2, 3. So this means this one will be popped out. Next, we print it and then insert again and in the desired position. Okay, so fruits dot insert at the third position is watermelon. Third watermelon was not there, so at the third position we entered watermelon. We print the fruit. So now once we run the code, this is the output. You can see once we remove the pear goes out. Pear is not here. Pear earlier was after the apple and before the banana, so it is vanished. Next one is the pop 3 operation. That means pop of the third one. So pop of the third one means 0, 1, 2, 3. So kiwi vanishes. So you can see the kiwi has vanished here. And here you can see the insert at the third position is watermelon. So 0, 1, 2, 3. So at the third position watermelon comes again at the place of the kiwi. Earlier kiwi was here and now it is replaced by watermelon. But what we have done, first we have popped out, then we have inserted. Okay. So this way we have done the operations. So done here with the examples and its explanations and the code execution. Now let us move on to the next slide. List basics, use it as a stack. So in this example, we will use the list as stack, and let us begin here. The first line of the code is the Python interpreter. Next, we have defined how the stack is working. So using the list as a stack, and we use the method last in first out, that is LIFO, L-I-F-O. LIFO is the method of the stack. Stack you might have read in case you have microprocessor in your syllabus. So there the stack is there. In case you have not, you will use this example to learn how a stacking operation done in the programming or in the data structure rather than inside the data structure through the programming. First, we have stack defined as a list, and here it is 3, 4, 5. So we will operate it as a stack, not as a list. So what we'll do? First, we append 6. That means 6 will get added here. Okay. And then we append 7. So again 7 will get appended at here. Then we print the stack. Next, we write stack.pop. That means 7 will be popped out, and then again we write print the stack, and then we write again stack pop. So that means in this pop operation 6 will be out, and again we print the stack. Once we run this code, here we have done the 2 appending here, right? 6 and 7, 6 and 7. The next, once we pop out, right, the 7 is gone. 7 you can see is gone here. And the next operation you can see the 6 is gone here. So again it comes back to the original state. So this way we can use the list as a stack. So this can be a good interview question. You might have to memorize this example, okay, a code example for your interview. And from here you can answer the questions. Here we are done with this code example and its output and the explanation. So let's move on to the next slide. List basics, use it as a queue. First line of the code is nothing but the Python interpreter. Let us see how Python list can be used as a queue. So using list as a queue means first in first out, that is FIFO. FIFO, first in first out. Stack was LIFO, that is last in first out, and queue is first in first out. So here goes our first line of code, that is from collections import dq. We have a module called collection. Inside that we have a method called dq. So we are importing dq from the collections library. Next, we have q is equal to dq Eric, John, Michael. So it is a list and we are using the dq operation on it. Next, we print the q. So this has made a q, right? The q operation, q is there, which is a first in first out operation. We have converted this list with this command into a queue. Okay. Next, we will use the queue means q dot append. So we will have used the append method. Then we write Terry. So Terry arrives. Okay. Next, we print the queue. Next, q dot append, then Graham arrives. Next, we print the queue. Then q, then pop left, Eric lives. So here we have done the appending, that is in, that is the first in, right? And then pop left. So from left side it will pop. So the first one, Eric, is removed by this one. Next, we print the queue. And next, again we do the q dot pop left. That means after this, John will go out. So John leaves it from this queue. And we print the queue. So let us run the code, and once we run the code we get this output. So this is dq is a queue, right? So here it is printed as is. Now as we append Terry, Terry comes after this Michael, right? And Graham is this. Now this was the first one entered, so this has to go first, right? Eric. So as we do the pop left operation, the Eric vanishes here, and next we will do the q, the John vanishes here. So John was here present and he removes, and he leaves, or the element is getting removed. This way, the list in Python can be used as a queue. And one thing remember, we have to use this particular thing. That means we have to use the dqueue method from collections. Here we are done with the code and the example and its explanation. Let's move on to the next slide. List generation or list creation using loops. Loops we know that is the for loop, while loop, all these are loops. So using the loops, how we can create a list. First goes our first line of code, that is Python 3, and then we have the squares. This is nothing but a list, but it is empty, you can see. Then we have a for loop with the range operator for x in range 10. So that means it will start from 1 and it will go up to 10 as an integer with the increment, and the for loop will rotate for this. What we do? We write squares dot append then x to the power 2. Okay, so we are using the power operator using double star. Next, we write the print then square. So here, as we come out of the for loop, we write it square. How we are coming up the for loop? Because you can see the indentation. Whatever inside this indentation will be in the for loop. And as we come back to this original indentation, that means we are out of the for loop. So this is the convention in Python, which is very, very different from any other language. Next, we have another list, that is const, that is also empty. We write for x in 1, 2, 3. So it is a complete list and on which we will operate x, and that means x will be first 1, then 2, then 3. Using that, and here we write for y in 3, 1, 4. So there is another list. Y will operate like that. We write if x not equal to y, then const.append then x comma y. This is a kind of coordinate like structure, that is x comma y. And then we print the const. So let us run the code and see the output. What happens? The first one is x, that is range 10, that is it will start from 0, and here it is with 81 because it is doing the squares, right? So 0 to the power 2 is 0, then 1, then 4, then 9, then 16, and this way it goes up to 9, which is the 9 square is 81. And here you can see that we have done the const, that is the combinations, right, for x and y combinations, and where x is not equal to y, that means this 1 and this 1 will not work, and this 3 and this 3 will not work. So apart from this, all other xy combinations, that is the coordinates like that structure, are kept here. So this is the first element, which is again combination of 1 and 3. This is the second, this is the third, this is the fourth, fifth, sixth, and seventh. This way the lists can be created using the loops. So we are done here with the code example, its explanation and the output. So let's move on to the next slide. The del and len command. The del means the deletion command, that is the delete command, and the len means the length command. So we have seen this, but we will explicitly cover examples here about these two. The first one, as usual, is the Python interpreter. Next, we have the list of fruits. So there are several fruits here, and we write del, then we write a slice, that is 2 to 3, that means 0, 1, 2. That means 2 to 3 will go for deletion. So we'll del this particular slice. So this is a destructive slicing. Next we have fruits, print then fruits, then length of the fruits. That means length of the remaining elements after the deletion will be printed here. Then we write del fruit 0, the 0th index is deleted. So del can be used to delete a slice, or del can be used to delete one particular element. Then again we write fruit, then len, then fruit. So we will print the fruit as well as its length. So you will see both the things coming out as an output. Once we run the code, we have this output. So you can see after we deleted 2 to 3, what happens, that orange is appeared there, and then from pair, that means the 2th element, up to it, this only is vanished because there is no more, because banana is here, right? So banana is here, kiwi is here, apple is here, banana is here, again apple is here, and orange is here. So by this deletion, right, pair goes out of it. That means the pair is deleted from the list. And next, as we have deleted the 0, that means the orange is deleted and the apple shifts this side and comes here. So you can see orange is deleted by the del command. Okay, this is the simple use of the del and the len command. And length, you can see here, the length output is 6 here because there are 6 elements, and here it is the 5 because here the len at the last. So first is fruits. Fruits is covering this area. Okay, the list. Len is getting printed here. Similarly, the fruits is here up to this, and the length is 5. Length is 5 here, you can see. So this way the del and len command can be used along with the list. We're done here. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will briefly cover all the data structure that are available in Python. These are already available. You don't have to construct them. You can use it readily once you know their usage. In today's episode, we will talk about tuples. These tuples are heterogeneous in nature, unlike the list, which is a homogeneous in nature. Next, we will talk about the accessing and concatenation operation on tuples. So these are basically lists with special ability and restriction also. Next, we will talk about the unpacking method and iterating method on tuples. Next, for the unpacking, we will talk about how to unpack any unknown number of elements in a tuple. So this is for known and this is for unknown. We will show you two methods of unpacking. Finally, we will demonstrate the slicing method on tuples, which you have already seen in case of list, and you know how the slicing works, and the same thing and some additional features will be disclosed in the last slide. So that's the menu for today. Without any further delay, let's begin. Data structure in Python. So here briefly we give you a table. The table starts here, the data structure. First element list, which we have discussed in last episode. Next one is the tuple, which we are going to discuss today. And there are two rest of the things that we are going to discuss in upcoming episode, that is set and dictionary. So today we will focus on tuple. We are done here. Let's move on to the next slide. Tuples heterogeneous nature. As we do, we are going through examples here. The first example here of the tuple. Through this example, you will understand that tuples are basically a special type of list with some restriction and features. The first line here is hashbang user bin Python 3. This is nothing but our Python interpreter, and obviously this code is portable, so you can use this port in Windows. If you remove this is needed for the Linux. Next, we have the tuple t, and here how it is written. You can see 1, 2, 3, 4, 5 is the first element, next element is this, and the third element is this. So you can see this is number and this is some string. So the elements of the tuple are heterogeneous, which we have just mentioned here. Next, we print the length of the tuple t here. So this print command. Len we have discussed in last episode, which you can use over the list, and now you can see you can use it over the tuples too. Next, the tuples may be nested and can contain list. Since this is heterogeneous in nature, it can contain a list too. So you can see tuple is not a list, it's a specially featured data structure which looks like a list, but it has some more features and some restrictions. Next, here you can see this is our tuple, the next tuple, where the first element is a tuple itself, t, which we have defined earlier. The next element here is again a list of numbers, that is 1, 2, 3, 4, 5. Another list is there of orange, apple, lychee, pear. So these are the fruits and we have them inside the tuple. So you can see that how the heterogeneous nature can be in various forms in this example. Next, we use the print command to print the tuple and length of the tuple. Since this has to be expanded into this, we use here u to print the entire thing. Otherwise, the thing is visible to us. But how this comes here while it is expanded, we will see. Now, this is our code, and another thing here I would like to mention is that tuples are immutable, so they cannot be interchanged. Okay, so modification directly is not possible. Unlike list, this is the special restriction in tuple, which I have talked a couple of times from the beginning. So you see the restriction here. Here, once we run the code, we get this output. So this is the first print command, which prints our initial tuple here, and you can see the len operator here keeps the number of elements, that is 3. Once the code goes further, this print command is executed and it prints u. Okay, so the first element here, you can see this is nothing but our first tuple, right? And the next element is a list, which is here. And the next element is another list, which is here. So you can see the heterogeneous nature of the tuple here. With the first one, you see explicit the single element, which is heterogeneous. This and these are two different types, that is number and string. And here you can see the nested elements are even further different type. So you can see the versatility of the heterogeneous nature here in this example. Here you can see the length calculated by this particular function len of this tuple. Since this is nested, this is element 1, element 2, and this is element 3. So there are 3 elements. So it is treating this, and this as a single element, and hence this is nesting. It is not counting 1, 2, 3, 4, 5, 6, and not like this. It is counting 1, 2, and 3. That is 3 elements. So here we are done talking about the basics of the tuples and its heterogeneous nature, which makes it very different from the list. So let us move on to the next slide. Accessing and concatenation of tuples. Here, let us demonstrate these methods through the example. Here goes the first line of our code, which is nothing but our interpreter. Next, we have the comment creating tuples. The first tuple 1 is 1, 2, 3. Next tuple is apple, banana, orange. And tuple 3, Mercury, Venus, Mars. So you can see these are 3 different kind of data. Although this is string as a type, but the nature of the string is different. Here it is fruits, here it is the planets. Next, accessing the tuple elements. Here we will access each individual tuple element like this. How to do that? This is very similar to the list. Right? First, we write the print command here. First, we print the element of tuple 1, the first element, and here it is tuple 1, then 0. As we put the index here, it gives the first element. Next, second element of tuple 2. So, tuple 2 is this. The second element tuple 2 is accessed by index 1. Next, we have the third element of tuple 3. That is, here is tuple 3 and we put index 2 and it accesses the third element of tuple 3. Now we talk about concatenation of tuples. So first accessing is done. Now let us focus on the concatenation. Tuple 4 is equal to tuple 1 plus tuple 2 plus tuple 3. So this will concatenate. That means this will make all these tuples pack together into another tuple, that is tuple 4. Here we print the concatenated tuple, that is tuple 4. Once we execute this code, we see the below output. So here you can see the first element of tuple 1, which is this one. Second element of tuple 2 is this, which is nothing but this one. And third element of tuple 3, which is nothing but this one. And the fourth one, the concatenated tuple, that is the addition of all these tuples 1, 2, and 3. So here 1, 2, and 3, apple, banana, orange, Mercury. So this code is available for download from the GitHub. Link is provided in the description. The earlier code is also available. You can download this code and try to print the len of this tuple 4. Okay. Add that line of the len from the previous code and print it. So we have done talking about the accessing and concatenation of tuple in this slide, and the code is downloadable so that you can use it, modify it, and do the trial and errors. We are done here. Let's move on to the next slide. Unpacking or iterating on tuples. Here goes our code. The first line of the code is nothing but the interpreter. The next we are talking about creating of tuples. First tuple 1, next tuple 2, third one is tuple 3. These are very same from the previous example, these 3 tuples. Now here we print the length of the tuple 3, that is len tuple 3. Now let us start the unpacking. We write A, B, C, and in the right hand side we write tuple 3. Now why we have print len here, you will understand, because it is 3 we know already, but in case it is unknown, you have to print the length first and then do the things. So the first variable A will contain this one, B will contain this one, and C will contain this one. So this is the method of unpacking. So here we print the unpacked values of tuple 1 are A, B, C. So now the tuple 3 is unpacked into these 3 variables and we are printing them. Iterating over a tuple. So talking about the unpacking is done. Now we move on to the next part, that is iterating on tuple. So here elements of tuple 2, we will iterate on this one. How to iterate? We write a for loop. The for item in tuple 2. In case you are unfamiliar with the for syntax, we have already one episode on the loops. Please go to the playlist and watch that particular episode. And we simply print the item that we get as we iterate, right? So this is the method of iterating over a tuple. That means we are accessing the elements one by one. Now once we execute this code, the output comes like this. So the first print command gives the length of the tuple, that is 3, and next we have the unpacked variables are Mercury goes to A, Venus goes to B, and Mars goes to C. So these are printed. Now elements of tuple 2. Now in the next part, in the iteration part, the elements of tuple 2 are apple, banana, and orange. So this way you can either unpack the tuples or you can iterate over the elements of a tuple. Here we have chosen the tuple with very small number of elements, but in real case this can go in a very huge number. That's why the data structures are very important. So we are done talking here. Let's move on to the next slide. Now, in last slide, we have talked about the unpacking method for known number of elements. In case the number is unknown, which is a very realistic case in case you are parsing some file and you have populated all the data in tuples, right? So, in that case, this unpacking method will be a very realistic one. So, here goes our code. The first line is nothing but our Python interpreter. Next, we have the tuple assignment. The numbers here, this is our tuple, and here we have 1 to 10, the integers starting from 1 ending at 10. Next, we have the method of unpacking using the wildcard. Let us see, we have the first, we have the second, and we have the remaining. And you can see the star is here, this is our wildcard. And on the right hand side, we have numbers. So you can relate with the previous example. First we'll fetch this, the second will fetch this, and the rest will be fetched into this one. So this will become a tuple and it will contain these elements. Displaying the unpacked values. We write print first, the first one which is unpacked. The first is the variable. Earlier we used single alphabet variable, but here we are using names, that is strings. Next we have unpacked 2. Next we have unpacked as a tuple. First, second, and remaining. Okay. So this is the unpacking method here we have discussed, and this is for unknown, and this is a very realistic case because on the fly when you are getting a tuple, you don't know how many elements are there, you can unpack in this way. And once we run this code, we get this output. You can see the first one belongs to 1, the first element, the second one belongs to the second element, and here you can see the remaining is nothing but the rest of the tuple, which is again picked up as a tuple. So this is the unpacking method that we have talked about in the previous slide, and this slide we have talked about the unpacking method, and we are done here. Let's move on to the next slide. Now in this slide, talk about the slicing method to get some new tuples from an existing tuple. And this is not unpacking, this is a slicing method which we already discussed in list, and we will see how that is done for the tuples. Here goes our code, and this is the first line of the code, which is nothing but our Python interpreter. Next we have the tuples starting here with numbers from 1 to 10 we have in this tuple. Next we are slicing the tuple. The first slice is numbers, then 2:5. That means we are starting from index 2 up to 4. This is exclusive. So this is the first tuple. The next tuple is tuple 2. That is numbers 4, then nothing. Right. This means we start from index 4 up to the end. Next, again we do the slicing here. Numbers. This is the :3. That means we start from the very beginning and we run up to index 2 exclusive. Next, our tuple 4 is numbers, then 1:9:2. Now, where does these 2 comes from? This is nothing but a step of 2, and it is starting from 1 index up to 8 and with a step of 2. Now here displaying the slice tuples, we write the first print command, second print command, third one, and the fourth one. For all these tuples, we print them separately, and once we execute this code, we get this. The first one is 2 to 5. That is, here you can see the 2 to 5 is this 3, 4, 5, which is here. The next one is from 4 up to this. So this is 4 and up to this. That means up to 10. So you can see this has come here. This is another slide. Another one here is :3. So it is starting from the beginning and it is stopping at here. So you can see this part is here. And the very interesting slicing is the fourth one, where we start from 1 and go up to 8, right? But with a step of 2. That means we are jumping 1 element. So here we are starting from here and jumping and going up to here, right? With a step of 2. So we have 2, then 4, then 6, then 8. to the even numbers, and we are stopping here at 8 as this is our stopping index, right? We are done with the slicing method of the tuples. This code and all the codes shown in this episode are available for download from the GitHub. Download links of the individual files are provided in the description. So here we have done talking. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about the set. Set means this is a set which you have learned in the mathematics, and we will have a data structure in Python that can satisfy the mathematical properties of set. And you know the set has a unique number of elements. Next, we will talk about adding, removing, updating a set. So that means any kind of manipulation inside a set we will cover next. Next, we will talk about iterating over and emptying a set. That means we traverse inside a set, and also how you can void a set. In the next point, we will talk about the mathematical operations that can be performed on set. However, we will be limited to the Python programming only. Next, we will move on to the special data structure in Python, which is called dictionary, similar to the hash, which is there in Perl, where we have a key value lookup, or you can say key value mapping. Next, we will do the adding, removing, and changing dictionary elements. That means the key value pair. So, in this section, we will talk about all about manipulating the data inside a dictionary data structure. In the next very point, we will do the existence checking, non-existence checking, and the length of any dictionary data structure. That means there is a key value pair in the dictionary, and we will check whether any element that we want to check whether it exists inside the data structure or not. So that is existence or non-existence. And length is how many pair of elements are. In the next very point, we will talk about iterating over keys and values. That means we will traverse inside the dictionary data structure. So this way, in today's episode, we will conclude all the data structures that are available in Python. Earlier, we have talked about the list and tuples, and in this episode, we will talk about set and dictionary. And hence, we will be covering all sort of data structures that are available in Python. We are done here. So without any further delay, let's move on to the next slide. Now in this introductory slide, we will talk about the divisions inside the Python data structure. The first one, list, which we have already covered. Second one is a tuple, which we also covered in last 2 episodes of Python. And in this episode, we will cover the set and the dictionary. So this way, we will cover in total 3 episodes all the data structures that are available in Python. So the picture or the bird's eye view is clear to you. Now let's move on to the next slide. Set, unique elements. So here we will start talking about the set data structure, which is very similar to the mathematical set operation. Here goes our code, and the first line is the hashbang user bin Python. In case you are in Windows, you will not need this line. Next one is our set. So you can see here is basket, this is the set, and in the right hand side we have the set elements, and you can see this is the curly bracket or the second bracket here, opening and closing, and inside that we have the comma separated values. So this way we write a set. Next, we have printed the set and its length is the length. So you can remember for list or tuples, we have used the len operator earlier. So the len operator can be used here also. This way we can check the length. That means how many elements are there in a set. Next, we start our code with the if condition. If orange is in basket, then print we have orange in basket. Else, right, we do not have orange in basket. So this is one way of checking about any element. So we can see orange is there. So in this case, ideally this will be printed. If watermelon is in basket, print we have watermelon in basket. Else, print we do not have watermelon in basket. You can see watermelon is not there. So the positive condition is satisfied here and the negative condition is satisfied here. So let's run our code and see the output. Once we run this code in our terminal, this output comes. So here you can see this particular set. You can see orange is repeated twice, and once the set is done, right, the orange has come into one element. So there is no two elements. You can see that these 4 elements are there, although here 1, 2, 3, 4, 5, 6. And you can see apple is written twice here. Clear and point out. So apple is written twice here and orange is written twice here. So I have done underline for apple and overline for orange. And you can see the repetition has been shrink into 1. So apple has a single entry and orange has a single entry. So this is the speciality of the set. That means the set will contain unique elements. That means it will not have repetitions. It do not accept repetitions. Rather, it will have a set of unique elements. And once we print the length, rather than printing 6, it prints 4. Now, we satisfied the positive condition here. That means we have orange. So we get this output here. We have orange in the basket, and here we test the negative condition. Here we reach to the else condition, and this is printed here. That means we do not have watermelon in the basket. This way we check the element whether it exists or not exists inside a set. So we are done here. Let's move on to the next slide. Now here we will talk about adding, removing, updating a set. That means all sort of manipulation inside the set data structure. Here goes our first line. This line is essential for the Linux programming. However, if you are using the Windows, you may not need this line. Next, we are creating a set. Here you can see we are using the same thing here. Almost same. You can see there is no repetition, but we have apple, banana, orange, grape and watermelon. So we have already unique elements. So this is a set. Unlike the previous one, we had repetitions and they shrink into 1. And here we do not have such cases. We have 1, 2, 3, 4, 5 unique elements in a set. So this is a fruits. Next, we do the printing of the fruits. That means we are printing it. Next, adding elements to the set. Let us see how we can add it. Next, we write fruits.add. So .add is a method. Since the Python is an object-oriented language, every kind of data structure has its inbuilt methods or functions. So here we are using the add function or add method to add a element. So kiwi. So kiwi is not present here. It added as a unique element. Next, fruits.update, then mango, pineapple. It will update 2 more things. So this is another. We will see as a print comes here how these are different. You will see. Next, again we print the fruits. So earlier we have print fruits here before any modification, and after modification we print it. Removing elements from the set. Now we have added here and here, right, using the 2 different functions or methods. Now we will do the removal of elements. So here we use another method or function, remove, to remove the banana. So you can see the initially the banana was here and we are removing it from the set. Again saying that the Python is an object-oriented language and any data structure or any module will have its inbuilt method or function. We are using those only, and this is the object-oriented way of using a particular method or a function. And this is very similar to any of the object-oriented language you can find. Next, we write the fruits.discard. It is another way of removal. That means we are discarding one value, that is watermelon, which was here already. In the next line, we print fruits. So we have 3 print statements, 1, 2, and 3. Now let us run the code. And this is the output. In the first, it is printed as is without any modification. Now here we added 3 elements, 1, 2, 3, using the 2 different methods. And we can see that here those are added. So kiwi is added here. Mango is added here and pineapple is added here. So this is the new set which we get from this particular print. Now we do the removal operation, and as a consequence of the removal, banana get vanished. So you can see banana which was here is no longer here, and again we are discarding watermelon. The watermelon which was here is again no longer here. So this way we can add elements or remove elements or delete elements from the set. So in this particular code you learned about the add and update to include single element or multiple element, and use remove.discard methods to throw away any of the element that exist inside a set. So we are done here with the code and its output. Let's move on to the next slide. Iterating over and emptying a set. So here we will learn about the iterating over all the elements and making a set void. So here start our code. Here is our first line, which you can ignore in case you are in Windows, but in Linux this is must. Next, we are having a comment creating a set, and we have again our fruits, so which has apple, banana, orange and grape. First, getting the length of the set. Here we print length of the set is len fruits. Len we have already used and again we are using it here. And iterating over the set. Print fruits. Here we have a fruits and then we have blank here. Here we print fruits and then we have a blank here. Now we use a for loop for fruit in fruits. So this is S and this is plural and this is a single element. We print fruit. This for loop will iterate over the entire set and it will print each and every element using this print command. Now emptying the set. That means we want to make a set void. To do that, we write fruits.clear and here no argument is there. This is an inbuilt method or inbuilt function. As you know, the Python is an object-oriented language and each and every module of it will have its inbuilt method or function to control or do the basic things. Next, we write the cleared set. So we have 1, 2, 3 and 4 print statement all together. Once we run this code, we get this output. Length of the set is 4. You can see len operator is giving the value. And then we come to this. Okay, here this print command is first executed and this is printed recursively. That means this print command is used recursively using the loop and all these values are printed one by one. That means we are iterating over the elements. Next, as we void the set using the clear command, the set is nothing but just a blank or void set. In this particular code and example and output, we learned about the iterating over and emptying a set. That means voiding a set. You can download this code and all the codes that are shown in this episode from the GitHub. All the links are provided already in the description. We are done here. Let's move on to the next slide. Mathematical operation on set. So here what we do the mathematics of set and let us start the code. Here goes the first block of the first line. As usual is our Python interpreter, which is unnecessary in case you are using the Windows. Next we have the comment, the creating multiple set. First set is, second set is this and the third set, and then we have the union of sets. So here you can see here it is apple, banana and orange, mango and pineapple. So the one particular element in this set and this set is orange. So this will be shrink into one. There will be no two entry or there will be no twice entry of the orange. Instead there will be a single entry of the orange in the union of the set. The union operation you know in the mathematics, right? So let us do it. The union set is set 1 dot union, then set 2. So set 1 goes here and set 2 goes here. So we do a union and the method here is called union itself based on the mathematical concept of set. Next, we do the print and we print the union set. That means the union or the unified set. Next, intersection of sets. Intersection set is set1 dot intersection dot set and then in the parenthesis we have set2. That means set1 comes here. It calls the internal method or function that is intersection and then set2 is provided here. So the intersection set will be created using this particular instruction. Now as we see intersection of the set, we have only one common thing, orange, which will go to the intersection set. Next we have our print command for the intersection set. Next, we have the remaining portion of the code. Due to the space problem, we have two blocks here. Next, difference of the sets. Difference set is set 1, then difference, again another mathematical operation. So set 1 usually is here and the set 2 is usually here, as we have seen in the earlier cases, that means here and here. And then we have the print command, that is the difference set. Next, we have symmetric difference of sets. Then we have SD set, that is set1 dot symmetric underscore difference. So this is another method or function available in the library inside the set, right? The set module. So there it does the symmetric difference within set1 and set2. We'll also see using the print command. So now we have seen 1, 2, 3 and 4 mathematical operation as per our learned mathematical operation of sets during our college days. So here once we run it, get this output. So the union set, you can see the first one here, it brings two elements into one, the orange. So orange has a single entry here and rest I think 1, 2, 3, 4. So 4 elements are there. So total 5 elements. This is how the union set is created. Now intersection set, as I said, orange is the common one. So this will be the intersection set and you can see here it gives the intersection set. Now difference set. So once we do the difference right, set 1 then set 2. If we differentiate, what remains there? The only 2 remains here. As we come across this one orange, and in this it is orange, so rest of the things are red, and here the difference is there, banana and apple. It also depends on the order. If you can recall the set mathematical operations from your mathematics book, you can also correlate the sequence in which we use the sets. Then we have the symmetric difference in set. You can see as we do the symmetric difference, right, we have omitted the common thing. Orange is not present here. Only 4 other elements are here. It's symmetric difference. There is a difference between the difference and the symmetric difference is that in difference, we start from the beginning. We encounter orange here, and from there we omit everything in the first one. And in the second one, in not that, we take everything together and then we make the actual difference. So actual difference is that we omit the common factor and keep the uncommon factors. Okay, so that is the symmetric difference. So this code and all the codes you can download from the GitHub. All the links are provided in the description. Go ahead and download them from the GitHub. We're done here. Let's move on to the next slide. We are done talking about the set, and now we are entering to the dictionary. Dictionary is nothing but the key value pair or the hash data structure. In modern languages, the hash that was earlier in primitive languages has been modified to take care of many things. So you will see that. So let us start our code to understand what is called dictionary. Key value pair, or you can say key value lookup, which is also termed as mapping. So here we have lookup, mapping, all names are here. So this is our first line. Now this is our interpreter. Next we have our set, that is a student, and then we have wow, then momo. This is key and this is value. Then KFC, then we have chicken, and then we have burger, then we have king. So these are key value pair. These are famous food outlets, so you know all. So wow, momo, KFC, chicken, and Burger King, all of them. But we have split here as key value pair. Wow, then momo. This is a key and value, key and value and value. So this way we made a dictionary here. Next, we use the print statement to print. Now, we use the restaurant and the index we write this. So, this becomes an index and it will find out that means this is a key. As we give the key, it will print the value which is associated to it. That means we are using the lookup table or the mapping method to find out. Next, we print the next one, that is from KFC, and next we print the burger. Then that means we are using this key. As we run this code, this is coming, which is much more obvious. The first one value is picked here. The second one value is picked here, and the third value is picked. So this is a simple data structure, that is a key value pair or a hash in Python. We are done here. Let's move on to the next slide. Adding, removing, and changing dictionary. Here goes our code. The first block of code. First line is our interpreter, which is unnecessary in Windows but essential in Linux. Next we have our comment here. Next, we start our data structure, that is dictionary, then fruits, and we have a curly bracket or second bracket here, and we have apple, fruit, and then color. So apple is red, banana is yellow, and we have a comma here. You can see all these key pair values are separated using the comma. Next, we have orange, then grape, then purple, and then here we close it. So this is the dictionary data structures, right? And here we print our entire dictionary using the simple print command, and we use the dictionary. So you can see here there are 4 key value pairs inside this particular dictionary. Now let us move on to the next part of the code where we do the manipulations. First, modifying dictionary values. What do? We write fruits, then apple, then we write green. So apple could be red, or we can have green apples. So we are changing the color from red to green. So this way we write this first, and then we give a equal to sign, and right hand side we give the value. So this is key and this is value. So that means we are overwriting red with green. Next, we have a print command just to print and see what is the change happen. Next, adding a new fruit. Here we write fruits, then as an index or key value we have watermelon, and we write as a green, and then we print the fruits again. Next, removing a fruit. We use the del command on fruit, and then we give the key value. So here this key value is provided, and corresponding the value will be omitted from this particular dictionary. So the del command is necessary to delete any element. Next we do the print. So we have 1, 2, 3, 4 print command. Let us see what they gives once we run the code. First one gives the fruits. That means here. That means all the key value pairs are printed as is. Next, after color change. So we have here, right? Modification. Apple goes green. So you can see apple is red here, but here apple is green. So this is changed due to this one. Now here you can see dictionary after adding watermelon. Okay, so here you can see the watermelon green. This is added to this particular dictionary. You can see the key value pair is added. Now we have removed a particular key value pair orange. So orange is here, which you can see missing in this particular one. This is from this particular print command. Okay, this way you can do the basic modification of the elements that are available in a dictionary, that is the key value pair or the hash structure. We are done here. Let's move on to the next slide. Taking existence or non-existence and determining the length of the dictionary. This is very simple. Let us start the code and consequently you will understand the things. First line is our interpreter, which is essential for Linux, unnecessary for Windows. Next we have created a dictionary. So here you can see fruits and our dictionary is there. You know this already, right? Here we close it. In the next part of the code, we have checking a fruit exists or not. Okay, so the existence checking. So suppose you have this particular dictionary or the hash structure somewhere you got from text parsing and you do not know what is there and what is not there. You must check it, right? So that operation you can do in this way. If banana is in fruits, print banana exists in the dictionary. Else, in the next line we have the avocado not in fruits. If avocado not in fruits, then we print avocado does not exist in the dictionary. In and not in are the things that we use for checking. So we are using the if only. We are not using any else like earlier. So here we are using directly if to write a less amount of code. And getting the number of fruits, that is the length, is the number of fruits, then length is the length of, you can see len is used everywhere in the data structure. It's the length. And then we have a print command. As we execute this particular code, we get this output. Banana exists in the dictionary. Yes, banana is there. Avocado do not exist in the dictionary. Yes, avocado is not here. And number of fruits is 4. So you can see number of keys are 4. It gives the 4 using this particular len command. This is very simple to understand and you can download this code from GitHub. Not only this code, all the codes that are shown in this episode you can download. Download link is provided in the description. Done here, let's move on to the next slide. Iterating over the key value pair for dictionary. So here we will use a looping method to iterate over the keys and values. Let's start our code. First is our interpreter. Next we have a comment creating a dictionary and we have fruits. Again we have the same one. In the next part of the code, let's start the iterating. For that we have just print a header, that means print fruit names. Then we start our for loop for fruit in fruits. We have print fruits and iterating over the dictionary values. Now how we can do on the values? Again we have fruit colors, right? Initially we have fruit names. That means this will be printed, all these keys. Now we want to print all these, right? How to do that? For color in fruits.values, since this is object-oriented language, we have used the method or function values, get the values inside one particular list and we are iterating on it. So color in fruit.values. So the values comes here and you can print them. One by one we print it using this particular print command. Iterating over the dictionary together the key value pairs. Here we have done the single access of either the key or the value, right? But here we are going to access together the key value pair. How? Here we have another header or heading, fruit name and color, and then we write for fruit comma color in fruit.item. So use this method to pick one key value pair at a time. So key goes here and the value goes here, fruit and color. Using this method you can do the access to the key and the value pair in a single shot. So use the print command, print fruit separated by another separator, that is colon, and then color. So this will be printed as fruit and color. So we have 1, 2, 3, 4, 5, 6 print commands all together to print out. As we run the code, first the fruit names are printed, next print command prints the fruit colors. So that means this gives these values and this was the header here. Again next this was the header here and this gives all these values. Now in the third one, we access the pair together, and this gives like first one gives the header, and this print command is printing this particular set of key value pairs. This code and all the codes shown in this episode are available for download. All the download links are provided in the description. Please go ahead and download them from the GitHub, so that all these codes are provided so that you can try at your end, do some modifications as per your thoughts which are getting provoked during this learning. So you try those codes, and for that you don't have to wait for me. Go ahead and download directly from the GitHub link and try out at your end. We're done here. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about function in Python. We'll go by definition. Next, we will take an example with argument of the Python function. Next, we will talk how a function functions. That means the working mechanism of a function. Next, we will talk about the function with returning values. So this is very important. A function can return a value or may not return a value. Here we will talk about the function which is returning values. Next, we will exemplify a function with default argument. That means there should be some default value of the given arguments of the function. In the very next point, we will talk about function with keyword arguments. So we will see in detail with example. Next, we will talk about special argument functions. So this is a discussion and it is not an example. So we will discuss couple of things here which is applicable to Python. Finally, we will talk about the call by reference. Earlier, all were call by values. Now, at the last, we will talk about the call by reference of a function in Python. So that's the menu for today. Without any further delay, let's begin. Function in Python. In this slide, we will talk about the function by definition, and we will describe how a function is constructed or how it is constituted. Let us see a simple hello world function in Python, how it looks like. First, we will have a name for the function which is preceded by a def keyword. Def is a keyword which defines a function, and we have a empty parenthesis or the first bracket, pair of first bracket. Next, we have the print statement, print hello world of Python. So if you write these two lines in a .py extension file, obviously there will be a Python interpreter, as you know from this series. This will become a hello world function, and you can call this function hello world at any part of your code, and it will print out the hello world of Python. In the next very point, we will talk about the keyword def is used to introduce a function definition. As I have said, def defines a function. Next, it must be followed by the function name and a list of formal parameters in parentheses. There should be some parameters here. However, only the hello world doesn't need anything here inside the parentheses, so it is left blank. The statements forming the body of the function start at the next line and must be indented. Because in Python, when you start something at the next line, you give an indentation, whether this is a space or a tab, whatever it is. Throughout the code, you have to main that indentation character. It could be a space, it could be double space, or it could be a tab, or it could be a double tab. So whatever indentation thing you are using, you should be using that. So whatever under this indentation will come under this particular line. The same is true for the function. The first statement in the function body can be a string literal, which serve as the function documentation string or doc string. So generally we have a comment or something like that, because when you are writing a function, you are not writing one single function, maybe you are writing several functions, and there should be a definition of the function at the very beginning of the function inside the body of the function, not outside, so that any stranger who is looking into the code is able to understand or grasp the meaning of the intention of the function. Next, including doc strings in your code is a good practice for generating documentation or facilitating interactive code browsing. So when we are coding, generally we give a comment here, comment there, and comment here. So in this way, when we put comments, right, it's very easy for a third person, maybe who is not you, who is not your boss, maybe someone else from another team, because in VLSI, the work is generally a cross-team collaborative work. In that case, you are maybe from team A and someone from team B is looking into your code. He may not be aware of entire thing. So in that case, in person, you or your boss have to be present there to make him or her understand what the code is for. So in that case, it should be a good practice to put a comment. It's a good practice to put a comment at different levels of the code. That means at different important turnarounds or maybe at different important blocks, the comment should be there or some couple of comments should be there to understand what that block is doing. This is a good way of conveying the message to any unknown person who is going through your code, because this is scripting. This will not be given as a binary to someone. It will be processed as a script to the end user. An end user, if want to look into the code, he or she must be able to grasp the meaning quickly. And here the comment plays a good role. And especially I will recommend you, for a good practice, maintain this style while you are coding in VLSI. So we are done here in this particular slide. Let's move on to the next slide. A function example with argument. Earlier we have just seen the hello world function which you can execute at your end. I think this is a 15th episode. Right now we are broadcasting. So by now you are well able to write the codes of Python and you can write the function your own end. Now here we will give a simple function how it is written in Python. So here goes our code. First line is our interpreter. Obviously, if you are in Windows, you will not need this line. This is needed when you are in Linux. Next, we are writing the def keyword followed by the function name fibo and followed by its argument, that is n. Here n will be an integer number. Since in Python we have automation or automatic detection of the variables, we are not writing int, char or something like that, which was there earlier in C language. So let us go to the next very line, and here you can see there is a indentation here, and whatever comes under this indentation vertically, sorry, the line got bent. So if I try to write the vertical line here, whatever comes under this will be inside the function. So here we give the doc string, that means the comment function to write Fibonacci series up to n. So by the name you can see it is Fibo and it's a Fibonacci series function. Up to n means n is the last entry, or you can say the upper limit up to which the Fibonacci series should proceed. So at the next point, we have the initialization of the two variables a and b, and we have 0 for a and 1 for b. This is you can do together. That means you are assigning a and b together. So initialize first two numbers in the series. Next, print Fibonacci numbers less than n. We'll print it. We write a while loop, a less than n. A means this and a means this. And then again you can see we have another indentation level for the while. Everything under this is under the function and everything under this while. Next we have here print a and then end equal to this, and update the values of a and b to calculate the next number of the series. So what we do here, we again assign b to a and a plus b to b. So this is a dual assignment. That means we are assigning two variables at the same time. So assigning b to a and a plus b to b. This way we are assigning this. So this is how our initial variable shifts to the next position, and the next position is proceeding in the manner how the Fibonacci series should proceed. Next, print a new line after printing the series. So here we are printing a new line. It's a print then blank, nothing else. Next, here you can see up to this it was under the while. Now we have came back inside this Fibo. So we have came out of this while already up to this, and this is we are back again under Fibo, and here we have a new line and calling the defined function with target argument. So you can see we have totally come out of the function body here because this indentation is no more. It has ended here, and this is again to the original indentation. So the function body has ended and we are calling the function here Fibo. Then we are putting the limiting number 9 and then we are writing Fibo and limiting number 49. So the series will end somehow near 9, and this yes the series will end somewhere near the 49. Once we execute this code, we get this output. So the first one is series is this one and the second one is this one. You can see 0 plus 1 we have 1, then 1 plus 1 we have 2, and then 1 plus 2 we have 3, then 2 plus 3 we have 5, and then 3 plus 5 we have 8. So this way the Fibonacci series proceeds. The same is true for this bigger series. So this way a function can be defined, and you can see this way the entire body of the function is captured in a Python code, and later the function is called in this fashion. Now this could be in one Python code and this could be another Python code. Obviously they has to be interlinked somehow. We are done here. Let's move on to the next slide. This is a discussion slide, how a function functions. So here we will discuss about a function and its functioning, especially inside the Python. When a function is executed, a new symbol table is created using its local variable. So this is a concept again for the local and the global. Whatever values and variables we are using is very much local to that particular function. A new symbol table is created. Remember, in some of the programming language, we have namespace. This is a very similar concept, the symbol table. Variable arguments within a function store a value in the local symbol table. So whatever values we are doing, adding, manipulating, assigning, whatever we are doing, it is happening in the local symbol table. That means inside the function only. Direct assignment of the global variables or variables is in enclosing functions is not possible within a function except for using a global or a non-local statement. So there is a global statement. Unless we are using it, it is not possible to directly tie a global variable to the function and its local symbol table. This is the speciality. I think this is the beauty of the function, because whatever you are doing, it is happening locally. Even if you have a same name variable, that means you have another variable outside the function and inside the function, both have the same names. In that case, they will not clash, because whatever inside the function is operating on the local table particular to that function, and this is the local variable, and whatever outside, it may be a global or it may be a local to some other body of the Python code. So this is the beauty, and this is the functioning, how the function functions. Arguments passed to a function call are introduced as local variables in the called function symbol table. So whatever values we are passing on to the function goes to the local symbol table. These are values, not the variables. Even we are assigning some values to variables, maybe inside the function, right? We have the function parenthesis, and here we write a variable, another variable we write, and this variable contains values. So those values will go enter into the function's body as local, and these variables will be intact, whatever they were outside defined. So these were defined outside and they are carrying variables up to this point, and they hand over to the local symbol table, and that goes to the function itself. Arguments are passed by values whether the value is always an object reference. So this is very important. We just talked here, right? The arguments are always passed by the value, which I have just discussed here in this point. And this is the emphasis and more clear and straightforward way of telling that. When a function calls another function or calls itself recursively, a new local symbol table is created for each of the call. That means we are calling a function here. Again, it is calling here. So each time it is creating a local table. You have seen the movie Inception, right? In that there was a concept that we are instantiating here, and then again inside that we are instantiating here. In this level of hierarchy, we are going down. So just remember that concept from the movie Inception. The similar thing is happening here. When one function is recursively calling the same function, each and every time a local variable or local table is created. So here we are done discussing how a function functions. That means this is very important for your VLSI interview. Why? Because here we have explained the mechanism how a function works inside the Python. And these things you could be facing as a tricky question. So these are very simplified explanations, so that you understand it well and you are well prepared for any tricky questions. So questions are not here, but however you know the fundamentals, so you will be able to answer any tricky question in the interview. We are done here. Let's move on to the next slide. Function with returning values. So far, if we are writing a function, right, hello world, it is not returning any value. Rather than on the screen, it will print hello then world. So it is not returning. In this particular slide, we will talk about function. When they are executed in real time, we will return, maybe at the end of the function body, there will be some statement to which it will return some value. So let us start our code. Here goes our first part of the code. First line obviously is our interpreter. The next very line is the function with returning values. This is the docstring, or you can say the definition. Next we write the def keyword, and then we write the function name, that is add, and we write two arguments a and b. So a and b, theoretically it seems that it will add a and b together, and the added value of a and b should be returned back. That is the intention. You can see here we have an indentation character here, and then we have the next line adding %d, and then we have a % here, and then a and b. This way whatever a and b is, they are printed here and they will be added. Now we have a return statement of a plus b. So we have a plus b as a return statement. That means once the a and b value comes, this will be printed, adding this, and this value will be immediately returned. So this is like hello world, we have a print, but however in addition we have a returning value. That means when the control goes back to the main program, right, the main body, this value will be returned. And if we assign a variable, right, p equal to add a and b, this returning a plus b will be returned into p. Let us proceed further inside the code. If subtract a comma b, and in the same way we are printing here subtracting a from b, we have return value a minus b. Next we have multiply a comma b, and then we write, that means we print multiplying a with b, and we return a multiplication b. So asterisk is used for the multiplication, and hence we are returning this value. Yes, then we write divide a comma b, and here we write dividing a by b. That means we are printing it and we are returning a by b. So this is the first part of the code. Here we have defined all the functions. 4 functions we have defined with returning values: add, subtract, multiply and divide. In the next part of the code, we will call these functions. So let us call them here with numerical values. First, a equal to 10. And then b equal to 5. So we are assigning 2 integer values, a equal to 10 and b equal to 5, to a and b, because we will be using this value. Next we write result add. This is the variable where the output will be stored, and we write add a plus b. So whatever is added here and returned here, it will go into this particular variable. Next we print it. Next again we write result underscore subtract, and whatever is returned through this statement will go to this particular variable. Then we print it, and again we write a variable result multiply. Whatever we are getting from return here will go to this particular variable by calling this function. Similarly, we have printed the multiplied value here. Next we write another variable result, then divide, and whatever divided return is going to be stored in this particular variable through calling this function. And here again we print the result divide. Now this is a single code, but because of the space limitation, I have split into 2 parts into this slide. Once we execute the entire code, the output comes as this. So adding, you can see 10 plus 5. So this statement is coming from here, adding, and you can see this statement is coming from here. Result of add is 15. In the similar fashion, once we pass this subtract, right, this first print statement is coming here subtracting, and from here we are getting result of subtraction. We proceed in the same manner. Here multiplying, here it is going here, and this result multiply goes here. In the same way, dividing, this statement is getting printed here, and result of the division is printed here. So this way, a function with the returning values is defined and called in Python. We are done with this example. You can download this code, and whatever codes we are going through in this particular episode and all the previous episode, they are available in GitHub. Download links of the respective episodes codes are provided in the respective episodes description. You go to the video description, you click on the link, you reach to the GitHub. From there you download the code. Once you click the required link, it will take you only to that particular code. So go ahead, download those codes, do some alterations at your end and try out. Because without trying at your end, you cannot learn a programming. We are done here. Let's move on to the next slide. Function with default argument. So here we are dealing with the default argument. That means the function, we have a set of argument, and some of them or one of them may have a default value. So this is our function, and we have a parenthesis. There are say 3 variables, 1, 2, 3, and here we have a default value. If we do not give this, the default value will be picked up. So this is the theme of this particular slide. Function with default argument. So let us proceed for the code. Here is the interpreter as the first line of the code. You will not need this in the Windows. However, this is essential in Linux. So here we give a prototype. Def ask okay, then there is a prompt, then retry is equal to 4, and reminder is please try again. So these are 3 different types of the arguments, and we will complete this code in the next slide. This is just a placeholder, and here we will talk about what each of these particular means. So the purpose, this is a doc string, basically ask the user for confirmation with a prompt, allowing a certain number of retries. Arguments are prompt is the string, the prompt message to display no defaults here. So So you can see prompt will not be considered as defaults. Retries is integer, the maximum number of retries allowed with default values. So you can see 4 retries will be there. Reminder is string. The reminder message displays on the input with default. So in case the input you have given is invalid, then it will be given. Please try again. What it returns? It returns boolean. True if the user confirms with Y or YE or yes. False otherwise. Any other cases will be false. Raises value error if the user exceeds the maximum number of retries without providing a valid input. So this is the doc string. That means this is you have to write here when you are writing a function. What the arguments means, what the purpose, what is the type, what its limitation, and what its flexibility, all these things. So this was just for your understanding. In the next slide we are continuing the same code, but however there will be the code only, and there will be code and its usage, and here it was just to discuss what this function is intended to do. So let us move on to the next slide for the actual code. First line is our interpreter. Now we have the definition, and we start our code with the while. You can see there is a indentation character here. Then we write while true, that means it's a while loop with the true condition. Until or unless you are forcefully breaking it, it will continue. Next, prompt the user and get their response. OK equal to input, then prompt. So this is another function. You will see what it does. It gives the prompt. If OK is in Y, YE or yes, what it will do? It will return true. If OK is in N, no, nope, no, all these things, it will return false. Next, decrement the retries counter. Retries equal to retries minus 1. So you can see it is 4 by default and it goes to 1 minus. You can override this value if you suggest, say, there will be 10 retries. So you provide 10 here. So in that case, the default will be overridden. But in case you are not providing the retries, it will start counting 4, and from there it will deduct 1 and go again in the while loop, and this way it will go further. If retries is less than 0, the maximum retries has exceeded, raise an error. So here it will raise another keyword in Python. Value error is invalid user response. So that means the function has retried multiple times to take the user input, but the user is not giving a valid input. Next, print the reminder message of the valid input. Here we print reminder. So reminder is here. You can see. Please try again. So you can see calling of the function. So here this function has ended, right? Now let us call the function. Confirmation, then ask underscore OK. Do you want to proceed? Yes or no. This is the calling of the function. And next, in the further part of the code, we have if confirmation. Print you choose to proceed, else you choose not to proceed. That means we are putting true or false here, and we put a if-else condition here to check whether true or false. According to true, we are printing this. According to false, we are printing this. Once we execute this code, right? For the true condition, when this is prompted on the screen and we type Y, so the true value goes to the confirmation and this block is activated. So you can see you choose to proceed. You can see this is printed. And again we execute the code, and in that case we type in. You can see this goes to here and false is stored here, and false it goes to the else condition, and this is printed. So you choose not to proceed. This comes here. You can see. So this way a function with the default argument works. That means some of the value is default, and that will be used in case you are not overriding it. So here you can see this has a default argument and this has a default argument. Only the prompt you are taking from the user. You can also give the values of retries here as 10 retries, and you can say reminder also you can give some string, and then you can close the first bracket. Okay? In this way you can also call the function. This code is available for download from the GitHub. The link is provided in the description. Go ahead, download it, do the changes you want to do, try out the code at your end. This is how you are learning. Not only this code, all the codes are shown in this episode and in the entire series are available in the respective video description with a proper naming. So against that naming there is a link, so you go to the link and download it from the GitHub. Once you click the link, you will go to GitHub, and there you can either copy paste or you can download the code as a zip or something like that. We are done here. Let's move on to the next slide. So here we will talk about function with keyword arguments. So this is another thing that is available in Python. We will talk about the keyword argument, so you will understand how it functions. We will make you understand this thing with a code. So let us start our code. First, here is our code. Here goes the first line, which is an interpreter. And here we have a definition. Remember, like the previous function, here we will give a definition of the function and later we will use it in actual code. So we will make you understand, otherwise it will be very difficult because there are several variables and they mean different things to you and maybe into the end user. So we have a function parrot, we have a voltage, state, we have action, we have type, we have. You can see these are already containing values. So now let's have the docstring. Simulate a parrot speaking with various characteristics. Argument, voltage is int or float. The cage light voltage. So parrot is in a cage and the cage contains different lights which are maybe colored or non-colored and they depend upon the voltage. Those voltage parrot will pick. State is the state of the parrot. Action is the action of the parrot performs. Type is the type of the parrot. The parrot could be different types. So here is a Norwegian blue. It could be different types of species of parrot. So here you can see we have 4 different arguments and they mean different things. Now let us move on to the next slide where the function is defined and called. Before proceeding, one more thing. Function can also be called using keyword arguments of the form argument keyword equal to value. So argument keyword equal to value, keyword equal to value, keyword equal to value. So remember this thing. So let us move on to the next slide. Here we define the function and call it. So let us start our code. First line is the interpreter. Next we have def, then parrot, then voltage, then state, then action, then type. We have defined and explained all these in the previous slide. So we will go and start writing the code. First line is the parrot information, is a print command. Next we have the print voltage. Next we print the state. Next we print the action. Next we print the type and then we give a separator by print so that if there are multiple instances are called, right, there will be separator to separate each and every instance. And here we are ended. So this is the function body and there is nothing more. We just getting the values and printing it. We are not doing anything here. We are not doing anything else here. So example usage of the multiple argument combination. The first combination is this parrot and 1000. So when rest of the things are defined, we are only giving the voltage value 1000. Next, we are giving the voltage value of 200 and here we give tired here. Instead of boom, we have fly here and instead of Norwegian blue, we have cockatoo here. So we are overriding the keyword values. Next, we have 3000. Then we have a relax, jump, African gray. Next, we have action equal to sing. So you can see we have swapped the different places, right? Action has came in the first while it was in a third position. Action equal to sing. Voltage equal to 6000. So earlier voltage were in the first position. It has came. State is equal to a happy. It was in the second position. And type is Macau. So this is the beauty of the keyword arguments where you can change the position. That means this is keyword and its value. Keyword and its value. Keyword and its value. So you can place them anywhere. Or you can give the values if you want to maintain the same order. Otherwise, you can change it as a keyword and value style. So this is how you define and this is how you flexibly use it. Next, we have parrot, then type, love bird, then voltage is equal to 7000, state is sleepy, and action is equal to cuddle. So you can see here again we have changed the position of the action, which was initially here. So we are continuously swapping or changing the position of the arguments. This is what we can do with the keyword arguments. Next, again what we do, we come back here and again we change the position. 8000 goes for the voltage. Voltage is unchanged. Then we have type equal to Amazon, state equal to excited, action equal to top. So action was originally here, state was here, and type was here. We are again changing the position of the argument. So rarely the position is defining the arguments, rather the key value pair is defining the arguments and their values. This is the use of the keyword. Once we execute this code, this comes out. So you can see all these things are printed. So the first one here is printed here. Second one is here, the third one is here, the fourth one is here, one is here, and the sixth one is here. So you can compare these things. It is very easy. Go ahead, download this particular code from GitHub. The link is provided in the description. Try it out. Do all this swapping, whatever way or whatever combinations you want. Remember, when you change the position, you have to maintain the key value combination. You cannot write here only 6000. You cannot write it. You have to write a key equal to value in this way. So do the swapping and try out this particular code. Download the code from GitHub and do the changes as you want. You're done here with the particular code and its output. Let us move on to the next slide. special argument function. So this is a discussion slide. We'll talk about the different argument and their specialities in Python. Let us start our discussion. By default, the arguments in Python can be passed by position or explicitly by the keyword. So explicitly by the keyword, as we have seen in the previous code, and position we also have seen in the last two examples. Restricting the way of arguments can be passed, improve the readability and the performance. So this is the beauty of the Python, that we can play with the arguments, which was, I think, not possible in C language, which was very stiff, this kind of nature. Next, we have function definition example def, then we have position 1, position 2, then position or keyword, then keywords, then keyword. Okay, this could be star, this could be slash. Okay, so this way, this is a flexibility. The slash and the star are symbols indicate parameter types for argument passing. Positional only, positional or keyword, and keyword only. The position or keyword goes here, keyword only is here, and keyword only is here, and the positional only is here and here. So this could be mix and match. So you can do the mix and match. You download the last two codes which we have just discussed. Then you can write something which is a mix and match of this, how we have shown here. This is the beauty of the Python. If slash and star are not present, arguments can be passed by position or keyword. Positional only parameters are marked before by the separator, the slash separator. Their order matters. They cannot be passed by keyword. The slash separate the positional only parameters from the rest of the parameters. That means these two position only parameters are separated by a slash. So this is a separator inside the argument. The position only parameters will be before this slash. If there is no slash, there are no positional only parameters. So these are positional only parameters. Parameters after the slash can be positional or keyword. So this after this slash could be positional or keyword only. Keyword only parameters are marked by placing a star before it. Since this is here, anything after this will be keyword only parameters. This is a style that Python maintains. Anything before slash will be positional. Anything after this star will be keyword only. This is how we are restricting it. Keyword only parameters must be passed by keyword arguments. So this should be key value pair, this should be key value pair, and this could be position or keyword. Anything after star is strictly the keyword one, anything before slash will be strictly the position. Okay, this way you can restrict it. Otherwise you can mix and match, as you have seen in the previous example. So this is the tricky things that you are learning about Python function, and this can be asked in interview. So get prepared. Try out the codes, do the modification, try out, and if the error comes, if it is not intended, that is how you will learn. So go ahead and download the codes from GitHub. Links are provided in the description. Do the changes and learn. Here we are done discussing about the special arguments, that those are available in Python. The methods deal with the different type of arguments, or restricting maybe the types of the arguments, or making them flexible. Anything, anyhow, any angle you can take on this. And down here, let's move on to the next slide. Function call by reference. Generally, this is also termed as call by reference. Let us start our code to see how the call by reference can be done. The first one is our interpreter, which is useless in Windows but essential in Linux. The next one is def, the function, then the modify list, and then the list. Then list.append, then for the list function available along with the list object, right? The append function, we write for. And then this is the function, right? And then my list is 1, 2, 3. We're writing it. We have come out of the function, and up to this is the function body. So it ends here. And outside this, we are writing my list is 1, 2, 3. Next, before modification, we print the my list, and after modification, calling by reference. Modify list, then my list, and here we print it. Now why this is a call by reference? Because here we are not taking the output here onto some other variable. So it is operating on the list itself, and this is how the position, that means the memory position of this list, is used, and hence this is a call by reference. Once we execute this code, this comes. Before modification it is 1, 2, 3, and after modification it is 1, 2, 3, 4. So here the list is passed on to as is with the reference, and here the the reference is modified, that means 4 is added here and the actual list is modified. Not we have a modified list and then we assign it to some other list and then we are printing. No, we are just modifying the original list here, and this is why this is called the call by reference. The reference of the list goes here and it is modified, and before and after, say you can see we are printing the same variable here, my list, and before modification is this value and after modification is this value. You can see this is how the call by reference is working. So we have done talking about all about the functions in Python. You can go ahead, download the course from the GitHub links provided in the description. When we are done here, hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about the basic definitions of modules in Python. Next, we will talk about a Hello World module, how you can create a Hello World module in Python. Next, we will see various variations of Hello module in Python. Next, we will learn the multiple types of importing styles in the next section. Next, we will talk about the Python module search path. This is very important when you are working in a Unix or Linux environment and maybe some other operating system, because this search path will help you to place your Python module in the right folder or right directory. So that's the menu for today. Without any further delay, let's begin. Module in Python. So let us see the definition of a module in Python. In Python, modules are files that contains function definitions and statements. Most important is the functions. Those are very important because most of the time we use the functions inside the module. Also, there could be any other application also of the module and whatever statements are therein. Because through module, we create a reusable Python code that can be defined once and used in the multiple cases of a same user or maybe for a set of users inside a VLSI company. So whatever module you will be writing in Python for your company, that may be used only by you or may be used by a lot of people in your company. So this is the basic need of creating a Python module, that is the code reuse. These modules can be imported into other modules or main module. So this can be imported. Say you write one particular module and when you are writing another module, you see that if we have instantiated inside this, the effort of writing the line by line code would have been less. So in that case, what you will do, you will import this particular module inside the next module. So that is also possible. The file name of a module is the module name with the .py suffix. So when you are saving the Python module, you also have a .py suffix as similar to your normal Python. Next, the name of the module is stored as a string value in the global variable called name. To use a module, you first import the file into the current script. That means whatever current Python file you are putting inside that, you have to import. And to import, the keyword in Python is import also. You will see later in this episode. Once imported, you can access the functions or variables in the module using the dot operator. So also we will exemplify, so wait for some time. And these codes, whatever we are going to show in today's episode, are available from GitHub. The download links are provided in this video description. Here we are done talking about the module in Python. Let us move on to the next slide. Hello World module in Python. So let us code the Hello World in Python and using the Python module. So here goes our hello module.py. We have underscore in between the hello and the module here. And here goes our code. The first line of code is #bang user bin python 3. This is the Python interpreter. Next, we have the function definition def hello. And in the body, we have print hello world. So this is very simple function which prints the hello world. Now, this is executed when the module is run directly. So you can directly run this hello as if name equal to main, then hello. So this will print the hello world. So this is the namespace. That means this is the main namespace. Inside that we are calling hello. So this can be executed in this way. Next, we have main hello.py. So we are writing another Python code which is separate from hello module, and this is main hello. So here we are writing our basic code. So here goes our code. First line is again the interpreter. Next, we have to import the module which we have written here. How we do that? We use the keyword import and then we give the module name. You can see this is the module name and we are not giving the extension here. So you can see there is no extension here. We are keeping these two files, this file and this file in the same directory for the practice. This is another thing I would like to mention. Now, after importing, how we access this hello? This is the challenge. To overcome the challenge, we do the hello underscore module dot hello. So you can see hello underscore module dot hello gives this particular hello. So once we give a dot separation here, we are accessing the hello function defined in the hello module. So this way you are going to use the function that you define inside any Python module. So once we execute either of this code, maybe you are executing the first code or maybe using the second code, while the first code is already present in the present directory. While the first code is already present in the present directory, then you will get this output. So hello, comma, then world. So this will be there. So this way you can write the hello world function inside the hello module and you can access that particular function by importing the hello module and then using a dot separator to access the hello function to print the hello world in this way. So we are done here. Let's move on to the next slide. Let us see some more examples of the hello module that you can write in Python. So here we'll see different other styles of writing the hello module. So here we are writing the hello underscore all.py. So this is a Python module and the code consists of the first line is the Python interpreter. Next we have the function definition def hello world. Next we have the print hello world. This is the print command. And then we have the def hello universe and we have hello universe. So you can see here we have two different functions. One is the hello world, another is the hello universe. So these two will print the hello world and the hello universe. This is executed when the module is run directly. If you make it executable and you execute directly this one, then the below code section will execute these two functions. If name equal to main, so that means the main namespace is there, then we write hello world and hello universe. So this is the direct execution of this particular module. That can be also done. And if you want to reuse the code, that means you want to instantiate this particular module into some other Python code, this is the way you should approach. Here we have main hello all.py and here goes the body. First line is the Python interpreter. Next we have the import hello all and next we have the hello all dot hello world. So we have imported the hello world module and again I am saying there is no py here. There is no py here after this hello all. So this is done and now we are calling the function by using a dot separator. So hello all dot hello world. Next we have the hello all dot hello universe. So that means we have already imported this entire code here using this import command and we are calling this particular two functions. So this is the way you can reuse the Python code. That means you can instantiate this particular module in multiple number of your Python codes and there you can call this function as many as times you want to use them. So once we execute, this comes. First, this gives the output hello world and this gives the output hello universe. Also, if you have directly run this particular code, that means this code, so this will give the hello world and this will give the hello universe. So this is the thing you have to remember. We are done with this particular slide talking about the different types of hello module in Python. So you have kind of idea about how the Python module is, how you can write a module and how you can reuse the Python code written in the Python module by using the import command. So let's move on to the next slide. More importing styles. Here we will learn about various ways of importing a Python module. Like in the last code you have defined hello all, right? And how you can import it in different fashions. Why I have kept this particular slide is that in various sectors of VLSI, when different people are coding, you will see different types of coding styles as per their individual taste. And you have to know all of the ways that import can happen for a particular Python module, so that you don't get taken aback by a coding style of another person while importing a Python module. Now, let us start our code. This is the main hello all.py, and again I am mentioning that all these .py files you will be able to download from the download links provided in the video description. So here start our code. First line is our Python interpreter. Next, we import hello all. Remember, we have already created hello world in the last slide. See, we are reusing that code and importing. Next, we can call hello all.hello world and hello all.hello universe. This is one style that we already know, which we have done in the last slide. So next, we can also do this import hello all as alias. So this is another name. This is not the same name. This is another name, alias, but it does mean the same. So this module, we are giving a nickname of this particular Python module as alias, and we will be using the alias in the rest of the code. Let us see how to do that. Alias.hello world. Here you can see instead of hello all, you can see alias.hello world, and similarly alias.hello universe. You can see here, you can see the difference. Here we are using the hello all, and here we are using the alias. Why? Because we have imported hello all as alias. So this is a different coding style. Next, we import in another way. From hello all, import hello world and hello universe. So earlier we have imported import as and only import. Now we are from hello all, we are importing the two different subroutines or functions, or you can call methods in if you are in the object oriented regime. So here you can see we can execute the hello world as this and hello universe as this, so you don't have to use the dot operator. So this is another way of reusing the code. So you can import the code and use it with the name without any dot in this way. Next, we can also use another coding style, that is from hello all, import hello world as HW and hello universe as HU. So hello world will be shorthand as HW and hello universe will be shorthand as HW. So this is another crisp way of handling the code reuse and using the import. So you have came across all the variants in the way you can import. Next, we use the HW and next we use the HU. So we run, we will get the same output. So hence I am not showing the output here. Just give a look. You can use the import hello world. Then you can import hello world as alias. Then from hello world, import hello world and import hello universe. This is one way. And from hello world, import hello world as HW and import hello universe as HU. These are the four different types of importing style. This is the way you should learn the different importing styles, because in the industry people may follow this style and you get that particular code for editing from which has been written by someone else and you get taken aback. What has happened, how it is doing, and also someone is writing in this fashion. You have to identify how it is done. Now you know all the variants and all the types of the importing styles in Python, and this is very frequent. Whenever you are using any Python module, you have to import something or everything from that particular module. This is a very frequent practice, because whether you are in VLSI or you may be in some other field, any Python module is imported in this particular style. Especially the VLSI tools that are there, maybe in GitHub. Here you will see there are a lot of scripts where you are importing in 4 different ways, as I have shown you. So we have done talking and we have seen the various variants of the importing styles, and now let's move on to the next slide. Python module search path. So in this particular slide, we will talk about the search path. This means this search path in Python. So let's start our discussion. When we have a module named xyz underscore module and we import it, the interpreter follows a specific search process. How the Python interpreter search? Now let us see. It first searches a built-in module with the name xyz underscore module in the this underscore bulletin underscore module underscore name. Here in this variable, the system variable or the Python internal variable, the interpreter first search for this particular module. If a built-in module is not found, it looks like a file, then xyz module.py in directory specified in the sys.path. So sys.path is another variable for the Python. So it will look there for this particular file name where that is stored. That means where this particular module file is stored. Sys.path is initialized from different location. Now let us see. The directory containing the input script or the current directory if no file is specified. So there is another system variable called Python path, which is a list of directory names similar to the shell variable path. The installation dependent default, typically including the site packages directory managed by the site module. So this is talking about the Python installation part. After initialization, Python programs can modify the sys.path. The directory containing script being executed is placed at the beginning of the search path, overriding modules with the same name in the standard library. So we are mentioning here, if this particular module we place at the beginning, right, then if the default Python library has some module in this name, that will be overridden by your xyz module from the standard Python library. Next, the behavior can lead to errors if the replacement is unintentional. So there is another catch here about the errors. Note, if the file system supports symbolic links, the directory containing actual script is used, not the symlink directory. The symlink directory is not added to the module search path. That means you are using a soft link here, right, which is targeting some path right here. So that actual path will be included, not the path from where to the symbolic link exists. So all the files in this particular directory, which is the actual path of the symbolic link and not the deciding directory of the symbolic link, will be called. This is the thing that we can expect from the search mechanism in the Python module search methods that is existing in Python. So here we have talked about where you can expect any module to be there. So we are done talking here. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about real-life class and objects. We will introduce you to the concept from where the object-oriented programming concept originated. Next, we will discuss when the object-oriented programming should be used instead of procedure-oriented language. We will talk about multiple scenarios. Next, we will give a brief idea of the mental tussle that each and every student like you face when they try to understand the object-oriented programming. Every time you will face and will give you a fair idea how to deal with this mental tussle. Next, we will discuss object-oriented concepts like class and object. Going further, we will talk about method, encapsulation, inheritance, abstraction, polymorphism. Now, these two are the basic concepts, and these are the concepts that coexist in object-oriented programming. Also, we will give you odd example of each and every concept. Next, we will go through odd example of all the object-oriented concepts in Python 3. Going further, we will do a comparative study of Python object versus module. And finally, we will summarize our entire learning of object-oriented programming in Python. So, this is the menu for today. Without any further delay, let's begin. Real-life class and object. So, here I will give you a pictorial example of real-life class and object. So here you can see multiple students are sitting in a class, right? And here you can see there is a teacher. Although the teacher is blurred, but you can see her still. Now you can see that there are many students. So here are some students, and these are the students who are backbenchers. Now, this is a very typical example of class and object. When you are in a school, right, you are in a class, and that class, each student will have a name, a roll number, and you might have a section of your class. And each of the student will have different names. So these are the objects. And here, the teacher also belongs to the school. However, he or she may be a different object. or rather a different class. Now, teacher is also a person who is inside the school, but the criteria of a teacher is very different. So here the teacher, obviously his or her age will be very much higher than the average students of a class, and this is the difference of the teacher and the student class. Obviously, if you go to a teacher's room in a school or college, all the teachers will be there, so they belong to the same particular class, means not the school class or school standard, but the class in terms of the concept of object-oriented world. Now, teachers are teachers and they are human beings and they belong to the school. The students are also human beings and they belong to the school. However, teachers are a separate class and the students are of a separate class. The property or criteria of students and the teacher makes them different, and this is the real life concept of class and object. And the teacher, if I say teacher, this teacher may have a name which is given by her parents and she is carrying that. And in the teacher's room, when you go there may be 30-40 teachers. Each of them will have a different name, different age, and they will teach different subjects. So even if you look inside the class of teachers, each teacher will have different properties. And here, if you look, right, visually all the students are different. So you can see some of are them girls, right? Some of them are boys, you can see, and some may be a bit taller here, okay, and some of them may be a shorter of height. So there are different properties each of them are carrying, but they belong to the same classification. Rather, if we shorten the word classification, it becomes class. And here the student class has all the students. However, each of the students who are the objects of that particular classification or class has different properties. So here some of the students may have black hair and some of them may have brown hair. Some of them are wearing t-shirt while some of them are wearing kurtis, some of them are wearing t-shirts, and here you can see the student is wearing a shirt. This way each object is different from one another. However, you will see such visual difference if you go to the teacher's room. Each of the teacher will be either male or female and they will be of different heights, they will be wearing different clothes, they will teach different subjects, and they will have different degrees, although they will have a common classification of teacher. So that classification or the class of teachers is a set of people who are having some properties similar. Again, similarly, all these students have some of the properties which are in common, so they belong to the same classification or class, and each of the student is an object. Similarly, each of the teacher are object of the class teacher, and here the students are the objects of the class or classification student. So here we have given example of real world class and objects which you can find in vicinity of you. And today if you are learning Python, you might have already passed several standards reach up to this level and you have seen this. So this is not something, the concept you have to virtually draw or hypothetically draw. It is there in front of your eyes. So you can start thinking about the class and objects with this particular and very easy to grasp concept. We are done here. Let's move on to the next slide. After having the concept, now we will discuss when to use the object-oriented programming instead of procedure-oriented programming. So here, let's start the first point. The system being designed is large or likely to become large over time. So you can see if I compare this line with the picture just I have shown, right? So when a school starts, right, it may have from standard 1 to standard 5. Then as the school grows, more 5 standards are added. So it now have, after maybe some years, it has standard 1 to standard 10, and then it will have 10 plus 2. So this way it will grow. And also each of the class can grow in terms of the sections. Say we have a class, say it is standard 1. When it started, it only has 2 sections. Over time, when the population increase inside the school, right, in the next or coming academic years, so there could be section A, section B, and section C. So this can become larger. So when we are having the concept of the object-oriented programming, we have just shown, right, in the last slide. So this way, we will keep on relating the concept to the programming concept. And the object-oriented programming is applied on real-world objects which can grow over time. That means the objects class will be the same, but the number of objects can can grow over time. So this is what we are talking here. The data can be put into obvious structures. In the previous pictorial example, you can see that we can put the teachers into the classification of teachers and the students in the classification of students. And we can then subdivide as per of their hairs, variables, and etc. etc. So obvious structural shape should be there of the data to apply the object-oriented programming. There is prominent of inheritance and polymorphism. We will talk about the polymorphism and inheritance in detail in later and chapter and slides, but just to brief, inheritance is nothing but what you get the properties from your parents. That means whatever criteria or whatever qualities you have inherited from your parents is called the inheritance. And polymorphism is a different concept. To explain this, we will have to wait till the slide of the polymorph. There is a piece of data on which many different operations can be applied. If I say there is a class test, so there is a method, right? So that class test we can apply on each of the students. So a class test is announced on maybe 15th of January, and that 15th of January, each and every student will have to face a class test. So a piece of data which maybe many different operations can be applied. So one is a class test, and maybe on the 30th of January, there could be one sports event. So these are different events and operations. They can be applied on the objects. And here we say there is a piece of data. Data here we say this piece of data is nothing but the clan of students in the school. You may need to perform the same general operations on related types of data, but with slight variations depending on the specific type of data operations are applied to. Again, let me bring the previous thing. There is a class, and there the class test is going on. Okay? Slight variation is what? Say student 1 may require 5 extra pages for writing the test, and student 2 may require 10 extra or 15 extra or 20 extra sheets for their exam. So there is slight difference in between them. Once the result come out, right, of the class test, there will be also a difference of the result of numbers. So here you can see there is a variation, but however there is a generality among the students. That is the classification or the class, and each of the students, when they are addressed, they are called the object. Chances are there that you may add new data types later. So you can add something, some addition is there, right? So this might happen. So such a way the object can have some addition of the data, and you can see as the student grows, there could be some other changes as per the rules of the school. The implementation of individual components of the system is likely to change over the time. So something which we can expect to change over time, the object-oriented programming can accommodate that. So that accommodatability or accountability should be there inside the object-oriented programming. The system design is already object-oriented. Large number of programmers from multi-site will be using your code modules. Here we are talking about specifically the industry which you are working, or maybe you will be working. That is a VLSI industry. If you are designing a system, that is a chip or something like that, that should be always object oriented, because there should be multiple variants of the chip. One may be high frequency operation, one might be power saving operation, and one might be RF application. So different variation of the chip would be there. VLSI industry, when you are doing something, it should be always object oriented. And large number of programmers from the multi-site, they will be operating. This is because today any of the VLSI company is operating like a MNC, and maybe you are sitting here coding from your cubicle which is in India. Someone in your team may be sitting at Seattle, someone may be sitting at Zurich. So this way the multi-site operation happens in today's VLSI scenario. When multiple people access the same set of data, it is better it is object oriented. If it is procedure oriented, it should have to be look from the 0th line of the code and they have to understand everything. But in object oriented programming, since they are dealing with one particular object, they need to get aware of the class and the details of the class, and accordingly they can do modification whenever it is necessary. So we are done here discussing all these points. So let's move on to the next slide. Object-oriented concept. In this slide, we will have multiple object-oriented concepts at a glance so that you can have this snapshot with you in your mind. So here are the different concepts. So class we have talked about, object we have talked about, we have to yet talk about all other. And remember, in object-oriented programming, all the concept, that means the class, object, abstraction, encapsulation, inheritance, polymorphism, they exist all together. That means they coexist. In case of you, when you are going through this episode, you have to learn them sequentially. However, you have to keep all of these concepts in your mind alive at any instance of time when you are writing or modifying an object-oriented code. All these concepts should be very clear. And now we are doing this episode for Python 3. So whatever you are learning in this episode, all the concept examples that should be ready. That means conceptually they should be ready in your mind whenever you are doing a Python 3 object-oriented programming. We will talk about the abstraction, encapsulation, inheritance, polymorphism one by one. Also, we will talk in detail about the class and object in upcoming slides. Here we have given one slide where we have given a snapshot of all the concepts those are necessary for object-oriented programming. And I must emphasize that all of these concepts coexist. That means we cannot have any concept individually outside the object-oriented programming. All are inside the object-oriented programming. Here you can see the entire black oval, right? That is the object-oriented programming, and all the concepts are coexisting inside that particular oval. You should be very much easy with all of these concepts before you start coding for the object-oriented programming. Here we are done discussing about these coexistent concepts, and let's move on to the next slide. Mental tussle of understanding object-oriented programming. I have kept this particular slide so that you can have a fair idea what type of tussle you are going to face in the upcoming sections. Let us get familiar with the mental tussle, and also I will give some tips so that you can overcome the mental tussle. So this is the world where we code in the object-oriented programming, like maybe C++, maybe Java. So there are a lot of object-oriented programming, right? And here we are having our object-oriented concept. So the tussle is to switch between these one concept to another and back to this concept. This is very tough. Although when I discussed using this picture a few slides back, it seems very easy, right? But however, when you are going to code, you will see that switching between the code and the concept is a bit hard at the beginning when you are at the learning level. Later, as you become familiar and get easy with the object-oriented codes, this will go away. However, here I assume that you are learning the object-oriented programming at the first time. So I have kept this slide that this is the mental tussle you have to face, and it's okay you are facing this. There's nothing awkward in facing this kind of tussle, and you should not blame yourself that you are not capable of learning object-oriented programming. So this is the mental tussle you are going to face until you get easy with the object-oriented coding. So this is true for any of the programming language which is object-oriented. Right now we are talking about Python. In case you go ahead and learn Java, you might also face the mental tussle will be here everywhere, and it becomes easy after certain time. You have to give some time to elapse and you have to keep on learning, and at some point of time it will be easy so that you can switch from code to the concept and concept to the code. So the switching will be faster for you, but for that you have to get familiar. You cannot be very faster switching in between the concept at the very beginning, right? At this moment when you are here in this slide, you will not have a very faster speed of switching between the code and the concept. You will get slowly familiar with the terms and coexistent concepts, and then you will be very easy. Once you learn all of them, you practice one or two codes. Obviously in this video I am providing all the code download links so you can try it at your end, do some modification and see what is the outcome. You will have the code download links in the GitHub in the description, and once you click on the link you will go to GitHub. From there you can download them. Now I think your mind is very much clear and you will going to have this kind of tussle, but the tussle is nothing that you would be afraid of. And let's move on to the next slide. Now, straightly we are coming to the definition of class. What is a class? Before popping up any point, let me say the class came from the classification, and classification means we are categorizing some of them, whichever it may be people, it may be animals, some of them with the similar kind of property, and the classification you know, and from there the word class is coined. So what is a class? Introduced first, the concept of a class lays the foundation for object-oriented programming. So it is the foundation, the class or the classification, right? It's the foundation of the object-oriented. A class is the blueprint or template that defines the attributes and behaviors common to all of the objects. So this is a kind of, say, blueprint, or you can say generic structure of the objects. So here all will be generic, and when we are instantiating objects, they will be having the specific type of data as per their own individuality. But the class will have a generic definition which is called the blueprint or the template, you can say, and it will have the attribute. Attribute is here mentioned as generic, and the attribute becomes specific for each of the object. It serves as a design for creating object. You can say it's a prototype. So from there you can create multiple objects. It defines a data structure that encapsulates data attributes, that is the attributes, and the function which are called method. So now we are going further specific here when we are talking about a class is a data structure. Data structure, now we started talking about the programming concept, and now you are having the switching between the two concepts, right? This line starts your switching in between the real world picture and the code, which I have just shown you in previous slide. So here the data structure, it encapsulates. Encapsulation we also talk about. What it encapsulates? The data, the attributes. Data means the specifications, and the function method. So these are the working method, and sometimes these are, in some programming language they are called function, in some programming language these are called subroutines, whatever it is. But this is the way the object is classified. That means the class is defined. In simpler terms, a class serves as the prototype for creating objects with similar characteristics and behavior. Objects with similar characteristics and behaviors. That means whoever the students of class 1 or standard 1, they will almost be having the same kind of properties. Their age, their mental capability, all these things. So this is very easy to grasp. And the next point is, object created from a class share the same structure and behavior but may have different values on specific attributes. When I have shown you the picture of the students in the class, I have pointed out there that each student is wearing different clothes and their hairs are different. Some have long hair, some have short hair, some have brown hair, some have black hair. So like that, even their eye color could be different. It may be blue, it may be black, it may be brown. So now let us see a code snippet of the class in Python 3. How to write a class? Say we are writing a class of dog. Now dog is the real world dog that barks, okay? And we are defining with the class keyword. You can see the keyword is in green. So we have code highlighted here. So the next one is the def init. You can see the def is a keyword, and then we have, I think, double underscore here, then init followed by double underscore, and then we write another keyword self, and then we write name and age. So self is there. It is also a keyword. You cannot change it. Name and age could be changed. Name and age are attributes. Self is for creating the object. Now self.name, that means the name of the object should be the name. So self.name, dot is a hierarchy separator here in the object oriented programming. When we are instantiating the object, this self will be replaced by the name of the class. Or this is a class, this is a generic name, it will be replaced by the specific name of the dog. So self.name, and that generic name here, the dog.name, will be feeded with the specific name. So this is the way the code is done. We have the self.age is age. So we have the object dot its attribute, and we have the proper attribute value. So name and age are attributes here, but here they will contain values. So it will contain string and it will contain numbers. This way you can write the class in object oriented programming in Python 3. So let us move on to the next slide. What is an object? Once the concept of class is established, objects may come into play. So we have just defined the class in the last slide. Now we can go ahead for the object. An object is an instance of a class representing a specific occurrence or realization of that particular class. Object encapsulate data and behaviors defined in the class. Encapsulation we will come later, and you can see the behaviors. That means the different variation of the attributes, those are captured. An object-oriented programming is a self-contained unit that combines data, that is attributes, and the functions that operate on that data. So it will have data and the function or methods, they will operate on the data. Why this encapsulation? Because you cannot access that data from outside without the methods. You cannot get any encapsulated data from outside. How? Let us give me an example. You want to know a particular name and the roll number, the class, the section of a particular student. How you can get? For that, you have to enter into the school, go into the class, talk to the teachers. Without that, you cannot get that data. So this is called encapsulations. From outside of the school boundary, you cannot get that data. So this is called the encapsulation. That means the protection of the data. Only if you follow some rules and follow some methods to get that data, you will get that data. Otherwise, you will not, from outside of the environment, you cannot get that data. This way, the data is either accessed by the methods, that means in the read operation, they can be read, or write operation, so they can also change the data. The student has a pocket money. Every day they come to school, right? A parent come to the school, say that he or she has mistaken to give the pocket money and gives that pocket money to the student. So this way they are modifying the pocket money attribute, right? After the student has reached the school, the guardian has come to the school gate and asking that whether that student has pocket money. The student comes and responds whether he or she has received the pocket money, so that she can or he can go back from the school using the bus or the transport. Objects are instances of classes in object-oriented programming. Instance is nothing but when we have a generic definition and we instantiate it on a specific, right? In a class, we have a student called John and we have Ram. So John and Ram are the two specific instances of that object called student or the class called student. It's not the object. Object is John and Ram and the class is student. Each object has a specific type defined by its class and can interact with other objects. Here another thing, the interaction, there should be a defined method. Without the defined method, they cannot interact. Objects are used to model real-world entities or abstract concept in a program, providing the way to structure a code, promote reusability, and encapsulate related functionality and data. So we have talked about this concept quite far enough and we are going forward, and you will now plunge into the code and you will see how the code is doing all of these things. And as I said that you will having the mental tussle to correlate the real world concept and the lines of code. It will be there inside you, and don't think that it will not be there. So it will be there. It will exist until or unless you become proficient in doing the object-oriented code. So at this point, if it is okay, if you are facing this mental tussle, it should exist. For some of you, it will exist in a more quantity, and some of you, it will exist in a lesser quantity. Okay, let's move on to the next point. In simpler terms, an object is a tangible instance of a class representing a specific entity or concept in the software. This is a very line that defines the code. Let us see the code. Now, remember we have defined a class dog in previous slide. Now let us create the object of that dog class. Now we have created a instance. So here the instance name is my dog. It's a data type, okay, where we are doing the encapsulation of the input data, where the name is Rambo and age is 3. So this is the class. So when we do this, right, the self keyword which is inbuilt transforms all of this given data into an object and store the data structure in my dog as an object. So once this encapsulation is done, you cannot read the data of Rambo or 3 from outside without having a proper method defined inside the dog to read this data from outside. This is the thing which is called encapsulation. Obviously, we may have some stricter version of the encapsulation. I am not going to that point. Rather than we are talking in a very simple terms up to this point, and we will go more complex as we move forward. And say you are inside the object-oriented programming environment. Each year or maybe each month, you will attain a different level of complexity, because the object-oriented concept is a concept can deal with a large complexity, but there should be a structural form of the complexity. Here we are done with this particular slide. Let's move on to the next slide. What is a method? As we have seen that methods are some tools to either transfer data from outside to the inside or from inside to the outside. Generally, this is the methods. So there could be other methods too. And those methods would be specific to a particular classification or class that you are writing and based on the objects which are required by the later part of the program. In the object-oriented programming, method is like a special set of instruction or rules that belongs to a thing, that is an object. And we define these set of instruction in the class definition and we use them when we instantiate them as an object. It is a way to describe that thing we can do and how it behaves. How it means how the object behaves. In various programming language, subroutine or functions inside a class or object are called methods. However, the methods or the rules may not be limited to subroutine or functions. They can go in case of any future development of the object-oriented concept in any of the shape or forms where these are rules or they are kind of methods which can deal or process the data. So up to now, when we are talking, these can be broadly said as functions or subroutines in a programming language. And let us move on to the next one. Methods help organize actions related to objects and they are like unique skills or abilities that an object has in a program. Now we have done talking theoretically about the method. Now let us see a small code snippet of the method. Let us define it. We are using the keyword def to define park and then we are giving self. So you can see the argument that is going to the function or the subroutine here is self and the name here is the park. And what we have the print statements. So self.name says woof. Woof is something a dog says when it barks. So this is one method we are defining. It's a simple thing. Let us learn the simple things first and then slowly you can go for the complex ones. This is what is called a method and how we define a method. Now let us move on to the next slide. Class and object example. So here we will continue our code. Start the code with #bang user bin python 3. This is our Python interpreter. Next we have class dog. We write the class which we have shown you a couple of slides back. And here inside that we have the def in it. Then we have self, name, age. And then we have the self.name. That means the attribute of name is getting the numerical value of the name. And here self.age is the age. So here it is a simple variable, but here it is becoming an attribute. So self.age, self.name, these are now attributes of this particular class. Now let us define the method def bark then self and we write the self.name says woof, creating an object of the dog class. My underscore dog, then we give the dog class and then we give the name Rambo and age 3. Now you can see this passes to this and this passes to this and here they are made attribute and the value is going here. Similarly here the value is going here to this attribute. This is happening automatically. Accessing attributes and calling the methods. So we print my dog name is my dog dot name. So this is what I told that whenever we put the dot, which is a separator, hierarchy separator, dot then name, this will access this value. Now self dot name is my dog dot name. So my dog is the object and object dot name. So we are having the object's name attribute printed here. Now it is no longer the simple name object. It has become the object's attribute. Now my dog dot bark. So we are calling the method. Once we execute this particular code in the terminal, this is happening. My dog's name is Rambo and Rambo says woof. First command, this one is saying that my dog's name is Rambo and here this is giving Rambo says woof. When this is called, the control goes back to here and this print statement is executed. So that is the very short and sweet example of class and object and the method. It's a very simple thing and it's highly relatable to the real world. Now let us move on to the next slide. Creating a class in Python, another example. Here in this particular code, we will create the code of a student who belongs to particular class. Let us see. Here goes our code. First line is our Python interpreter. Next one is we are writing class. Then we are writing student. So here we are writing the class student. The self word is the object constructor, right? And here we are writing the def, then double underscore, then init, then double underscore, self, then name, surname, then roll number. So each student will have these things. and then we make it as an attribute. So self.name, this is becoming attribute, and here we are storing the numerical value of the name. Next, we have the self.surname, and we store the alphanumerical value, whatever it is there for the surname. And here we are writing the self.role, the attribute, and here we are storing the numerical value of the role. So here it could be alphanumeric, or maybe a character, or maybe alphanumeric, or maybe character. This could be numeric, and they can be stored in the attribute. So this is where we are linking the attributes to the real world inside the class. This is the definition. Later everything is automatic, and once we declare it will automatic, all these things will happen. So here we define once and we use it multiple times. Method 1, definition, set name, tells that name, and what we do, self.name is name. Again we have to change the name, we can use this. Next, return 1, and method 2. Return was in nothing but it returns 1. We have a corresponding return value. Next we have the method 2, this is method 2, and we have def, then set surname, then we have the constructor else, and then we have surname. And here we have then start. In case we have to change the surname, so there could be some text mistakes in writing the name or surname. So these methods are there in real time to modify them, and we return 1. Next we continue the code here. We write method 3, def, set roll number, self.roll, and roll number. So there could be mistake in writing the roll number, and we can modify it using this particular method, and we return 1. Method 4, def display self. So display means it will display all the details, say name, surname, roll number. And what we have, body, we have print name equal to self.name, print surname equal to self.surname, print role is self.role. This will display it. So you can see this is the beauty of the encapsulation. From outside you cannot directly access the surname or something. You have to use a method either to store the data. That means here we have 3 ways of storing the data, 1, 2, 3, and here we define that time we are storing the initial data, and here we can modify, or we can print the data. Either input or output of the data we have to go through defined methods. So 4 methods are declared here. And object destructor is here. Destructor del, it is double underscore, then del double underscore, then self. Destructor is used for the memory optimization of the computer in which you are running the object oriented code. And destructor actually helps that whenever the usage of that particular object is finished, it clears all the memory. So memory is what? Some memory will be kept for all these, right? For that particular object, and all these memories will be cleared out by this object destructor. Don't think that object destructor is at last means that whatever we have written is going to destroy after this line. No, it's not that. When a real-time object is used and there is no longer use of a real-time object, the destructor will destroy the memory and the memory containing the data. Now here we have the print destroy is called from student.py. We are going to save this particular file as student.py. So I have named it here. Okay. When you are downloading this code from the description, you will also find that the student.py is there. So we are done here creating a class in Python for the very well-known concept of the student. Now let us move on to the next slide. We are done here. Creating an object of a class in Python. Now here we will create an object. So first here the code goes. Here we start here with the Python interpreter, and here we write if namespace is main. Now we are creating an object of the student class which we have defined in the previous slide. Student object is student, then we are writing the name Naga, then surname is Yamini, and we have roll number 112. Displaying the initial details, we say student obj, then display. Modifying the details, how we can modify the details. We write the object name, right? Student.object, then we give the method set name, then Ram. So we are changing it. Next, we are using the set surname method. Set surname Prasad. and you say set role is 112. You are changing the name. The name was written by mistake, so you are changing it. And here displaying the modified details. So here we will say student obj.display. So earlier one display method was called, and here another second time it is called. The first time it should give this data, and second time it should give this data. Once you execute the code, this comes. So name is Naga, then surname is Yamini, and roll number is 112. And in the next all of this display, we get name is equal to Ram. It is changed. Surname is Prasad. It is also changed, and roll number is unchanged, 112. And once this object is used and there is no longer use of the object in the entire code, so the destructor is called, destroy is called from student.py. So this is also a concept you should be familiar. You can use a destructor or not. It's up to you whether you are using a destructor or not. But in case you are using a destructor, right, in case there is a troubleshooting, you will get a print message at some point and you know that object has been destroyed. Based on the need, you can either use the destructor or you may not use the destructor. And you may have a message, you may not have a message. That is up to you. So it's up to you how you deal and how you do the code. Example is given to you. You can download this example from the link provided in the description, and from there you can go ahead and readily execute this code. You want to do some modification, you want to add some attribute, you want to remove some attribute, you can go ahead and do that. Remember, when you are adding or removing attribute, you have to synchronously do that thing in the class definition, which is in the previous slide or the previous code and this code. So the things should be in sync. So if you are out of sync, it will give an error. We are done here. Let's move on to the next slide. What is encapsulation? Now, after we are talking so much of the code and we have already plunged down inside the code, now we can talk about the encapsulation. With the introduction of objects, the concept of encapsulation evolves. So evolves, this is what I said. That means initially when the concepts was there, later the encapsulation or the data protection have been evolved over time. We are not going in the chronology of the evolve, how it evolved or what, but you know it is evolved. Encapsulation refers to the bundling of data and methods that operate on that data with a single unit. That is, single unit means a single instance, that is the object. Object is written here. Next, it helps in hiding the internal details of an object and exposing only what it is necessary. So that is the properties which I was talking about. The student's detail you cannot access until or unless you go through a proper method or proper channel, right? So that is called the protection or encapsulation of the data. Encapsulation in programming is like putting the data and the actions that work on that data inside a box, and that box is called an object. So now we are more on programming and lesser on the real world side. So I think the mental tussle is still going on in your mind, but however the mist is demystifying slowly. The mist of the object oriented programming is demystifying slowly. It's like having a container where you keep things and only allow others to interact with them in a certain way. So that is the protection. This helps hiding the inside details, making it easier to understand the change how things work without affecting the outside. Encapsulation is useful for keeping code organized, making it more secure and allowing it for easier maintenance. So once you write in this fashion, right, the entire code will be very much interaction free. Say one class is defined and the entire data structure of that class, whatever data mining you are doing with that particular class, is completely secure. It is not vandalized easily. There is no kind of local global concept here. Everything is encapsulated inside that particular class and object, and that data is not at all vandalized by any other part of the code. So data is secure inside the code and throughout the code, and this way the encapsulation helps the more efficient use of mining the data. When you are mining lot of data in the object oriented fashion, maybe in some database, that is also very easy and secure to store and access that data. We are done talking about the encapsulation. Let us move on to the next slide. Encapsulation code example. Here we will talk about the encapsulation example code in Python 3. Here we start our code. This is our Python interpreter. And next we have the class bank account. Now you will see the much more in-depth programming example of the encapsulation. Although earlier examples are quite good enough to understand the encapsulation, but here we are again give a more thorough use of encapsulation. we have def, we have then init, then self, then account holder, then balance. So you can understand this is about a bank account and the class is bank account. So we are inside the bank. We have the object here. Definitely one customer is the object whose bank account we are dealing with. So account holder here will be the name and the balance will be the money. Here we write self.account and holder, account holder. So this is called protected attribute. So you can see we have account holder and here we put a extra underscore. So this is called protected attribute. And here we have self, then double underscore, then balance, and we put balance. This is private attribute. This is much more detailed encapsulation we are going into. Earlier it was simple encapsulation. Now we are going towards a complex encapsulation. So this is called private attribute. We have double underscore here in the balance. And we have a method here, def, deposit, self, then amount. So the customer can deposit money in the bank. So what will happen? The self double underscore balance plus equal to is amount. So amount will get added to the balance. Next, we have a print command, deposited amount of rupees in the new balance is self dot double underscore balance then rupees. And next we have another method which is called withdraw. So a customer can withdraw money. So self and then amount. So we have here a condition if amount is less than self underscore underscore balance. So if requested amount is less than the balance that is remaining in the account, what will happen? That self dot underscore underscore balance is minus equal to amount. The amount it will get deducted from the balance. So for that balance should be greater than the amount requested. We print then withdraw amount of rupees, new balance is self dot underscore underscore balance rupees. Else, so in case the opposite happens, that either the amount is equal to the balance or amount is higher to that of the balance, what will happen? So it will print insufficient funds. Until or unless your bank account is a zero balance account, you will not have the privilege to withdraw all the amount. Generally, some amount has to be kept in the account in case it's a non-zero balance account. Now def get balance, then self. It will return the self dot underscore underscore balance. Let us go to the next slide. We continue the code here, creating an instance of the bank account class. Account equal to bank account holder name is Ram Ratan and balance is 5,000. What we do? Accessing the protected and private attributes. We try to print account holder account dot underscore account holder. And then accessing the balance using the get balance method, account underscore get balance. Depositing and withdrawing money. First of all, we print the name and the balance. Next, access the deposit method and we deposit rupees 500 and we withdraw rupees 200. The following line would result in error because the balance is private. The next line here, if we try to print, right, the account balance, account dot underscore underscore balance. So if we try to do that, it will account an error. Okay, yes, the data is private. Once you execute the code, this happens. First, we are using the account holder name. So name is coming here. You can see Ram Ratan here. And we are using a proper method, get balance. So we are getting the get balance. And deposited 500 rupees using this and the new balance is 5,500 rupees. You can see after this has executed, this line is printed. Because this particular method has a print statement also. Now withdraw rupees 2,000, new balance is 5,300 rupees. This is coming after this line is executed. And here, once you try to execute, right, once you try to access a private variable, it gives an attribute error. Okay, bank account has no attribute balance, it is private, so it is saying it do not have. And did you mean get balance? So it is proposing the method. So it is proposing the method rather than directly you are trying to get value. This way the encapsulation protects the data. Here we have seen a more tough example of the encapsulation. Through this example, you can download this example from the link provided in the description. From that link you will go to the GitHub and from there you can download the code. Here we are done. Let's move on to the next slide. What is inheritance? Now we will talk about the inheritance. You are slowly plunging deep inside the object-oriented concept as well as examples. So what is inheritance? Inheritance in object-oriented programming is like passing down the traits from one thing to another. That means a father has something, quality. The father can play a guitar. So the son also can play the guitar in case the father has handed over the knowledge. This is called inheritance. That means handing over something. It could be knowledge, it could be money, anything. That is called inheritance in real world. Now in programming, we will see the programming counterpart of the inheritance in object-oriented programming. Building on idea of classes, inheritance is introduced to promote code reuse and organization. So this is because code reuse. That means we don't have to define each and everything. If we have inherited from some other code, that will be used as is, and that would not have to be defined twice in the subcode, or here you will see the subclass. Inheritance allows a class to inherit properties and behaviors from another class, that is creating derived classes. It establishes the hierarchy where the subclass inherits the characteristics from superclass, fostering is-are relationship. This is the thing, that inheritance is coming from one to the another. Generally, there will be a superclass from which we define a subclass, and the subclass will inherit some of the qualities of the superclass, not all of the qualities. It depends upon the coding and what you are allowing to be inherited. The class that gives its trait is called parent or superclass, and the one which is receiving the traits or the attributes or qualities is called the child or subclass. So it could be a parent class or superclass which is handing over some of the inheritance to the child or the subclass. This helps in reuse of the code and build on existing data structures. So the code reuse is nothing but something which you have written once can be reused without explicitly rewriting the code, and that is achieved by the inheritance in terms of the parent class and the child class, or the superclass and the subclass. This way code is reused. That means the methods, the attributes, anything whichever written can be reused in the object-oriented programming. Creating an inherited class. Now let us see the code here. First line, class, then intern, then student. Earlier we have defined a class student, and here we are defining a subclass or child class which is called intern. The parent class or the superclass is student. Earlier we have defined student. Now intern. Let us see what are the changes here. Constructor of the child, def, init, self, then name, surname, role, company. Any student who may be doing some internship will be related to a company. So this is some additional info. The rest of the things will be inherited from the previous one. Next, super, then init, then name, surname, role. So you can see we are not writing this code again. Rather, we are inheriting from the superclass. You can see super is here, then init, then name, surname, roll number. So it will go to the parent class and do all these kind of initiation of the attributes and come back to here. Next, only the thing extra we are having here is the self.company, and the company value will be, this attribute will be written here. Don't worry, all these codes are provided for download, and the download links are provided in the description, from where you can go to the GitHub, download the codes and do all the code experiments and modification, whatever you want. Or in case you want to just run and see the output, you can do that also. You don't have to write down, you can just download it. So here def display then self. So you can see the super.display calling the parent inherited method. Again, we are using the super attribute here to call the display which was defined earlier in the previous class or the parent class. Okay. We are directly calling that one using the super. The super is the keyword that actually helps to connect back to the parent class or the super class. And here we are using the print for the extra attribute, the company, and here we are writing self.company. And here If-Elif-Else, so that is a destructor, right? And destroy is invoked from intern.py. So we are saving this as intern.py. We are done here defining the inherited class. Now here in this slide we will be creating object of the inherited class. We have defined the inherited class, and now we'll instantiate an object or more than one object of that particular inherited class. So here starts our code. First line is hash by user bin Python 3. If namespace is main, then creating the object of the intern class. Intern obj is intern, then we write naga, then yamini 112 and stm. So this is the company name which is extra from the previous one. This student has got an internship in this particular company. We are giving it here. displaying the initial details. So intern object dot display, if we write this right, it will print all these details which we have just given through the object creation. Modifying the details. Intern object, then set name, then Ram. Okay, we are changing it. And then we write intern object that set surname is Prasad. Set roll number is 114. So we are modifying all these things. And we are modifying the company also, Xilinx. So you can see this modification is happening similar to the previous example when we have used the object, not the class. So the class is handshaking one with the parent and the child class, or the super class and the subclass. They are handshaking in between to their internal methods to the super keyword, right? And when we use it as an object, we operate it in a very similar fashion that we have done earlier in the parent class. And here displaying the modified details, call the display method. So here the display method is called first time when all this data has been given as an input, and after this modification again this display has been invoked. Once we run this code, first we can see that this was the first set of data and this is the modified set of data. So you can see that it has changed to this has changed to this, and this has changed to this, and also this has changed to this. So we can operate very easily in a very similar fashion. However, the attributes are dealt, or we are dealing the attributes in the very similar fashion of the parent class, same as the child class. But however, the parent child, the code we use is happening through the super keyword. We are done here with the example. Please go ahead and download these codes and run at your end, and let us move on to the next slide. What is abstraction? Now we will go further and learn about the abstraction. This is another very important concept in the object-oriented programming, and let us start. Abstraction in programming is like simplifying models to represent complex things. So as I have said that object-oriented programming from by birth, it is designed to deal the complex object. But abstraction is something that will make much more simpler as per of the look. As classes and objects become more sophisticated, the concept of abstraction is introduced. So abstraction was needed. As I said, the object-oriented programming evolved over time. This abstraction is introduced to make things simpler. Abstraction involves simplifying complex systems by modifying classes based on their essential properties. Abstraction is nothing but here we have a complex data, and we are redrawing the data with much more simple concepts or simple shape and size. The complex data we have and we are giving it a simple shape, that is called the abstraction. It allows developers to focus on relevant features while hiding the unnecessary or surplus details and complexity. That means you should be focused enough to deal with the problem and not the detailed data which is coming with the problem. So you will find a solution for the problem, and that will deal with the data which is related to the problem. This is called abstraction, and this is very programming related concept, and you cannot just relate with the real world. So now we are going further deep diving inside the programming concept of the object-oriented programming. So you should be very much aware how the object-oriented programming concept begin and how it was formed. We have so far discussed, and now from this slide we are diving deep and you think in terms of the programming aspect to deal with the data complexity, because the data complexity does not visualizable in real world, and the data complexity can be visualized only when you are writing the codes. So don't try to relate it. However, if you are able to correlate, it's good enough. In this programming concept is very much needed in object-oriented programming. In simpler terms, abstraction helps us to understand things without getting into the vivid explicit details. Here, the main motto of the abstraction is to make complex set of data into a simple structural format and feed it into the object-oriented programming class and object and all other aspects of the object-oriented programming. We are done here discussing about the abstraction, and let's move on to the next slide. Abstraction example. That is the code example, the codes, and in the right hand side we will be explaining the codes. So the pink box contains the codes and the yellow box contains the explanation. First line is our Python interpreter. Next we have from ABC import ABC and abstract method. The ABC is a predefined module in Python and we are importing that. You know about this defining styles from the module in Python episode. And here we are giving the definition. ABC is a module in Python standard library that stands for abstract base classes. ABC is a shorter form of the abstract base classes. This is much more complex programming concept rather than the very easy things that we are correlating. And here we have defined a particular module of ABC. ABC is abstract base classes. It provides the ABC class which you can inherit from to create an abstract class. For abstraction, much more in a programming way, you can use this. So here goes our abstract class. We have the class shape, and here we keep it as a ABC. So the ABC which we have imported will take care of this. And here we have defined @abstract method. So abstract method we have already imported here. @abstract method is a decorator that is used to declare abstract methods within the abstract classes. So we will define a method that will be very much abstract and that will not be very specific. Okay, let us see how. Def calculate area self. Okay, so self is the object constructor, right? So here we give the pass. So we are not writing anything and we are passing it. Pass is another keyword which passes of any definitions. Here you can see we have defined the prototype of the calculate area, but we have not written any code and we are using the pass statement to pass from here. In this case, the calculate area method is the shape class is marked as abstract. This shape is abstract now. This is the abstract class. Now, the calculate area method in the shape class is defined without any implementation using only the pass statements. We have not defined any methods to calculate the area. Let us see how we will do it later on. Concrete class implementation of the abstract class. So now we are becoming specific from the abstract, and now here we are writing a class circle. Now the shape is a circle. Okay? Now you can see this shape we are passing here, and this is a circle. New class is circle, and this is a specific class, not an abstract class. Now def init self then radius. So we have to give the radius, right, of the circle. And we write self.radius is radius. So that means we are attributing the numerical value as radius. This method is meant to be overridden by the concrete subclass. Now calculate area. Now we are making the abstract definition which was here in a specific manner for circle. What we are doing, it will return. Now the pass statement is not there. Instead there is a return statement and 3.14 into self.radius into self.radius, that is pi r square. Pi is 3.14 value and the r square, that is the radius square, is self.radius into self.radius. So this gives the circle area, and the area will be in a square unit. So you can see we have defined the abstract class here, and then we are defining a specific class here, and here we are giving a specific area calculation in the method which was earlier an abstract method. So abstract method here we are defining with the abstract method keyword that we have imported. So this way the abstraction is created in the object oriented Python programming. We go further in the abstraction, right? Another concrete class is there. You can see the square, okay, and we give the shape which was the abstract class here, and we give the side length. So square have 4 sides and 4 equal length. Here we give the self del side length is side length, and here we are attributing the numerical value of the side. Then we have the def calculate area, and now we are having a specific definition instead of an abstract definition. Here return statement is there instead of pass, and here we write self.side underscore length into self.side underscore length. That means the length square. So that is the area of the square. The length of the side, we make it a square, it will give the area, and that is we are calculating using the calculate area. For circle it is having one type of area, and for square it is having another type of area, right? Now let us use this. We define a circle object as circle and radius equal to 5, and we write a square, then square side length equal to 4. And here we print area of the circle, and we will get the area here with this particular circle calculate then area. Okay, so using this method, okay, and similarly we will get the area of the square using this method. Once we execute this code, so you can see that this value which we provided is helping to get the area using this method, and the result is coming as the area of the circle is 78.5, and similar way the area of the square is calculating as 16. So please go ahead, download this code from the description. Once you click the link, you will go to GitHub, and from there you can download the code or copy the code. So here we are done. For the abstraction example, you can see we can define an abstract class, and then we can define specific class. Complexities may grow more. Say if you are trying to define a rectangle area, right? In case you can add, you add it in the similar fashion and you calculate the area. So the complexity will grow. If you want to calculate the area of a cylinder, right, there will be two circular surfaces and there will be a cylindrical surface. So this way the thing can go on, the complexity can grow bigger, but the thing is that the abstraction is helping the complex thing to stay simpler. However, from object to object, the complexity may grow high or grow less. The actual class, that is like square or circle or maybe rectangle or maybe cylinder, in that case you will have the specific complexity of that particular type of class. But in the abstract class, everything is very simple. We are done here. Let's move on to the next slide. What is polymorphism? This is another good concept of object-oriented programming. The polymorphism you should know in very attentive way. Polymorphism is the context of object-oriented programming, comes later in the evolutionary timeline. So it has came as the object-oriented programming evolved. It refers to the ability of objects to take on multiple forms of the ability of different classes to be treated as instances and of the same of the class through a common interface. This is called polymorphism. It allows us to use a common method name, but depending on the situation, it can do either different thing or the same thing in different way. So polymorphism is nothing but case to case, the object to object, one method maybe. Let us take an example. One method may behave differently. That is called polymorphism. So we'll go for explicit codes, don't worry. Simply, it is a way that any method have ability to non-biological mutation capability. So why we are saying non-biological? Because when we talk about mutation, right, we will have the concept of biological mutation. But no, it is not a biological mutation. That is what I was saying. From one object to another object, it may have different kind of behaviors. Okay, so this is called polymorphism. So this is also there to accommodate the complexity of the object-oriented programming that is we are doing nowadays. From the original object-oriented programming concept that was during its birth, these complexities got added, and now at present day we have all these concepts and to deal with the complexities of object-oriented programming. So this is nothing but a non-biological mutation capability of any of the method that is defined inside a class. Polymorphism example. Let us see an example here. And in the right hand side, we will see the explanation. So the code will go here in the pink box and the explanation will go in the yellow box. First line is our Python interpreter. Next we have class animal, and then we define make sound. This is the kind of voice the animal will do. Okay. Then we keep it as pass. Here we are not defining anything. We have a base class animal with a method make sound, which is marked with the pass statement, indicating that it is meant to be overridden by the subclasses. So in the subclass, what we do, we write a dog, which is a subclass of animal. Okay. And in that particular case, what we do, a make sound is correctly defined. We return oof, the dog sound oof, and that is then. For cat, which is a subclass of animal, we define the make sound as meow. And for a bird, which is a subclass of animal, we define the make sound as tweet. So the dog says woof, the cat says meow, and the bird says tweet. All these things, you can see that the subclass, the particular method is overridden. That means it is dealing with the complexity, right? For each of the cases it will encounter. This is a very simple example, you can understand, right? The subclass dog, cat and bird inherit from the animal class and provide their own implementation of the make sound. So make sound cannot be defined at the beginning. In this real world case, if we define animal class and the sound has to be modified in each of the subclass, we cannot make it here in the parent class. So the subclass we have to define it. The function animal sound takes an object of the animal as a parameter and calls the make sound method on the object. We continue here. The pink box will contain the code and yellow box will contain the explanation. Function demonstrating the polymorphism. So def animal sound, which we have just talked in the last slide. And here return animal.makeSound, creating instances of different classes. dog, then dog, cat, then cat, bird, then bird. So you can see the class is here. It is, the first one is capital, the other two are small. So here it is small. So you can even name dog 1, dog 2, cat 1, cat 2 also you can do that. When we create the instances dog, cat and the bird and pass them to the animal sound function, polymorphism will come into play. So here we have defined the polymorphism of this function animal sound, and it will pass on to the make sound. So earlier we have defined the make sound for that, right? The appropriate make sound method of each of the object is called based on this actual type. So this selector or thing that whatever there is a polymorphism, but it has to select the correct one, that is done through this programming. Using the common interface make sound with different objects. Okay. Print animal sound, then dog, it outputs woof. Print animal sound, then cat, here it outputs meow. Animal sound, then bird, outputs tweet. Now have a careful look. These dog, cat and bird are objects and not classes. In classes we have defined each of their respective sound, and here since we are dealing with here this animal sound, right, it is actually helping the polymorphism, and this is polymorphism example. So you should take your time, spend time on this and understand this. This is different from the abstraction example that we have given earlier. Okay, here one particular decisive function is there which actually routes to the correct object and correct function. If you pass on that particular animal, right, here we are giving the animal as a class, right, and if you give that particular animal, it will call that particular animal sound. So you understand carefully code, maybe you spend some time with the code. This code is downloadable, and once you execute this code, you can see this first one gives woof, the second one cat gives meow, and the bird gives tweet. So this is coming as output. You can go ahead and download this code from the download link provided in the description. So we're done here. Let's move on to the next slide. Now here we do a specific comparison of object versus module. This might be good for you because when you are facing interviews, right, this kind of things may come, that what is the basic comparison, they say similarities and difference between the module and object. Start comparing here. Earlier we have learned the Python module in the last episode, and this episode you have learned the Python class and object, right? So let be there a side-by-side comparison. A module is a file containing Python code. It can define function, classes, variables as well as runnable code. An object is an instance of a class. A class defines a blueprint of the object and specifying attributes and methods that the objects of the class will have. Now, this is the definition. We write the definition of this and definition of. First, we compare the two definitions. Module has a plain code and the Python class is a concept. So you can understand these two. Purpose. Now, let us see the difference and similarities of their purpose. Modules are used to organize code into reusable, manageable units. They help avoid naming conflicts, provide code encapsulation and support code reuse. Objects are used to model and represent the real-world entities in a program. They provide a way to encapsulate the data and behavior into a single unit. So you can see that there is a bit similarity between the module and the class and object. However, these two are a bit different. Both are targeted toward the code reusability, but in different fashion. Object-oriented programming in Python can deal with a large and huge amount of complexity, but module, I think, is for the much more simpler kind of data handling. The object itself is by birth is to deal with the much more complex data. As you have come across all the concepts, all the 6-7 concepts that coexist together in object-oriented programming, now you can be able to correlate and differentiate the module and the class. We are done in this slide. Let's move on to the next slide to see some more comparison. Here now we compare for the organization. Module provide a way to organize and structure your code. Class and objects allow you to organize the data and behavior within your program. It's just about the code and it's about the data that the code is dealing with. The class and object is about dealing with complex data and the concept. The module is just for the code, the reuse and structure of the code, the segregation of the code and the encapsulation of the code. So module does that, but Python class is having a much more higher capability. Scope. Modules provide a global scope for function, classes, and variable. Objects, on the other hand, they have their own scope and encapsulate the data behavior within the scope. So this is a strong data protection. You can see that the module, if it is instantiated, called, it can have either global or local scope, but the object and class, the data is much more secured and it is handled in a much more strict manner. Instantiation. Modules are not instantiated. They are typically imported as a whole. That means we do not have an instance of a module, rather it is imported. That means it is taken as a copy. Objects, on the other hand, are instances of the classes and must be instantiated using the class constructors. There is a fundamental difference of calling the module and calling the class. Calling the class is object, where we instantiate the object, and with the object all the set of data and methods are instantiated. But for module, it's just about code. So even we do not bother that module could be a procedure oriented code, but object oriented code, there could be mixture of both. Some of the methods may contain the procedure oriented code inside the object oriented code, and it's a very complex structure as compared to the modules. Modules are used to organize and group related code. So module are for code organization and code use. Simple as that. So it can be for even procedure oriented. But objects are used for model and represent individual entities with specific characteristics and behavior. So the usage of object and class is much more targeted, rather than module is much more generic. Module is a very generic concept and object and class is much more specific concept. Module can deal with simple amount of data, but the object and the class, they can, that is the object oriented programming, can deal with a huge large complexity in terms of abstraction, in terms of polymorphism, and all the concept that can coexist together inside the object oriented programming. So here we are done comparing object and module side by side, or class and module. Okay, so here I may write class or object, but however class or object means that one is the definition, another is instantiation, so please don't get confused. So we are done here. Let's move on to the next slide. Summary. Let us summarize in this slide and the upcoming slide about whatever we have learned so far, so that the entire concept is now jotted down into your mind. Class. In Python, when you declare a class, you are instructing Python to create a blueprint of a new kind of object. The object and the class will contain set of data, that is called attributes, and also some methods which will be used either to write or read those data or do some modifications to the data. Object. This term in Python has dual meanings. It can refer to the most fundamental type of entity, and it can also denote any instance of the particular type of class. So this is a fundamental type of entity, because Python from birth is a object oriented programming. Its structure from the beginning is object oriented. Hence the object is a very fundamental entity in Python. After you learn the object oriented concept in Python, then you look back to the Python codes you have done so far, and you will see the small touch of the object oriented programming there. The dot operator, I give you a hint, and rest of the things you can find out yourself. Instance. When you use a class to tell the Python to create object, the resulting object is called instance of that particular class. Instance. These are terminologies. We are making familiar with the terminology. So object and instance means that we have instantiated the class in an object. So these are coexisting concepts. Def. In Python, def is used to define a function, especially when you are doing so with the context of a class. Self. Inside functions within a class, self acts as a variable representing the instance of the object currently being accessed or manipulated. So def is defined for a function or a method, and self is the object constructor we have come across. Inheritance. This is the concept that a class can acquire characteristics or traits from another class similar to the individual inherits from their parents. So this is the things we have learned. Now let us go to the next slide of the summary to get much more details of the concept. Composition. The concept revolves around the idea class can be constructed or composed using other classes as component, resembling how a complex object like a car can be built using individual parts like wheels. So this is called composition. We have not given any example of this, but the object-oriented programming does have this concept. attribute. Attribute in Python classes are properties that arises from the composition, often taking form of variable associated with the class. And in real world, the attribute to a person or a student, maybe it's hair color, maybe it's eye color or skin color, like that thing attribute. So in the similar way, attributes in the Python objects are nothing but variables containing different values or different properties, which are also known as attributes. Is a. The phrase is used to express that one thing is subtype of or inherit from another. It is saying a hilsa is a fish. A fish is a class and hilsa is an object. So is a concept is connecting an object with its class. Has a. The phrase indicates something is composed or processes from other traits. Say, Hilsa has a fin. So the attribute getting connected with its object using a has a. So attributes are connected through as a, and the object and its class is connected using is a. So these are the concepts you may find in text, in maybe you are reading a book or something like that, or you are maybe reading an article in the internet. Here you can find all these concepts. Or in your company you may have some code with some comments which are using these words. So that's why we have summarized all the things that we have learned in today's episode. We are done here. Let's move on to the next slide. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below. And bye for today.